Welcome friends and thanks for joining my course. My name is Nitin and I am certified cloud architect both by Google and AWS. Thanks for providing me an opportunity to help you learning about Google Cloud Platform, which is one of the fastest growing cloud platform. Objective of this course will be to help you in passing Google Cloud Associate Engineering exam. So this course will cover all the Google Cloud services required to make you Google Cloud Associate Engineer. So first thing is, why should anyone go for this exam? Getting cloud knowledge will definitely boost your resume and it will open many opportunities for you in cloud computing space. Since Google is doing great investment into its cloud solutions, so there will be many opportunities available for the people who knows about Google Cloud. Now, what all things we will learn in this course? In this course, first we will cover what is cloud computing and why it is getting so popular these days. Then there will be some introduction about Google Cloud, where we will talk about its growth pattern and some of its features. Then we will discuss about how Google Cloud is different from other cloud providers. In this course, I will be showcasing various demos which will help you in learning in more practical way. In this course, we will learn about various Google Cloud services and how to use those services. I will also explain when a particular service should be used and when it should not be used. So let's start learning all these things one by one. I know that cloud computing is a very common term nowadays. So first we all must understand what is cloud computing and why it is so popular these days. What kind of problem does it solve? In my opinion, cloud computing is delivering computing service over internet using pay-as-you-go model. Compute service here means any hardware or software that you need to run your application. What all things do we need to run our application? We need various services for running our application, like we need compute server to host the application. These are the actual physical machine or virtual machine where we will run our applications. Traditionally, when we try to build and run any application, what do we think about? We need to worry about how we will provision all these services for our application in our data center. Provisioning all these services in your data center and its regular maintenance is really very costly and difficult. There used to be very high upfront costs to set up all this infrastructure in your data center. Still, right sizing of all this is really a challenge. Mostly, we end up buying resources by keeping peak demand in mind, even though peak demand happens just for the limited amount of time. For rest of the time, machines are not fully utilized. Every application requires some kind of storage. It could be a RAM, local disk, or network attached storage in your own data center. Based on the type of application, we need to provide these storages. Let's think what kind of challenges could be there if we are moving our application to cloud. If we are migrating our application to cloud, we need to think about how we will migrate our data to cloud. What services do we need to migrate this data? How much time will it take to move data to cloud? What cloud storage option will be best fit for our use case? How can I manage the storage cost? What will happen to my data in case some kind of failure? No enterprise application can avoid use of database to store the application data. We might use different type of databases based on the use case. It could be SQL, NoSQL, or it could be cache. To store relational data, we use RDBMS like MySQL, Postgres, or Oracle. To store some kind of profile information, we would like to use some kind of document-based database like MongoDB. For frequently accessed data, we can optimize data retrieval by using cache like Redis cache. For all kind of database maintenance activity like taking backup, applying security patches is always a pain. We need expert DBA to tune your database as per the application requirement, which is not easy to find. Every application has to struggle with database scaling as the business grows. Networking is also a very important aspect of our application deployment design consideration. We need to set up proper networking and security in cloud data center. While doing cloud migration of any application, we have to think about how we will do the load balancing. Do we need CDN or not? Will I incur any kind of charges for the data for ingress and egress traffic? Do I need to pay anything for setting up the data center? How can I access my on-premise resources from cloud network? How hybrid networking will take place? What are the SLA provided by cloud vendors for any critical application? How can I build fault-tolerant application in cloud in case of data center failure? Setting up infrastructure for applications related to data analytics and machine learning in your own data center is not an easy task. Such applications need both high computation and high memory. Setting up such cluster is very costly and require expertise in dealing with distributed system. Buying such an expensive infrastructure for jobs which might not run continuously and have very dynamic scalability requirement is not a good idea. After executing few jobs, whole infrastructure might sit idle, which will not be the optimized use of resources. Creating a in-house machine learning model for very commonly used services like image recognition, speech-to-text conversion is not an easy task because of the lack of data availability. We definitely need monitoring and alerting service to track what is happening inside our system so that we can take required corrective measures on time. We normally need monitoring to find performance bottleneck in our application. We also need to check if our servers are reaching closer to the defined threshold value. We need such alerts to take the corrective actions, like sending an alert to some admin, or we can also trigger some kind of scaling based on this threshold. Setting up such alerts helps in keeping application live by triggering scaling up of the application or database servers. If resources usage goes below the minimum threshold, we would like to free up some resources so that we can save the cost and utilize resources in more optimized way. We also need to use CI/CD pipeline to bring efficiency in our processes. These processes make us feel more confident about the quality of our application delivery. And this list is quite big. Here we have discussed some of the challenges that we need to consider if we are planning to move our application to cloud. Next, we will talk about some feature of the cloud solutions, how cloud providers can address these concerns. So let's move to next video. Let's discuss some of the benefits of cloud and how does cloud can answer our concerns. Cloud solution provide many benefits. First benefit is flexibility. User can scale services to fit their needs. Users can customize application and access cloud service from anywhere with an internet connection. It provides flexibility in various ways like cloud infrastructure scale on demand basis to support the fluctuating workload. We can do both scaling up and scaling down of the resources based on requirement. Users can choose public, private or hybrid storage offering depending on the security need and other considerations. Cloud provide various storage options similar to on-premise data center. User can choose both type of storage and size of storage as per the application requirement. Organizations can determine their level of control while choosing any cloud service. For more control, we can choose infrastructure as a service option like virtual machines. It gives maximum control to user over the resource. User can also go with software as a service or platform as a service option. Choosing any of these options mean less maintenance pains but with limited control. Users can select from a menu of pre-built tools and features to build a solution that fits their specific need. Various tools and services exist in cloud to manage your code, deploy application, monitoring and alerting, and for other use cases. We can also create our own virtual private cloud, which is very much like our own data center in cloud. Customer managed encryption and API keys helps in keeping the data secure in cloud. Data in cloud is very safe as the industry standard security practices are followed in cloud-based solutions. Another advantage of cloud is efficiency. Enterprise can take their applications to market quickly without worrying about the underlying infrastructure cost or maintenance. Cloud-based applications and data are accessible from virtually any internet-connected device. Developing in the cloud enables users to get their application to market quickly. Users can focus more on developing the business use case rather than spending too much time on infrastructure management. Hardware failure do not result in data loss because of the data backup in network. Cloud follows pay-as-you-go model, which means users only pay for the resources that they use. Cloud computing uses remote resources only as much as they need. It saves the cost of server and other equipment for the organization. Using cloud also has strategic advantage. Cloud services give enterprise a competitive advantage by providing the most innovative technology available. Cloud service providers manage underlying infrastructure for us. It enables organizations to focus more on application development and other priorities. This gives organization a competitive edge over its competitor who must devote IT resources to manage their infrastructure. Cloud service providers regularly update their offerings to give users the most up-to-date technology. Since cloud services are easily accessible from anywhere in world via internet, teams can easily collaborate from widespread locations. So far, we have learned about what is cloud computing and what are its advantages. Now, let's talk about why should we learn Google Cloud. Google Cloud is continuously expanding. Just look at this graph carefully. Percentage of Google Cloud share is continuously increasing. In 2015, it was just 4%. In 2020, it is expected to grow beyond 15%. Google is doing heavy investment in its cloud infrastructure continuously. So, number of opportunities are also increasing proportionately. Also notice the revenue growth chart of overall cloud business. It's a billion-dollar industry in current time and it's growing year on year basis. So it is very good time to learn Google Cloud as it will help you in your career growth. See, knowing things and proving that you know something are two different games. If cloud certification is attached with your resume, then definitely your resume will stand out as compared to person who just claim that he or she has the cloud knowledge but do not possess any certification. Having a certification also helps in getting business for your company because most of the IT companies, while bidding for any project, they can showcase how many certified people are there in their organization. If you have cloud certification, then definitely you can help your company to get more business. Now let's talk about how Google Cloud is different from other cloud providers. There are some differentiating factors about Google as compared to other cloud providers. Google security model is end-to-end process. Google is always focused on keeping customers safe on Google applications like Gmail and Google Apps. With Google Cloud, your application and data take advantage of the same security model. In Google Cloud, compute engine instances or virtual machines are charged in 1 second increments with 1 minute minimum. So you do not need to pay for the compute minutes that you do not use. Google is pioneer in innovating technologies like Hadoop MapReduce, Bigtable, or machine learning. It provides state-of-the-art data processing and data analytics tools as its big data offering. Google Cloud Big Data Analytics solutions are serverless, which removes the complexity of building and maintaining a data analytics system. It enables faster data analysis for its customer. Google Cloud's power is in its network, which sets the Google Cloud hosting apart from some of the other cloud players. Google Cloud Network is one of the biggest networks in the world. Google's backbone network uses the advanced software-defined networking and edge caching services to deliver fast, consistent, and scalable performance. Also, Google Cloud Data Center run on half of the energy of a typical data center and run on 100% renewable energy where available. We will learn about all these things in more detail in this course. Hello friends, so far we have covered cloud introduction part, where we covered what is cloud and why to use cloud computing. Now it is time to learn about GCP platform. As part of this, I will show you how to create Google Cloud account and log into Google Cloud Console. After login to Cloud Console, I will give a demo of console walkthrough so that you become familiar with Cloud Console. I will also cover geographic distribution of Google Cloud. Here we will cover terms like region and zones, and we will discuss how to decide when to use regional or a zonal service. I will cover overview of GCP services. Here I will discuss for which kind of use case particular GCP service should be used. I will also showcase how we can interact with GCP. What are the possible ways to interact with GCP? So let's start with how to create Google Cloud account and log into Cloud Console first. Now in this demo, I will show you how to create a Google Cloud account. But before you create a Google Cloud account, just make sure that you have a valid Gmail ID. It is a prerequisite to create a Google Cloud account. To create your first cloud account, just open your browser and open the URL cloud.google.com. On this page, click on this button to create your first account. Here you need to select your Gmail ID and enter the password. Now click on Next. On this page, you need to select your country and accept the term of service. If you are creating your free trial account, then Google will provide you $300 for free, which you can use to create resources in GCP. You cannot do any other shopping from this amount. You can use this credit for limited period only. Now click on Continue button. On this page, make sure that your account type is individual because we cannot create free trial account with business account type. Then here you need to provide your tax information. Next, here you need to provide your name and address detail information. Google also need credit card detail to create your account. Google need this information just to make sure that you are not a robot, and this card will only be charged if your free trial account is converted into paid account manually. Once you fill up this whole form, then you need to click on this button. Once you click on this button, your account will get created, but it will take some time for your account to become active. So just go and create your first cloud account. In next demo, I will show you how to log into Cloud Console, and we will do a walkthrough of Cloud Console. In previous demo, we learned how to create Google Cloud account. In this demo, we will do a walkthrough of Cloud Console. For this, first open this URL in your browser console.cloud.google.com and log in with the account which you created in last demo. After login, you will see this page, and this is the Cloud Console dashboard. Now let me show you what all things you can do here on this dashboard. So on the top of this page, you can see your remaining free credit balance in your local currency, and it will also show you how many days of free trial account are remaining. Just keep one thing in your mind, that if you click on this activate button, then your account will get converted into paid account. So do not click on this button. You can hide this by clicking on dismiss button. If you want to see this bar once again, then click on this icon. and it will show the same bar once again. So let me dismiss this bar, and this is the Cloud Shell icon, and I will create a separate demo on this to showcase how to use Cloud Shell. This is the help icon. Here you can see various kind of help like cloud documentation, some kind of a tutorial or a keyboard shortcuts. You can explore this on your own. This is the notification bell, and you can see any kind of notification in cloud over here. Currently there are no notification in cloud, so nothing is appearing over here. From here you can select your preferences. Like here you can change your preferred language, date format, time format or number format. Under communication, you can configure how you want to be notified for certain events. Like here, you can decide how do you want to be notified in case of any error. You can choose to be notified either by email or mobile. Now let's go back to the dashboard once again. On this dashboard, you can see various kind of cards or you can say widgets on this main page. You can play around with these cards by moving it anywhere like this. If you want to hide some card, you can do that as well. Just click here and hide the card. If you want to do more customization for this dashboard, then click on the customize button. Here also you can play with the card in the same way. Like you can move this card. If you want to show some hidden card, then you can do that as well. Once you are done with this customization, then click on the done button. This is how you can play with any card on the dashboard. Whenever you create a Google Cloud account, then one default project and one default billing account is also created for you. And this is my default project. You can check the detail of this project by clicking over here. Here you can see project name, project ID and project number. You can change your project name anytime, but you cannot change the project ID and project number once your project is created. Any resource that you create in Google Cloud must be under some project, and that resource will be built under that project only. And each project is associated with one billing account in GCP. There is one shutdown button over here on the top of this page. If you click on this shutdown button, then this entire project will be shut down and all the resources within this project will also be shut down. If you want to create a new project, then click on the new project button. Here you can give any meaningful name to your project. You can also change the project ID for the first time at the time of project creation. And this project ID must be unique across whole Google Cloud. Here you can see some quota limit as well. Your free trial account has some limits on how many projects you can create. Currently, there are 10 projects remaining in my free trial account. Now, if you click on this create button, then this new project will be created for you. Now, let's go back to Google Cloud dashboard once again. Now, let's look at the billing information as well. To look at the billing information, click on the billing option here. Here, if you click on this view report button, then here on this page, you can see your current bill and forecasted bill for the current billing month. Currently, there is no resources created in my GCP, so nothing is appearing over here. If you want to see your bill for some other time, then from here you can change the date range as well. Here you can see your bill at various level. By default, it will show you the billing information by doing the grouping based on the project. But if you want to see your bill in a different way, then you can select the different options from here. Like from here, you can see the billing information based on the service. Now let's check the payment profile. Here on this page, you can check the payment profile of this billing account. Like here, you can check the credit card information associated with this billing account. And from here, you can make the payments for your bill for this billing account. From here, you can export your billing information. Now, let's go back to dashboard and let me show you how to select any service in Cloud Console. To access any service in Google Cloud Console, just click here. And in this list, you can find any service available in Google Cloud. Like if you want to use any compute service, then you can select from here. If you want to use any storage service, then you can select from here. In the same way, if you want to select any database related service, then you can select from here. And these are the networking services. And these are the operation related services. And there are some other tools as well, like Cloud Build, Cloud Task, Container Registry, and so on. This is all what I want to show you about Google Cloud Console in this demo. In this demo, we will learn how we can interact with GCP using Cloud Shell. Cloud Shell is a web-based command line utility to interact with GCP, and you can launch Cloud Shell from Cloud Console only. Cloud Shell is a secure admin, and Cloud Shell cannot be accessed from outside of Cloud Console. To launch Cloud Shell, you have to log into Cloud Console first and then click on this icon. Cloud Shell has full power to manage your GCP, and if you are creating new session of Cloud Shell, then it can take some time in starting Cloud Shell because new VM will be created in GCP for this Cloud Shell session. Main benefit of using Cloud Shell is that latest version of all the tools required to interact with GCP are already installed and configured in Cloud Shell VM. Like you can use gcloud command over here. You can also use gsutil command here. Gsutil command is used to interact with cloud storage. You can also use bq command, which is used to interact with BigQuery. You just understand one thing here is that when you execute any command in Cloud Shell, it is not executed on your local machine. In fact, it is executed on VM created for this Cloud Shell session. Browser just make connection to this VM created in GCP to execute any command. You can also open Cloud Shell in separate tab by clicking on this button. Here you can do some UI based customization for Cloud Shell, like you can change the color theme. You can also change size of the text displayed in Cloud Console. You can also execute any Linux command in Cloud Shell, like ls command. As of now, I am in my home directory and persistent disk is mounted to this home directory. And due to this attached persistent disk, if you save some data in your home directory in current session, then you can retrieve this data in your next Cloud Shell session as well. Because once you close your Cloud Shell session, then VM allocated for this Cloud Shell session is shut down. But data still remain available in this persistent disk. When you create a new Cloud Shell session, then new VM is created for new session. But same persistent disk get mounted to your home directory in new session. So if you save your data outside your home directory, then that data will not be available in next session. Cloud Shell also provide UI based editor, and you can open this editor by clicking on this button. So here you can see this file which is available in my home directory. In this UI editor, you can either make changes to the existing files or you can also create new files as well. Now you can save this file. Now I will close this editor. There is one more interesting feature of Cloud Console, that is web preview. But before I showcase this to you, I need to start a web server in Cloud Shell VM. So let me start web server first. Now this web server is started in Cloud Shell VM. Now let's do a web preview. So here you can see the index page of your web application. And this is all about what I want to show you in this demo. Now let's talk about locations in GCP. Location in Google Cloud are defined in terms of region and zone, where zone is the actual physical data center in Google Cloud where Google Cloud services are hosted. And regions are independent geographic areas that consist of multiple zones. Most of the regions in Google Cloud have three or more zones. For example, this US West 1 region denotes a region on the west coast of the United States that has three zones: US West 1A, US West 1B, and US West 1C. Zones within any region are connected with very high speed fiber network, which provides the very low latency. And Google also designed zones to be independent from each other. Each zone usually has its own power, cooling, networking, and control plane, which is isolated from other zones. It helps in designing the fault-tolerant and resilient application because failure in one zone will not affect the other zone. Whenever we use any of the cloud service, we have to specify the region or the zone for that service, which control where that service is hosted and from where it can be accessed. We can launch the service in any mode like single zone or regional or dual region or multi-region. By specifying the region and the zone, we can specify how much fault tolerant our application is and speed of service. Which service can be deployed where depends upon the service itself. Not all the services can be deployed in all possible locations. Like so far, dual region option is available for cloud storage bucket only. Now let's see what are the advantages of these locations. Location of a service determines how much fault tolerant our service is. As you can see in this diagram, as we move up from zonal to multi-regional, fault tolerant level of our service also goes up from low to high. Next factor for deciding the location of a service is latency. To decrease the network latency, we might want to choose a region or a zone that is close to our point of service. For example, if we mostly have customers on the east coast of the United States, then we might want to choose a primary region or a zone that is close to that area and backup region and zone that is also close by. Speed is the key for Google Cloud services, and Google provides very high speed of up to 10 terabytes per second to its customer because of its faster cable system. When we use any of these service in Google Cloud, it means we are using the same infrastructure that Google is using to run its own applications like Gmail, Google Search, and YouTube, etc. Now let's try to understand how region and zone can help in making the application more fault tolerant with the help of an example. Let's consider a very simple case where currently you are hosting one server of your application in one data center that is in zone US West 1A. This US West 1A zone is in US West 1 region. Now, can you think of some concerns with this deployment? Definitely, this deployment is not fault tolerant because there is a risk that your server in data center can go down. Second, this whole data center can also go down. Or there can be another worst case scenario where whole region becomes unavailable due to some kind of failure. But these days we all want our application to be highly available. So how we can avoid this situation? Now let's see how we can solve these concerns one by one. So to mitigate the first risk of server crash, you can run multiple servers in your data center. If you are hosting these servers in your on-premise data center, then these servers can be actual physical machines. But in case of cloud, these servers actually represent the VM instances that you can create in one zone because zone is the actual physical data center in cloud. So this way we can protect ourselves from the first risk of server crash. But what if whole data center goes down? In that case, if you want high availability for your application in case of data center failure, then you should run your application in multiple data centers, or you can say in multiple zones. Now, in this case, if you deploy your application in two data centers, US West 1A and US West 1B, and if one data center, let's say US West 1A goes down, then your application will still remain available in another data center that is in US West 1B. So, in such zonal failure disaster event, all your customer requests will be served by the application running in another data center in US West 1B because each zone in Google Cloud is completely isolated from any other zone. While hosting your application in multiple data center, just keep one thing in your mind that you should choose another data center in the same region to keep the application more close to your customer. This will help in reducing the network latency for the customer. Now we have achieved high availability for the application against the zonal failure. But what if whole region goes down? And since all the zones are in the same region, so your application will again become unavailable. You can achieve high availability for your application against the regional failure in the same way by running your application in multiple regions rather than keeping it in one region only. Like here, now the same application is running in two different regions, US West 1 and US West 2. This way, your application will remain available in case of regional level outage as well. But keep in mind that you must choose the region close to your customers only to reduce the network latency. Since cloud solution provides many data centers across the globe, which are grouped in terms of zones and regions, so you can easily launch your application in any available data center just by selecting the right choice. With your on-premise data center approach, it is never easy to host the application in multiple geographies, and it also requires a lot of investment. This region and the zone-based distribution also helps in meeting the government regulation, where government regulation can force you to create your data center in particular region or country only, so that data of their citizens remain in that location only. And you can find the list of all available regions and zones on this page, along with the list of all available service in all the locations. Currently, there are 25 regions and 76 zones in Google Cloud, which are spread across the globe. I will share this link in the resource section of this video. Please go and have a look at it. Now let's try to understand how Google has set up its cloud infrastructure with the help of a map. When I recorded this video, this was the latest state of Google Cloud infrastructure. And since Google Cloud is continuously expanding, so you can go and check the latest state at the URL mentioned in this video. So now look at this map carefully. Each dot here represents a point of presence in Google Cloud. And there are two types of point of presence. One is the CDN point of presence and second is edge point of presence. These CDN point of presence include some computing hardware along with the storage, since their key function is caching of data close to end user. These edge point of presence actually represent the peering locations where Google and the another network provider can connect together via their respective networking hardware. Now also observe the cables over here. Green cables here represent the submarine cable where Google has made investment. These are owned by someone else, but Google has made investment into these cables. Blue lines here represent the Google's own fiber optic network, which are spread across the globe to provide high-speed network to its customers. These high-speed fiber optic drive the speed of Google Cloud Platform, and Google also use the same infrastructure for its services as well. Now let's talk about the services offered by GCP. Google Cloud Platform provide various services based on the domains. We have compute services to serve various computation needs in cloud. Example of compute services available in Google Cloud are Compute Engine, Kubernetes Engine, App Engine, and Cloud Function. New service added in this portfolio is Cloud Run. Management services provide the set of tools which enables us to get insight into Google Cloud services along with the application running inside GCP. These services are helpful in providing monitoring and alerting. It also helps in finding performance bottleneck in our applications. Networking services define how will our VPC will look like in Google Cloud. These services empowers customer to optimize their cloud network for the performance or price. It defines how we can establish hybrid network between our on-premise data center and cloud network. It also defines how can we do network sharing. Storage and database gives option to choose the right data storage solution based on the business use case. It could be SQL or NoSQL in nature. Big data services provide tools to set up big data processing pipeline, performing the data analytics and doing the data visualization efficiently in Google Cloud. Identity and security ensures the data protection and compliance. Using these services, we can define who can do what in Google Cloud. Machine learning provides API for AI-based use cases like image recognition, speech-to-text conversion, and natural language processing. And Google is pioneer in this area. We will learn all these services in detail in this course. Apart from categorizing services based on the domains, we can also categorize the services based on how much control users have on these cloud services. We can select either infrastructure as a service option like compute engine VM instances, which gives almost full control to user. User can select any kind of VM instance based on the business needs. We can also go with platform as a service option like Google App Engine, which is a kind of balance between the configuration and agility. It is faster for user to use these services as it requires less configuration to start with. Another option is software as a service like Cloud Function. These are serverless auto-scaled services, which means no operation headache for the user. As per this diagram, as we move from bottom to top of this triangle, user will lose more control in terms of configuring the resources in Google Cloud. But this will give more agility to user. It means as we move more towards software as a service model, we will have faster turnaround time for running and instrumenting our application, but we will have less options for environment customization. But there are many cases where managing resources on our own is really a very painful for customer. So it makes complete sense to use software as a service model and focus more on implementing the business use case. For example, setting up a big data cluster and machine learning models is not easy in our own data center because of high dynamic scalability requirement and lack of enough data to create the machine learning models. In this case, it makes more sense to use cloud services in software as a service mode. It will save both time and money for the customer. Now let's talk about how we can interact with Google Cloud. What all tools do we have to interact with GCP? We have various options to access GCP like Cloud Console, Mobile App, Cloud Shell, Cloud API, and Cloud SDK. We have already seen Cloud Console in our demo. It is a web-based UI through which we can interact with GCP. It helps in managing and getting the insight into everything that powers your cloud application. Cloud Console helps us to deploy, scale, and diagnose the production issue in a simple web interface. Mobile app is also a UI-based application similar to Cloud Console, but it is available on mobile. Mobile app is available for both iOS and Android. You can install this app on your mobile. Since it is mobile based, so its main advantage is that we can manage the GCP services on the go. Any activity that we can do via Cloud Console can be done by this app as well. Like we can start the compute engine instance or we can check the alerts on this app. You can install this app on your own and can try this. We will not focus on this much. In exam also, you will hardly find any question on this. Cloud Shell is a browser-based command line tool which we can use to perform any operation in GCP like launching a VM or creating a bucket. Many of our favorite command line tools like Bash and Vim are already pre-installed and updated. Admin tools such as MySQL Client, Kubernetes, and Docker are also configured and ready. By using Cloud Shell, no more hunting is required for how to install the latest version and all its dependencies. Just connect to Cloud Shell and go. It enables managing your GCP resources with the flexibility of Linux Shell from anywhere. Cloud Shell provides built-in authorization for access to projects and resources hosted on Google Cloud Platform. Cloud Shell also provides 5 GB of persistent disk mounted on Cloud Shell instance, which allow data to remain persistent between multiple Cloud Shell sessions. When we launch Cloud Shell session, a VM is created in GCP and a persistent disk of 5 GB is attached to your home directory inside that VM. Cloud Shell instance is created inside this VM and this is per user per session. Because of this attached persistent disk, if we save some data during one session of Cloud Shell in your home directory, then we can get the same data in next session as well because data is getting saved in persistent disk. When we close the Cloud Shell, VM is shut down after some time, but data still remain intact in persistent disk. When we create next session, a new VM is created again for the new session, but same persistent disk is attached to this new VM instance. So we can get the same data that we created in last session. Cloud API is a programmatic interface for Google Cloud Services. Cloud API allow us to access GCP services from our code. It provides similar functionality to Cloud SDK and Cloud Console and allow us to automate workflows by using our favorite language. We can use these cloud APIs with REST calls or client libraries in popular programming languages. Cloud SDK is a G-Cloud command line tool installed on your local machine. Using this, it is easy to perform many common cloud tasks like creating a compute engine VM instance, managing a Google Kubernetes engine cluster, and deploying an App Engine application. A collection of command line tools comes packaged with Cloud SDK, including gsutil, BQ, and kubectl. gsutil tool allow us to manage cloud storage buckets and objects using the command line. BQ is BigQuery command line utility, and we can run queries and manipulate datasets, tables, and entities in BigQuery using this command line utility. With kubectl, you can deploy and manage Kubernetes container cluster using command line. In this demo, we will learn how to install and set up Cloud SDK on your local machine. Cloud SDK is a command line utility to interact with GCP. Cloud SDK runs on your local machine. To install Cloud SDK, open this URL in your browser and then based on the operating system that you are using, select the correct choice from here. Since I am using Windows operating system, so I will use the Windows-based installer. Now first, you download the Cloud SDK installer on your local machine. After this, you need to run this installer and follow the instructions of installer. So let me run this installer. Agree the terms and condition. Here you can also select the beta commands as well. Now click on install. Now it will take some time to install Cloud SDK on your local machine. By this time, I will pause this video. So Cloud SDK is installed on your local machine. Click on next and click finish. Now before using Cloud SDK, you need to do the certain initialization. For this, you need to run command gcloud init. Now it is asking you whether you want to log in. For this, you must log in to gcloud by using the same account which you created in last demo. Here you need to select the Gmail ID and authenticate yourself. Now here you need to select one project and it will be set as the default project in Cloud SDK. So select the right choice and this completes your Cloud SDK setup in your local machine. Now you can try any command here like gcloud, gsutil, bq, kubectl, etc. From next time, you just need to open your command prompt and you can execute any command to interact with Google Cloud. And this is all what I want to show you as part of this demo. So far, we have learned about how to use Cloud Console, how to use Cloud Shell, and how to install Cloud SDK. Now let me introduce you some of the important commands related to Google Cloud. As a cloud engineer, most common commands that you must know are gsutil and gcloud. gsutil command is used when you need to interact with cloud storage service, and gcloud command is used for other cloud services. Since gcloud command can be used with multiple cloud services, so it is organized in terms of group, and this group specifies which service you want to interact with via this gcloud command. Like if you want to interact with compute engine, then you will use gcloud compute command. Similarly, if you want to interact with App Engine, then you will use gcloud app command. And if you want to interact with Cloud SQL, then you will use gcloud SQL command. If at this point you are not aware of what is compute engine or app engine or Cloud SQL, then don't worry. You will learn all these services as you will make progress in this course. Now within each cloud service, you can manage different kind of resources. Like with compute engine service, you can manage either compute instances or you can manage disks or images or snapshots. So after specifying the service with gcloud compute command, we need to specify what resource we want to manage within the compute engine service. For example, if we want to see the list of compute engine instances in our project, then we can run this command gcloud compute instances list. Here, instances is the resource that we want to interact within the compute engine service, and list is the action that we want to perform for these instances. Now, let's check out this command in Cloud Shell. So, I have already copied this command over here. Let's execute it. So, here it has given me the list of instances in my project so far. As of now, there is only one instance in my project, and this instance is in running state as of now. And you can see this state over here. Now, if you want to stop this instance, then you will use gcloud compute instances stop command. But since here you need to stop a particular instance running in a particular zone, so you also need to provide the instance name and the zone information as well with this command. So let's try out this command in Cloud Shell. So I have already copied this command to stop the instance. Let's execute this. It can take few seconds to stop the instance. So my instance is stopped now. So let's see the list of instances once again. So now you can see that my instance is in terminated state. In case you want to see all the actions that you can do with Compute Engine instances, then just type gcloud compute instances and press enter. Here first it will show error that some argument is missing in this command, and then it will print entire list of all possible options that you can use with this command. Like if you want to create a new instance, then you can use create action. So here you can see this create action. Similarly, if you want to delete an existing instance, then you can use delete action. Similarly, if you want to see the list of all possible operations that you can perform using the disk, then you just need to type gcloud compute disk command and then press enter. And here it will give you all possible actions that you can do with disk, like create disk, delete disk, list disk, and so on. Now we will look at another important command, that is gsutil, which is used with Cloud Storage Service. Cloud Storage is an object-based storage service provided by Google Cloud, and I will explain more about this service later on in this course. For the timing, let's check out some commands related to this. So if you want to get the list of all the buckets, then you can use gsutil ls command. Let's check out this command in Cloud Shell. So just type gsutil ls over here and then press enter. So there is no bucket as of now in my project. Now to create a new bucket in my project, I will use another command, that is gsutil mb and then the bucket name. Let's try this as well in Cloud Shell. So now to create one test bucket, I will execute this command. So my test bucket is created. Let's verify this thing by using gsutil ls command. So here you can see my test bucket. Now if you want to remove this bucket, then you will use the command gsutil rm and then the bucket name. So let's try this as well. Now I will paste the command to remove this bucket and then press enter. So my bucket is deleted now. Let's verify this thing by using the gsutil ls command once again. So you can see that there is no bucket as of now. Now if you want to see the help related to the gsutil command, then you need to type gsutil help and then press enter. And it will give you all the options related to gsutil command. So here you might have noticed that these gsutil commands are very much similar to Unix file-based system commands. But Cloud Storage Service is not a file system-based service. It is a object-based storage. So now we have seen two most important commands related to Google Cloud. But in addition to these two commands, there are other important commands as well that you must know. And these commands are bq and cbt. bq is command line utility to interact with BigQuery in Google Cloud. In Google Cloud, BigQuery is a data warehousing service, and cbt command is used with Bigtable service in Google Cloud. If you want to check help for any of these commands, then you can do that by a command like bq help or cbt help. So if you type bq help over here, then it will give you the complete list of options that you can use with this bq command. Similarly, you can also check the help for cbt by typing the cbt help command. So this is all about related to important commands for the Google Cloud. And you can play around with these commands as you will make progress in this course. We know that gcloud is one of the most common command line utility for interacting with GCP services. There are other command line utilities as well for some specific services like gsutil is used for cloud storage, bq is used for BigQuery service, tbt is used for Bigtable, and kubectl is used for GKE service. Though there are few specific command line utilities in Google Cloud for a particular service, but gcloud is the most common one because it is the single command line utility that is used to manage mostly other services in GCP via command line interface. gcloud can be used to manage services like compute engine VM instances, cloud SQL databases, load balancer, instance template, manage instance group, and so on. So in this section, we will focus primarily on gcloud. With gcloud, you can create, update, or delete supported resources. You can use this command both in Cloud SDK on your local machine and Cloud Shell, which is browser-based command prompt to interact with Google Cloud. In this section, I will use Cloud Shell to showcase how to use gcloud. But if you want, you can execute the same commands in your local machine as well via Cloud SDK. But for this, first you will have to install the Cloud SDK on your local machine. So let's go to Cloud Shell. One thing that you should remember here is that Cloud Shell is free to use and you do not need to pay anything to use the Cloud Shell. And some of the command line utilities like gcloud or gsutil are already installed in Cloud Shell. Now, first let's check the version of Cloud SDK component installed in your Cloud Shell. For this, I will run the command gcloud version. And here it will print the version information for all the Cloud SDK components like gsutil, tbt, bq, etc. Now just notice few things over here. This is the user ID by which I log into Cloud Shell. Second, this is my current project ID. And on Cloud Console, you can check to which project this project ID belongs to. For this, click over here, and from here you can check that this project ID belongs to this project. Now click on cancel. Let's go back to Cloud Shell. Now from where these values are coming up. Actually, these are the default configurations which are set in Cloud SDK installed in the VM created for this Cloud Shell session. Next question is, can we see the list of all the default configurations? Yes, we can. We can see all the values which are currently set in your Cloud SDK by using another gcloud command, that is gcloud config list. Let's try this as well. Click on authorize. So here you can see complete list of default configurations. Here these configurations are organized in four groups. One is component manager, second is compute, then core, and then metrics. Here just notice that the default account name and project name are under the core group. Now can we read the value of one particular configuration key only? Yes, we can do that via gcloud config get value command. Now let's try to read the value of project. So here you got the value of your project. Now notice here that whenever we type direct value of property here like this, then value of property is read from the core group. And since project is defined under the core group, so we were able to read this property value. Now let's try to read the value of this property. So it is not able to read this property value because this property is not defined under the core group. It is defined under the compute group. To read the value of this property, we need to write the command like this. And this time you are able to read the value of this property. Here just notice that this time we also specify the group name before the property key. Similarly, we can also read the project configuration like this. So this time also we got the value of project. Now opposite of gcloud config get value operation is gcloud config set command. This command will set the cloud SDK property. Similarly, there is another gcloud config unset property command which will unset a cloud SDK property value. I would like you to please try these commands on your own. I have given the examples for these commands over here. Like in this example, you are setting the value of default zone to be used for the compute instances. And in this example, you are unsetting the default project. If you need some kind of help for the gcloud command, then simply type gcloud help, and here you can read the whole documentation about the gcloud command. If you want to see the help for the gcloud config command, then type gcloud config --help. And here you can read the whole documentation about the gcloud config command. In this video, we will learn about another important gcloud command, that is gcloud init. If you are setting up your cloud SDK for the first time, or you want to change the settings in your gcloud, then you need to use the command gcloud init. Gcloud init can be used to initialize or reinitialize the gcloud configurations. It can be used to define the default Google account name to be used with gcloud. It also defines the default project to be used with gcloud, and it also defines the default region and zone to be used with gcloud. Now let's see in Cloud Shell how to use gcloud init command. For this, just type gcloud init over here. Here you can see your existing configurations, and here you are getting options to either reinitialize the existing configuration or to create new configuration. If you are setting up your gcloud for the first time, then you will not see all this. Since in my case I am already using gcloud, so it is giving me two options. Now you need to select one choice between these two options. Do you want to create a new configuration or you want to reinitialize the existing configuration? For this demo, let's go with second option, that is to create a new configuration. For this, just select two over here and then press enter. Here you need to give the name to this configuration. Press enter. Now you need to provide the Google account that you want to use with gcloud. You can either select an existing account, which is the first option here, or you can provide a new account name as well. Let's go with existing account for the time being. Now you need to select the project that should be used with gcloud. Since as of now there is only one project in my GCP, so let's select that by choosing the option number 1. If you have created multiple projects in your GCP account, then you can select any project. So just type 1 over here. So you can see over here that this project is set as default project for my gcloud. Next, it will ask for the default compute region and zone to be used with gcloud. Just remember that properties set by the gcloud init are local and persistent. It will affect your gcloud only. It will not be affected by the remote changes to the project. For example, the default compute engine zone in your gcloud configuration will remain same even if you or some other user changes the project level default zone in the cloud platform console. Now say yes over here. Here it has listed all the available zones and you need to pick one zone as your default zone for the gcloud local settings. I will choose option number 26 from this list, that is Asia East 1 B zone. So just type 26 over here and that's it. Now your gcloud is set up completely. So this is how you can use gcloud init to initialize or reinitialize the gcloud configurations. In previous video, we learned how to initialize or deinitialize the gcloud configuration. In that video, we created our first configuration in gcloud where we set default account name, default project name and default zone to be used with gcloud. In this video, we will learn about how to use gcloud config configurations command to manage the multiple configurations in gcloud. By using this gcloud config configurations command, we can create a new named configuration. We can also delete a named configuration. We can activate a named configuration. We can also list existing configurations or we can describe a named configuration by listing its properties. Now, before I show you how to use these commands, first question here is why do we need multiple configurations? Actually, in general, while working in GCP, you create multiple projects and you have to work with multiple projects from a single machine. And for each project, you might need different default configurations. In such case, you need a way to create and manage the multiple configurations. So basically, this gcloud config configurations command gives the ability to use different configurations for the different project on a single machine. Now let's see how to use these commands. So first command that we will try is gcloud config configurations list. This command will print the list of existing configurations. So let's go to Cloud Shell to try this command. So here you can see two existing configurations. This configuration is created by Google Cloud when we launched the Cloud Shell. And this is the same configuration that we created in our previous demo. Also observe that this configuration is in active state and here you can see the default account name, default project name, default zone and default region to be used with gcloud for this configuration. Now what you will do if you want to activate this configuration. If you want to activate other configuration, then you will use other command, that is gcloud config configurations activate. Let's try to activate the other configuration via this command. So this configuration is active now. Let's verify this by using the gcloud config configuration list command once again. So now you can see that this configuration is in active state. Also observe that the default zone is not set for this active state as of now. Also notice that this previous configuration is not in active state anymore. At one time, only one configuration can be in active state. Now question is, can we create a new configuration? Yes, we can create a new configuration via command gcloud config configuration create. Let's create a new configuration via this command. Here, this is the name of new configuration that we just created. Just notice that this command has not only created this second configuration, but it has also activated this configuration. Now let's see the values of this new configuration. So here you can see all the values of the configurations under this new configuration. Just notice that for this new configuration, default account name is defined, but the value for the default project and default zone is missing. And since value of the default project is missing, so we are not getting the value of project on the command prompt as of now. Now I will set this project as the default project for this new configuration. For this, I will use command gcloud config set. So here you can see that default project is also set for this new configuration. Let's verify this by listing the configuration properties once again. So this time you can see the default project for this new configuration. Now there is another command to describe a particular named configuration, that is gcloud config configurations describe. This command will describe a named configuration by listing its properties. Let's try this command in Cloud Shell to describe the second configuration. So here you can see that this second configuration is in active state, and you can also see the project for this second configuration. Now last command that I would like to show you in this video is gcloud config configurations delete. This command deletes a named configuration, but keep in mind that you cannot delete a configuration that is in active state. So before deleting an active configuration, you must first activate the other configuration. So let's try to delete the second configuration. So here we are not able to delete this second configuration because as of now, this second configuration is in active state. To delete this configuration, first I will have to activate some other configuration. So let me see the name of existing configurations first. Now from this list, I will activate the first configuration. Now I will try to delete the second configuration once again. Say yes over here. Now you can see that second configuration is deleted successfully. You can also verify this by listing the configurations. So here you can observe that second configuration is missing from this list. So this is all about how you can manage the multiple configurations in gcloud. In this video, you will learn about some more gcloud commands which you must know for this exam. While dealing with different type of services in GCP, we often need to do the listing of different type of resources, like getting the list of projects via command gcloud projects list, getting the list of compute instances via command gcloud compute instances list, getting the list of regions for the compute service via command gcloud compute regions list, and getting the list of images for the VM instances via command gcloud compute images list. As a cloud engineer, you should be familiar about how to do the listing of any resource in GCP. And if the result of such a listing operation is quite big, then you can filter the result by using the filter expression. Like if you do the compute images listing over here by using command gcloud compute images list, then you will get many line items in terms of result. So here you can see that there are many line items in the result. So here it has listed many images. Some of them are Windows based, others are based on Ubuntu, some of them are based on Fedora, and so on. But if you are interested in some Ubuntu based images only, then how will you find this? In this case, you will use filter expression to filter the result further so that you can reach to your desired result faster. So in this case, you will add the filter expression in your previous command and you will write your query as gcloud compute images list, and then you will add the filter expression in the end. Here, this list operation with this filter expression will return only those images whose name has Ubuntu keyword. And also remember that this filter expression should be a Boolean expression. So let me run this query with this filter expression. And this time we got only those images whose name has Ubuntu keyword. But if you look at this result, especially the values under the name column, then you will observe that values under the name column are not in sorted order. So can we do the sorting of this result based on the name column? Yes, you can do the sorting of the result by using sort by flag. Like if you want to sort the previous result, then you should add sort by flag in your command like this. Just notice that here I have added another sort by flag in the end, which will sort the result based on the sort by flag values. And in our case, it will sort the result based on the name column. So let's try this command to sort the result. And this time you can observe that this result is in sorted order based on the values in name column. In addition to filter flag and sort by flag, there is another important flag that you should know, that is URI flag. If you want to get the URI of each image in the previous result, then you should add --URI in your last command like this. And this will print the URI of each image in the result. But what is URI? Actually, every resource in GCP is identified by its unique URI. So it's a unique identifier for every resource in GCP. So let's try this command as well. And this time you got the URI of each image in the result. Also notice that for each of the listing operations over here, we mentioned the resource type as plural. We did not write project over here, but we write projects. In the same way, we did not write instance over here. What we write? We write instances. Similarly, here we write regions and here we write images. And this is very important point to note. Another important command that you must know is gcloud describe command. Describe operation generally gives the detailed information about the given specific resource. Like if you want to describe a particular project, then you will write a command like gcloud project describe and then name of the project that you want to describe. Similarly, if you want to describe a compute instance, then you will write the command like gcloud compute instances describe and then VM instance name that you want to describe. So let's try this command. Here, if you want to describe this project, then you will write this command gcloud projects describe and then this project name. And here it will print the complete details about this project. Now let's do the listing of compute instances in this project. Now if you want to describe this instance too, then you will write command gcloud compute instances describe and then instance 2, which is the instance name. I will use the default zone. And here it has given the complete details about this instance too. I will highly recommend you guys to practice all these commands so that you become very comfortable with all these commands. Now before we move further in our learning journey, we must remember that to use any service in GCP, first you need to enable its API. This way, Google try to ensure that you are not charged for a service which you do not want to use. If you have not enabled some API and you want to use that API, then you will be asked to enable that API the first time you try to use that API. Whenever an API is enabled, then API gets associated with the project for which this API is enabled. And monitoring pages is added in the Cloud Console for that API in the project. And billing is enabled for that API and services if billing is enabled for the associated project. Some APIs are enabled by default whenever a new project is created, and you can see the list of those APIs over here. So these are the APIs which are enabled by default for any new project. And this was the reason that we were able to use those APIs like gcloud compute and gsutil without enabling them explicitly in our previous demos. If you want to see the monitoring page of the API and services, then go to API and services page from here. Just write API and then select this option. Here you can see the various metrics related to the API. Currently nothing is appearing over here because nothing is running in my cloud as of now. From here you can change the time frame for the metrics data. Now if you want to enable some API, then you need to go to API library page. And you can go to API library page either by clicking on this option, or you can search the API library page from here. On this page, APIs are organized in terms of logical groups. Like for the APIs related to the database, you can check over here. Similarly, for the compute related APIs, click here. So here you can see all the APIs related to compute option. Now let's go back. You can also search for the API by using this search bar. Like if you want to search for the monitoring related API, then click here and type monitoring. And it will here show all the APIs related to monitoring. Now let's go back. Now let's say if you want to enable this map API, then select this API. Here you can see the details about this API. Now click on this enable button to enable this API. It can take some time to enable an API. So I will pause this video till then. So here you can see that map API is enabled for this project as of now. Click here. If you want to disable some API, then you can click on the disable button for the corresponding API. Since I do not want to use this map API as of now, so I will disable this API by clicking on this disable button. So this is how you can enable or disable an API in GCP. So first let's understand what is a resource. Resource is anything that user create in Google Cloud. It could be a compute engine instance, it could be a persistent disk, or it could be a bucket defined in cloud storage. Like if you click here and create compute engine, or you create some kind of a database like Cloud Spanner or Cloud SQL, or if you create some VPC network, everything comes under resource in Google Cloud. Whenever we create any resource in Google Cloud, we need to define the location of resource. Location defines the boundary from where resource can be accessed. Possible location for resources are zonal, regional, dual regional, multi-regional, and global. Zonal resource operates within a single zone. If a zone becomes unavailable, then all of the zonal resources in that zone are also unavailable until service is restored. Example of some of the zonal resources are virtual machine or persistent disk. These are accessible in zone only. Regional resources are resources that are deployed across multiple zones within a single region, like App Engine. This gives them higher availability related to zonal resources. These resources can be accessed from within region only. Google also offers to define dual region as an option for cloud storage bucket. Multi-regional services or resources are deployed across multiple regions like Cloud Spanner or Datastore. Such services offer even higher availability than regional services and can sustain the failure of region as well. There are some resources like image, snapshot, networking, which are global in nature, and these resources can be accessed from anywhere. Ideally, compute engine instance and data storage should be co-located to give the better performance. Mostly, we need to pay for the resources that we create in GCP, but some resources are free as well. Price matrix of a resource is dependent on type of resource. Each resource type has its own pricing strategy. Location-based view of a resource is just one way to visualize your resource. Resources can also be visualized in hierarchical manner. Just look at this diagram that shows how we can visualize the resource in hierarchical manner. At the bottom of this tree, we can create cloud resources like virtual machine, persistent disk, or Google App Engine. And above resources, we have projects, folders, and organizations. And these are nothing but just the container for the resources under them. In fact, project, folder, and organizations are also considered as resources in Google Cloud, and we can associate access policies with them. We will discuss about policy later in this section. The organization resource is closely associated with a G Suite or Cloud Identity account. When a user with G Suite or Cloud Identity account create a Google Cloud project, an organization resource is automatically created for them. We cannot create organization and folder in free trial account. So we will mainly focus on project and resources under them. As this diagram depicts, we can correlate resource hierarchy like hierarchy in organization. At the top, we have organization in which we work, and under organization, we have department like finance and HR. And each department can have teams inside them. Like in HR department, we can have teams like recruitment team and corporate policy management team. And each team might be working on multiple projects. Like in same IT project, we can have dev project and QA project. And each project can have any number of cloud resources. So this is how we can easily understand resource hierarchy. Next question is, why should we arrange resources in this hierarchical manner and what we can get out of this? Managing resources in hierarchical manner provides access management using policy. We can set an IAM policy at any level like organization level, folder level, or project level, or directly at resource level. These policies can be inherited as well from its ancestor. Like if we set a policy at the organization level, it is inherited by all its child folder and projects. And if we set a policy at project level, then it is inherited by all its child resources like Compute Engine VM instance or Cloud Bucket. The effective policy for a resource is the union of the policy set on the resource and its ancestor level. Another benefit of resource hierarchy is cost management. This resource hierarchy enables central management of the resources under its hierarchy. Like we can either check the cost of individual resource at the bottom level, or we can see the combined cost of the resource at project level or folder level or organization level. If there are 5 GCP resources in a project, then cost of these resources will roll up to that project, and we can visualize the cost of the project as a whole. In the same way, we can visualize the combined cost of the resources at any level in this hierarchy. We can also do enabling of the services and API at project level. To use most Google Cloud APIs and services, we must first enable them in Cloud Project. So what happens when we enable any API at project level? This associates them with the project and enables the billing for the API and the services if billing is enabled for the project. So far, I have explained what is a project in GCP. Project is a kind of resource container to manage resources in your GCP account. You can create multiple projects in GCP, and projects helps you in access management and cost management. Cost of any project is total cost of all the resources created inside that project. In this demo, I will show you how to do the project management in GCP via Cloud Console. Whenever you create a new Google Cloud account, by default, one project and one billing account is also created for you, and this project is linked with that billing account. And this is my default project which was created for me at the time of account creation. If you have multiple projects in your GCP, then all those projects will appear here. Like currently there are 3 projects in my GCP. You can go and see the project setting for the project which is selected over here by going to project setting. Here you can see project name, project ID and project number for your project. Here you can change project name at any time, but project ID and project number cannot be changed after project creation. Also, project ID and project number are globally unique across whole Google Cloud. You can also create a new project by clicking on New Project button. Here you can give any meaningful name to your project, and for the new project you can also change the project ID. This option will not be available after the project creation. If you do not provide project ID, then it will be generated by GCP along with the project number. You cannot create your own custom project number. And here it shows your quota limit. It shows how many more projects you can create in your free trial account. Currently, there are 21 projects remaining in my free trial account. Now click on the create button to create this project. Once this project is created, you can see this project in this project list. So you can see your project here. You can also shut down your project by clicking on the shutdown button. If you shut down your project, then this project will be marked as inactive for the 30 days and all the billing for this project will also be stopped. You cannot access any data, service and API in this project after it is shut down. Once this 30-day period is over, then all the project data and API will be deleted permanently. Right now, I do not want to shut down my project, so I will leave it as it is. Whenever you want to use some cloud API in your project, then make sure that API is enabled for this project. Some APIs like gcloud, gsutil, bq or kubectl are enabled by default. That's the reason that we were able to use those API in our previous demo without enabling them explicitly. And you can see the list of API which are enabled by default for any project listed over here. If you want to use any other API, then you can explicitly enable it on API library page. On this page, you can search for any cloud API. Like if you want to enable this map API, then click here and you can enable this API by clicking on the enable button. You can search for this API library page from here. So this is how you can open the API library page. Now let me show you the linking between billing account and the project. For this, click on the billing, then go to linked billing account and then click on manage. So here you can see the list of all the projects which are linked to this billing account. It means more than one project can be linked to a single billing account, and this billing account is responsible for billing and payment for these projects. If you want to disable the billing for any project, then click here and choose the disable billing option. And in the similar way, if you want to change the billing account for your project, then choose this option. Now let's do a recap of what we have learned about projects. Projects are the container for the resources and used to manage access permission and cost management for those resources. Whenever you create a new Google account, a new project is created for you. Each project has a project name, project ID, and project number, and you can just change the project name anytime. Project ID and project number cannot be changed after the project creation. You can define the project ID at the time of project creation, but project number is generated by GCP. Project ID and project number are globally unique. There are no charges for the project creation, but you need to pay for the resources like compute engine, cloud storage bucket created inside your project. So this is all about the project which I wanted to show you in this demo. Now let's understand what is quota in GCP. Quota defines the limit on the resources that you can create in GCP. There are different type of quotas depending upon the type of resources. There can be both global and the regional quota for the resources. And some examples of the quota are how many compute engine instances you can create in your project and how many number of network you can define in a project. Quota can also control rate limit on the number of API requests in a project. Quota controls both billing and the resource utilizations. There are quota limits defined for various cloud resources for a project. If we need to increase the quota limit, then we need to raise the request with Google to increase the quota limit. So you can ask for the quota increase by raising the ticket with Google, but still there are some hard limits defined, beyond which you cannot ask for the increase of quota limit. Like you cannot create more than 5 network in a project. It is a hard limit defined in GCP. This is all about the resource management in GCP. If you have any queries related to this, please post your queries. Next, we will learn about billing. Now we know that what are projects and resources in GCP. After this, next big question is how the bill will be generated and managed for the resources which are created in your projects, and who will pay for those bills. How can you make the payment for your bills? This question is answered by billing account. Billing account determines who will pay for the bills related to the resources created in your cloud. To check the billing for the resources, select the billing option here. Then go to link billing account. Whenever we create a new Google Cloud account, then a default billing account is also created. And this is my default billing account. If you do not create any other billing account in your GCP, then bill for all the resources in your GCP account will be managed by this default billing account. If you want to create a new billing account, then click on Manage Billing Account. Here you can see all the billing accounts which you can access. It includes both kind of billing accounts, means billing account which you have created and billing account which you have not created, but you have been given access to view that billing account. Like here, this is the billing account which is created by me. So I am the administrator of this billing account. But if you look at this billing account, then this billing account is actually not created by me. I have been just given the view only permission for this billing account, and this is my permission. I am just a billing account viewer for this particular billing account. Now to create a new billing account, click on Create Account button. On this page, you can create a new billing account by giving the billing account name and country and the payment information for the billing account. Now let's look at the billing account overview page. On this page, here you can check your free trial credit balance along with how many days are left for your free trial account. And this free trial amount is shown in your local currency. From here, you can upgrade your free trial account to paid account. Here you can see the total cost up to today for this month, and here you can see the forecasted cost for the whole month. If you want to further drill down your bill, then click here. Here on this page, you can see the bill for all the resources which you have created in your GCP. By default, it shows the billing information for the current month, but if you want to see the billing information for some other dates, then you can select the date range from here. And by default, it will show you the billing information based on per project basis. But if you want to see your bill in some other way, like you want to see your bill on a per service basis, then you can select this option from here. and now it will show you bill in terms of services. In the same way, you can also do the grouping based on the region. Now it will show you the bill in terms of region. Here you can also do the filtering based on the project. Let's say if you want to see the bill just for this project, then select this project. In the same way, if you want to see the bill for a particular service, you can select that service from here. In the same way, you can also do the filtering based on the SKU, location, and labels as well. This is all about the billing accounts that I want to show you in this demo. Now you have understood where to look for your bill in GCP and how to analyze it. But once your bill is generated, you need to make the payment for this bill. So in this demo, I will show you the payment section of billing account. For this, you need to go to billing account overview page and select the payment overview option. On this page, here you can check your current dues and you can make the payment for those dues by clicking on this button. Here you can see your payment methods. This is the same payment method which I specified at the time of Google account creation. You can either use this payment method for all your payments or you can add another payment methods as well. And you can add multiple payment methods here on this page. If you create multiple payment methods, then you will also get the option to delete the payment method. But one payment method must always remain active. And that is the reason that I am not getting the delete payment method option here, because as of now there is only one active payment method in this case. Here you can see the list of transactions that you made in the past. Here you can see the settings for your payment account and payment profile. Each billing account is linked with a payment profile, which determines the legal entity who is responsible for the payment account. Here is my payment profile. It shows the profile information like name, country, account type, tax information, and address. It is the same information which you specified at the time of account creation. Here it shows the document preference language, which determines your preferred language to receive your billing related documents. This is the payment account which determines how you will make the payment. Like, do you want to make the payment automatically on monthly basis? And there can be multiple payment accounts associated with the payment profile. This is all about the payment section that I want to show you in this demo. Now there is one more thing that we all must understand about billing is account management. To look at the account management, select the account management option from here. Here we will discuss the relationship between a project and a billing account. Whenever you create a project, it must be linked to a billing account, and multiple projects can be linked to the same billing account. Like here, all these projects are linked to same billing account, but it does not mean that all these projects are created by me. Here, four projects are created by me, this one, this one, this one, and this one. This other user project is not created by me. Let me show this to you. So if you go to Google Cloud Dashboard, here you can see list of all projects which are created by me. So here you can see four projects which are actually created by me. In this list, other user project is not there. Now question is, to whom does this other user project belongs to and why it is appearing here and how this project got linked with this billing account. Actually, I am billing account administrator of this billing account, as you can see over here. So I have full access on this billing account. So I assigned role of billing account user to other cloud user, as you can see over here. This role, allows other user to create project and associate their project to my billing account. That is why this project is appearing here. But also notice that linking of the project to billing account does not mean that I can access resources inside this project. I can just see the bills associated with this project and not the resources. You can also assign roles related to this billing account to other cloud members as well. For this, you just click on Add Member button. Here, you need to provide the email ID of other cloud user to whom you want to assign roles. Once you provide the email ID, then you can select the role from this list. From here, you can assign any of these roles. You can also enable this checkbox to notify user by email about this new role assignment. Once you fill up this whole information, just click on the Save button and then respective role will be assigned to other cloud user. It is like each IT team in your organization can create their own project and can link their project to same billing account. And there will be one CFO who will be managing this billing account and responsible to pay bills for those linked projects. CFO might not be interested in doing the project management for all these individual projects. He is just responsible to make the payment for their bills. Project management of the individual project must lie with the individual team only. On this page, you can rename your billing account as well by clicking here. Here you can give the new name to your billing account. And from here, you can close your billing account. If you close your billing account, then you cannot use any billable service like Compute Engine VM instance or Cloud Storage bucket inside any project linked with this billing account. Now let me show you the management of billing accounts as well. For this, click on Manage Billing Accounts. Here you can see all the billing accounts that you can access. And here you can see the number of projects linked with the respective billing account. If you want to create a new billing account, then just click on the Create Account button. Here you need to give the name and the country for your billing account and then click on Continue. Here on this page, you need to provide the similar payment related information which you provided at the time of GCP account creation, like name, address, or credit card information. For this, either you can use the existing payment profile or you can create the new payment profile as well. Once you fill this whole information, just click on the Submit button and it will create a new billing account for you. Now look at the projects as well. Here you can see all the projects which you can access and their associated billing account. From here, you can either disable the billing for the respective project or from here you can change the billing account for the project. Now let's do a quick recap of billing account. Billing account defines who pays for the given set of resources created inside the associated projects. Billing account can be linked to one or more projects. Project usage is charged to the corresponding linked billing account, and each project must be linked to a single billing account. One project cannot be linked to multiple billing accounts at the same time. Billing account results in a single invoice per billing account. So, even if there are multiple projects in a single billing account, we don't need to see the bill for each project separately. Single invoice will be generated for all the projects at the billing account level, and multiple billing accounts can be created in cloud. Each billing account is linked to Google Payment Profile, which includes a payment instrument, which defines how you make the payment for your charges. Billing account has billing specific roles and permission, which can control actions like who can create a billing account, who can see invoice for the billing account, and who can associate project with the billing account. This is all I want to discuss about billing account in this demo. If you have any query related to the billing account, please post your queries. In this video, we will learn about budget and alert. What is a budget and alert in GCP and why to use it. Next, I will show you how to set up the budget and alert in GCP. Budget in GCP is like any other budget where you plan how much you want to spend in your GCP, and alert is a kind of a trigger which notify you if your actual or forecasted spend in GCP goes beyond the certain threshold value which you specify while configuring the alert. This threshold value is generally relative to your target amount which you specify in your budget. Since we are using free tier account, so we do not want to spend too much in GCP. Sometimes we might forget to stop some cloud resources like compute engine or data proc cluster. And if we do not pay attention to such incidents, then we might end up paying very high cost in cloud, and that too because of the resources which we are not using. In such cases, these budget and alerts are very helpful for us. To avoid such situation, we first set the budget with the target expense and then set the alerts that sends the notification to us in case our actual or the forecasted expense in cloud goes beyond a certain threshold value defined in your alerts. And based on these notifications, you can take the corrective action on time to reduce your cloud expense. This way, it helps you in avoiding any kind of a surprise bill and helps you in managing the cost in GCP. Using this, you can monitor your actual cost versus target cost in your cloud environment. It is a good practice to set up budget and alerts in any cloud service before you start creating a resources in your cloud. So, if you have not set up your budget and alerts in your billing section, and if you click here, then here it will also recommend you to set up the budget and alert first before creating any resource in cloud. Now let me show you how to set up budget and alert in billing section in GCP. To create your first budget, you can either click on this button or you can go to this option. Now click on create budget button. Here first you need to give the name for your budget and then decide the scope of your budget. Like, do you want to create budget for all the projects or you want to create budget for a particular project? Here I will create budget for all my projects. In the same way, you can also decide, do you want to create budget for all the services or you want to create budget for a specific service like compute engine instance or stack driver logging. Here in this demo, I will create budget for all the services. Now click on next button. On this page, you need to provide your planned budget amount. Here, you specify your budget amount either as a fixed value or relative to your last month's spend. Here, you need to provide the actual budget amount. And also notice that this amount is in your local currency. Now click on next. After setting up the budget amount, here on this page you need to define the threshold values for your alerts. And you can also choose what kind of expense you want to track for each alert against the specified threshold value. You can track either actual expense or the forecasted expense against these threshold value, and you will get the email notification if your actual or forecasted expense goes beyond these threshold values. Here by default, three alerts are already configured with threshold value as 50%, 90%, and 100% of the specified budget amount. So in this case, you will get the notification if your actual expense goes beyond the 50% of the budget amount. And in this case, you will get the notification if your actual expense goes beyond the 90% of the budget amount. And in this case, you will get the notification if your actual expense goes beyond the entire budget amount. If you want to track forecasted value in place of actual value, then you can change it from here. But for this demo, I will create the budget and alert based on the actual value. You can also add more alerts in the same way by clicking on this button. But for this demo, let's create alerts based on these values only. You can also use Cloud Pub Sub to receive the alert notification programmatically. Now click on Finish button. And here your first budget and alert is created, and you can see the bars for your alerts over here. This is all about the budget and alerts which I wanted to show you in this demo. If you have any queries related to this, please post your queries. In this video, I will discuss about billing export, and I will show you how to use the billing export in GCP. Billing export allows you to export your billing related data to BigQuery automatically throughout the day. Once this data is exported to BigQuery, you can use this data for the analysis purpose by using any BI tool like Data Studio or Excel file. You can create your own tool as well to analyze this data. Now let's go and create the billing export. To configure the billing export, click on the billing export option over here. Here on this page, it shows that billing export is disabled as of now. So let's configure the billing export by clicking on the edit setting buttons. Here you need to select your project first where your BigQuery dataset is present in which billing data will be exported. If you do not know much about BigQuery, then for the timing, you can consider it like a database. So here I will select my project as my first project, and as of now there is no dataset exist in the BigQuery in this project. So first let's create a dataset in BigQuery. For this, go to BigQuery. Now click on create dataset to create your first dataset. Now here you provide some meaningful name to your dataset. Then here select the location where your dataset will be created. For this demo, I will create the dataset in Asia region. For the time being, you can leave rest of the settings as default and click on the create dataset button. Now your dataset is created and you can verify this by expanding this node. And here is your dataset. Now let's go back to billing export page. Now I can see this dataset over here. Now click on Save button to configure your billing export. And this completes your billing export. Just notice one thing here is that once you configure your billing export, your already existing billing data will not be exported via this billing export. Billing data, which is created only after configuring this billing export, will be exported to BigQuery. You can also export your billing related data in CSV or JSON format. But this is not a recommended practice because both the formats do not contain enough information for the good analysis. And this is all about the billing export, which I wanted to discuss with you in this video. If you have any queries related to this, please post your queries. In this video, we will learn about pricing calculator and I will show you how to use pricing calculator in GCP. Pricing calculator helps you in estimating the cost of any service that you are planning to use in your project. You can access the pricing calculator in GCP at this URL. And I have shared the link to open pricing calculator in the resource section of this video. Here, let's say you want to use compute engine in your project and you want to get the estimate for this. For this, just select this option. Then here you provide the number of instances that you want to use. then provide the purpose. From here, you can choose the operating system that you want to use. From here, you can choose the machine class. You can either go with regular machine class or you can go with the preemptible machine class. From here, you can choose the machine family and it could be any of them: general purpose, compute optimized, memory optimized, or accelerator optimized. In the same way, from here you can choose the machine type. Actually, you should provide as much detail here as possible for you, because more accurately you fill up this whole detail, better will be the cost estimate given by your calculator. If you are not able to fill this whole form as of now, you don't need to worry about it, because you will learn all this when we will discuss about compute engine. After filling this whole information, just press this button. And here it will give you the estimated cost for your compute engine VM instances for the specified configuration. Like, this configuration will cost me $97.84 per month. Once you are done with your pricing estimation, you can either send this estimate via email or you can save this estimate as well. If you want to make some changes in this configuration and want to try some more estimate, then you can click on this button. Now I will change the number of instances and calculate the estimate once again. Now this estimate has gone up to $195.67 per month. So this is how you can estimate the cost of compute engine VM instances that you want to use in your project. In the same way, you can also calculate the cost of other services like App Engine, Kubernetes Engine, Cloud Run, and so on. This is all about the pricing calculator that I wanted to show you as part of this demo. If you have any queries related to this, please post your queries. So far, we have discussed what is a resource and how to manage its hierarchy and billing. Now we will discuss about IAM. IAM means Identity and Access Management. With IAM, we can manage the access control by defining who has what access for which resource. IAM is actually a security framework in GCP and used to implement granular access control and security policy. Now, we will talk in more detail about what is an identity in cloud, what are the permissions and role and type of role, how to assign role to an identity, what is a policy, and how to attach a policy to a resource. So, first let's try to understand what is an identity or a member in Google Cloud. Member in IAM define who can do some action in cloud. A member can be Google account, a service account, a Google group, or G Suite or cloud identity domain that can access a resource in Google Cloud. It can also be an individual member in G Suite and cloud identity. In Google Cloud, each member is identified by its unique email address, and service accounts are used by applications, services, or virtual machine who try to interact with GCP. Google Group is a group of users and service account. Each group also has its unique email address, and group can be nested as well. It means group can contain other groups as well. For example, there can be one group of developers and there can be group of all employees as well, which will contain group of developers in it. If we have to assign similar permission to all the developers, then we can create a group of all developers and then give role to this group rather than giving the role to individual member. So role can be assigned to an individual user, but group is always a preferred approach to assign the roles. Just notice one thing here is that in GCP, we cannot create any new identity. We just use existing accounts. There are some special members as well, like all authenticated users and all users. If we want to assign some permission to all valid Google account or service account, we can assign that permission to all authenticated users. All users represent any user in internet, and we can make resource completely public by assigning permission to all users. Now let's discuss some key points related to service account. So what is service account? Service account is a special kind of account used by the application or virtual machine who want to interact with GCP. It is not used by a person. It represents an identity of a program rather than a person. Service accounts do not have any password and cannot log in via browser or cookie. Service accounts are associated with private public RSA key pairs that are used for authentication in Google Cloud. And service accounts are not members of your G Suite domain, unlike your user accounts. Whenever two applications or two VMs wants to communicate with each other, then service account must be used for the authentication between them. Now let's see what is a permission. Permission in Google Cloud defines the most granular operation that can be performed on a cloud resource. And permission name follows the pattern service.resource.verb. Example of a permission is pubsub.subscription.publish, and this permission just allows to publish the message to a topic on Cloud PubSub. It does not allow to create a PubSub. Permissions are not assigned directly. Instead, multiple related permissions are grouped into a role, and roles are used to manage the resource. Role is a collection of permissions, and it controls the level of access for cloud resources in GCP. Each service in cloud has administrative role defined, which provides the full access to user to whom this administrative role is assigned. There are typically three types of roles in GCP. First type of role is primitive role, and there are three primitive project level roles: viewer, editor, and owner. These are very broad level roles, and it is normally not preferred to use these roles. Viewer role gives only read-only permission on a resource, and you cannot change any state of the resource. Editor role gives both read and write permission on a resource, and owner role gives permission to control access and billing in addition to read and write permissions. Owner is a very powerful role. It can do lot many things in addition to read and write operations. Owner can give permission to other users as well. Owner can also set up and control the billing related operation for a resource. In addition to primitive roles, IAM also provide additional predefined roles that gives more granular access to specific Google Cloud resources and prevent unwanted access to those resources. And these are Google Cloud managed roles. And more than one role can be assigned to a single user. For example, the same user can have the network admin and log viewer role on a project and can also have a publisher role for a Cloud Pub sub topic within that project. One example of such role is BigQuery job user role. This role gives the permission to run BigQuery jobs in a project. Last type of role is custom role. It also gives the granular access to specific Google Cloud resources and prevent unwanted access to those resources. But these roles are managed by Google Cloud user and not by Google Cloud. Custom roles is a collection of other roles or permission. It means in a custom role, you can add either other already existing role or the permission or both. Predefined and custom roles are preferred approach as compared to primitive role while assigning the roles to any member in GCP. Now we have covered enough theory. Next, we will do a small demo to show you how we can use the IAM to create member and assign roles to them. So now we have understood what is billing account, roles, and permissions in GCP. There are two types of billing accounts. One is self-serve billing account and other is invoiced billing account. In case of self-serve billing account, bills are paid by either credit card or direct debit from the bank account, and this cost is automatically charged. But in case of invoiced billing account, bills or you can say invoices are sent to the customers, and customer need to make the payment for these invoices later on. This type of invoice billing account is generally used by the enterprises or large customers. Now also look at some of the important predefined roles related to billing account. First such important role is billing account creator role. This role allows the cloud member to create a new billing account, and this role is generally assigned to some finance person in the organization. Second important role is billing account administrator role. This role allows to manage the billing account. Any cloud member who has this billing account administrator role can actually see the bills, make the payment for those bills, can do the billing export, link or unlink a project from the billing account, or can manage the role assignment for the billing account. And this is a very powerful role in terms of billing account. But keep in mind that billing account administrator cannot create a new billing account. This role is generally assigned to cloud admin in the organization, and this is how in GCP you can separate the responsibilities to create and manage the billing account by using the different roles. Next important role is billing account user role, which allow cloud member to link a project to billing account. And in general, any user who can create a project should also have the billing account user role so that new project can be linked to the appropriate billing account. So this role is generally assigned to project owners so that they can link their project to billing account. We generally assign both project creator and billing account user role to the project owner so that project owner can create a project and can link that project to billing account. And last important predefined role is billing account viewer role. This role allows cloud member to view the bills and transactions. This billing account viewer role is useful for someone like an auditor who should be able to read the billing account information. But keep in mind that this billing account viewer role does not allow you to change any billing related information. This role does not allow any modification. It is just a view only role. In this video, we will learn about how to create members and assign predefined roles to them. For this, let's go to IAM first. So on this page, you can see some of the members over here, and you can also see the roles assigned to these members over here. Like first two members are actually the service account, and this is my email ID. Just notice one thing here is that these roles are defined at the project level, which you have selected at the top over here. Since this project was created at the time of Google account creation, so I am the owner of this project. And the service account have been given the project editor role. You can also see the same information under the roles tab. Like here, you can see that both service accounts have the project editor role and owner role is assigned to me. If you want to make some changes in the role assignment for any member, then click on the edit button. Here on this page, you can either delete the current role assigned to the member by clicking on the delete button, or you can change the currently assigned role from this list. Here, first you need to choose the service from the left side and then select one of the predefined role related to the chosen service. Like if you select the BigQuery service here, then you can select any of the roles from this list. In this list, these three roles are the primitive roles related to BigQuery, and remaining roles are the predefined roles which are managed by Google Cloud. In the same way, you can also add the another role for the member by clicking on this button. As of now, I do not want to make any changes in this current mapping, so I will simply cancel this. Now I will show you how to add a new member and assign role to that member. For adding a new member to your project, just click on the add button over here. Here you need to provide the email ID of the member to whom you want to add. Let me provide the email ID. Just remember one thing here is that addition of a new member here does not mean that you are creating a new email ID. This email ID must already exist. Here you just add the email ID as a member in your cloud so that this member can do certain operations in your cloud. And what operations this member can do will depend on the what role you assign to this member. After this, you just provide the role to this member in the same way as I explained you during how to modify the role for a particular member. Now let me assign the role of a BigQuery admin to this member. You can also enable this checkbox to notify this member via email about this role assignment. Now click on Save button. And here you can notice that this email ID has become a member and BigQuery admin role is given to this particular member. So this is all about the member creation and the role assignment in GCP. If you have any queries related to this, please post your queries. In previous video, we learned how to create members in GCP and assign primitive or predefined roles to those members. In this video, we will learn how to create custom roles in GCP and how to assign them to members. So for this, let's go back to IAM once again. On this page, you will notice that editor or the owner role are already assigned to these members. And since primitive roles are very broad level roles, so it gives too many permission to these users. And it is against the principle of assigning the permission with least privilege. Ideally, we should not give any extra permission to a member which is not required by that member. So, to adhere to the principle of least privilege, we will now create a custom role. To create custom role in IAM, select the role option. Here on this page, you can see that so many roles are already there. These roles are predefined roles which are managed by GCP. If you want to see the list of permission for any role, then just select that role. And here you can see the list of permissions under this particular role. Now to create custom role, there are many ways. If you want to create a custom role based on already existing role, then you need to select the already existing roles from here and then click on create role from the selection button. Here you need to provide the title, description and ID for your custom role. And here you can see the list of permissions which are copied from the selected roles. From this list, you can remove some permissions as well to do the more customization for your custom role. Like I can remove this permission from here. In the same way, if you want to add more permissions for your custom role, then click on the Add Permissions button. Here you can see the complete list of all the permissions available in GCP and you can choose any permission from this entire list for your custom role. Once you are satisfied with all the permissions, then just click on the Create button to create your custom role. And here your custom role is created with all the permissions that you selected on the previous page. In the same way, you can create a custom role directly by clicking on the Create Role button. In this case, no permission is copied from any existing role. In this case, you have to define all the permissions explicitly to this role in the same way which I explained a while ago. So here once again, you need to provide the title, description and ID for your custom role. Now click on the Add Permissions. Here you can do the filtering of the permission based on the role. So let's say if I select the storage admin role, here I can see list of permissions under this particular role. So let me select some permissions from here. Now click on Add button. Here you can see the list of permissions which you have just selected. Once you are satisfied with all the list of permissions, then click on the Create button. And your custom role is created over here. And here you can see the list of permissions that you selected for your custom roles. Once these custom roles are created, you can assign these custom roles to any member in the same way as you assigned the predefined roles to a member in the previous demo. Let me show this to you. For this, let's go back to IAM main page. Now let's say if you want to assign this custom role to this member, then click on the edit button over here. Then click on add another role. Then from here, you need to select your custom role that you want to assign to this member. Now click on save button. So now here you can see that this custom role is assigned to this particular member. So this is how we can create custom roles and assign to any member in IAM. If you have any queries related to this, please post your queries. In this video, we will look at how we can manage or create a service account in GCP. Service account is a special kind of account which is used either by an application or by a VM instance. It is not used by human user. Applications uses service account to make an authorized call in GCP. Like if you have an application running inside your compute engine VM instance in GCP, and this application need to write some objects in cloud storage bucket. So how can you achieve this? In such case, you can create a service account in GCP and can give the role of cloud storage object creator to this service account. After this, applications can use this service account to make a call to cloud storage service and can create objects in cloud storage bucket. Now, next question is how you can create such service account. For this, first you need to select the project in which you want to create this service account. For this demo, I will create this service account in this project. Now to create your service account, go to IAM first and then select the service accounts option from here. So here on this page, you can see the existing service account in your project as of now. To create new service account, click on create service account button. Now here you need to provide some meaningful name for this service account and the description for this service account. So let me provide these details. Just observe here that, like any other member, this service account is also identified by an email ID. And in this email ID, you can just control the prefix of this email. But suffix of this email ID is created by Google itself. Now click on Create button. Now your service account is created and next two steps are optional, which are related to assigning the roles to this service account. After assigning some roles only, this service account will be able to perform certain operations in GCP, and what operations this service account can perform is dependent on the permissions assigned via role to this service account. Now let's assign role of object storage created to this service account so that this service account is allowed to create objects in cloud storage. In my previous video, I have already showed you how to assign roles to any member. You can assign role to this service account in the same manner. So let me assign role to this service account. In the same way, you can also assign more roles to this service account by clicking on the Add Another Role button. Now click on Continue. In this step, here you can choose who can control or administer this service account. By default, project owner has the admin rights on the service account created inside his project. But you can also specify other users as well who can control this service account over here. Here you can also specify the users who can deploy jobs or create VM using this service account. But this is an optional step and you can leave it as it is. Once you are done with this, just click on the Done button. And here your service account is created. Just observe here that no key is created for this service account as of now. But Before this key creation, you cannot use this service account for any kind of API call. Now to create key, click on the create key option from here. Here you need to select the format for your key. You can select any format here. Let's select the JSON format for this demo and click on create button. And this will create key for this service account. And you must save this key. Just ensure that this key is very safe with you because you will need this key to make any kind of API call in GCP. This is how you can create your own service account in GCP. On this page, this service account that you see over here is actually managed by Google, but this service account is managed by you. You can also make some changes into this service account, and for this you need to click on the edit option from here. Like here, you can change the name or the description for your service account. From here, you can delete the key for this service account. And in the same way, if you want to add another key for this service account, then you can do that by clicking on this add key button. I do not want to make any changes in this as of now, so I will simply cancel this. If you want to make some changes related to the role assignment for this service account, then go to members page in IAM. On this page, you need to find your service account and click on the edit button over here. Here on this page, you can do the changes in the role assignment for this service account in the same way as I explained you in my previous video. Once you are done with your changes, just click on the save button. As of now, I do not want to make any changes in this, so I will simply cancel this. This is all about the service account that I wanted to show you in this video. If you have any queries related to service account, please post your queries. Now we know that resource is something in GCP on which we want to perform some action, and role determine the set of actions which assigned member is allowed to perform on the specified resources. But how the relationship between the member and the role is established. This relationship is established by a policy, and this relationship is called as binding in policy. Policy is something that binds member to the role for the specific resource. A binding typically tells what access should be granted on resources, and it associates one or more member with a single role. And there can be multiple bindings in a single policy. In previous demo, we assigned predefined or custom role to a member at the project level, which means a policy was attached at the project level which had all the bindings which defined the relationship between the members and the roles. A policy must be attached to some level in resource hierarchy to make it really effective, and it can be attached to any level in the resource hierarchy. It means if we look at the resource hierarchy diagram, policy can be attached to organization level or folder level or project level or directly at the resource at the bottom. Policies are inherited from its ancestor as well, and effective policy is union of the policies defined at the ancestor level and the resource level both. So if I define a policy at the project level and some policy at the GCS bucket level as well, then the effective policy for that bucket will be the union of both the policies. Like if you define one policy which give the read permission to user A for all the bucket, and you link this policy at the project level for the test GCP project. Then you create one more policy which give the user A write permission for particular bucket B and attach this policy to cloud storage bucket B. Then user A can do the read operation for all the buckets in the project because of the policy attached at the project level. And user A can do both read and write operation on bucket B because of the union of both the policies defined at the project level, and the bucket level. And also remember one thing, that you can define only allow rules in a policy and you cannot define any deny rules. So if some role is assigned at the ancestor level, policies defined at the child level cannot revoke the permission which are given at the parent level. So here in this example, you cannot revoke the read bucket object permission for user A at the bucket level because these permissions are granted at the project level. Also remember one thing in your mind is that in Cloud IAM, by default, everything is disallowed. And as a standard practice, you must always follow the rule of least privilege. It means members should not be given any permission which is not meant for that member. So it is not recommended to use the primitive roles because these are very broad level roles and each role contain too many permissions. So this is how you can visualize a policy. You have both members and roles defined in a policy, and policy binds the member to the roles for the specific resource. And there can be multiple bindings in a single policy, and to make it effective, it must be attached to some resource in resource hierarchy. Next, we will look at one sample policy to understand more about the policy. Now take a look at one sample policy over here. In this example, there are two bindings in this policy. And first binding assign the role of project IAM admin to Amit, and second binding assign the role of project creator to both Jane and Amit. If you attach this policy at the folder level, then these roles will be applicable for all the projects within that folder and the resources under those projects. If you attach this policy to the organization level, then these roles will be applicable for all the children in that organization. It means it is applicable to all the folders, projects, and the lowest level resources in that organization. We have already seen how to create roles and assign roles to members. In this video, we will look at some of the important commands related to policy in GCP. Like if you want to get the policy attached at the project level, then you can use this command gcloud project get IAM policy. In the same way, there is a counter command to set the policy at the project level, that is gcloud project set IAM policy. Though this command can be used to set the policy for the project, but this is not recommended to use the set IAM policy command to set the policy. Actually, there can be a race condition if this set IAM policy command is executed by two users simultaneously in parallel. Consider a case where user 1 wants to give the cloud storage admin role to Tom via set IAM policy, and at the same time another user 2 also wants to give the same role to another user, that is Neha. In such case, there is a race condition and only one cloud member, either Tom or Neha, will be given the cloud storage admin role. So next question is how to solve this issue. To solve this issue, we must use more granular commands like add IAM policy binding to add the policy binding to a project and remove IAM policy binding to remove the policy binding from a project. These commands are more granular as these commands add or remove one binding at a time, and these commands are atomic in nature. In addition to roles, permissions, and policy binding in IAM, we can also define the organization policy. By using the roles, permission, and policy binding, we can control like who can perform what action on a particular resource. But it does not allow us to create some top level rules like do not allow to create some resources in a particular region by any team in the whole organization. But the organization policy allows us to create such kind of organization wide rules. Organization policy provides a centralized and programmatic control over your organization cloud resources. The organization policy service actually complement the roles, permission, and policy binding defined in IAM. Identity and access management focus on who, that allow the administrator to control who can take what action on a specific resource based on the permission. But the organization policy focus on what, that allow the administrator to define the limits, or you can say restriction on a specific resource in the way how these resources can be configured. The organization policies are defined in terms of constraints on resources, and These constraints are the restriction on cloud services. Organization policy is applicable to all the users in your cloud rather than a specific set of users or group, where policy binding binds a particular member like a group, service account, or individual member with a particular role. Like if you want to restrict all the users from creating a bucket in one region like Asia region, then you must define the organization policy. Once you define this kind of organization policy, then no user can create the bucket in Asia region even if IAM policy has given the create bucket permission to some users. And always remember that the organization policy has the highest priority. So, if some action is restricted by the organization policy, then no user in the whole organization can perform that restricted action in cloud, even if the required IAM role is assigned to any user to perform that action. This organization policy allows us to define the compliance boundaries for all the project teams. Because once organization policies are defined, then project owner and their team can work easily without worrying about any policy violation for the compliances defined by the organization policy. As the organization policy administrator, you can define an organization policy either at the organization level or folder level or at project level. And these policies are inherited by the children of the resource hierarchy node for which these policies are defined. Like if you define the organization policies at the folder level, then these policies will be inherited by all its project level nodes as well. But keep in mind that child level node can override or you can say deny the organization policies defined at the parent level. So if you want to see the organization policies defined in your cloud, then click on the organization policies in IAM section. And here you can see the list of predefined organization policies. But you cannot use any of these policies in free tier account because there is no organization in free tier account. To use any of these policies, you first need an organization defined in your cloud account. Like if you want to disallow to use any external IP address for any VM instance, then you can use this organization policy. And I will recommend you guys to check this list at least once. In this video, we will talk about one more important thing that we all must understand in IAM, that is audit logging. Cloud Audit Log maintains 3 audit logs for each Google Cloud project, folder, and organization. And these are admin activity log, data access log, and system event log. Throughout this course, we will interact with GCP and perform various actions like creating a role, assigning a role, creating a VM, creating a bucket, and so on. And in such case, how we will answer one question, who did what, where, and when in our system. Answer to this question is given by audit logs. So what are audit logs? There are 3 kinds of audit logs in GCP: admin activity log, system event log, and data access logs. Admin activity logs log the other administrative action that modify the configuration or metadata of resources. Example of such logs are creation or deletion of a role, or creation of a VM, or creation of a GCS bucket. These logs are enabled by default and cannot be disabled by the users. It means these logs will always be created and there are no charges for such logs. Second type of audit logs are system event logs. These logs also monitor the admin activities, but these activities are not triggered by the user action. These logs track the event for the Google Cloud administrative actions like live migration of a virtual machine. These are also enabled by default and you cannot disable these logs. And there are no charges for these logs as well. And last type of audit log is data access log. These logs monitor the user action related to user specific data. These data activity logs are also of 3 types. First type of data access log is admin read logs. Admin read log write the log entries for the API to read the configuration or metadata of resources. Example of such logs are getting the list of roles or getting the list of GCS bucket. Next type of data access log is data read log. Data read logs capture the user-driven API calls that read the user-provided resource data. Example of such log is getting the list of objects or reading the objects in bucket. Another type of data access log is data write logs. Data write log capture the user-driven API calls that write user-provided resource data. Example of such log is creating the object in bucket. Here, just remember one thing, that these data access logs do not record the data access operation on a resource that are publicly shared. These logs are disabled by default and they can be quite large in size. If you enable these logs, then you might need to pay the charges for these logs. In IAM, you can enable or disable these data access logs for the various API. Now let me show this to you in our next demo. In this video, we will learn about how to control and view audit logs in GCP. To control audit logs, let's go to IAM and then select the audit logs option from here. On this page here, you can see the list of all the APIs in GCP and also observe here that logging is disabled by default for all the APIs. Like for this API, you can see that logs for admin read, and data write are disabled by default. You can also check the same thing by selecting API from here. And here you can see that logs for admin read, and data write are disabled by default. You can enable any of these logs just by selecting the respective checkbox. So let me select all the logging for this API. And now click on Save button. So this is how you can enable logging for any API in GCP. But here, just keep one thing in your mind, that these logs are chargeable and you might end up paying charges for these logs if the log size cross your quota limit. So to avoid any kind of a surprise charge, you can disable these logs as of now. And now click on Save button to disable these logs. On this page, you can also enable these logs for the API by default by clicking on this button. Like here, if you select any of these checkbox and click on Save button, then the respective logging will be enabled for all the APIs by default. Now, next question is, where can you see these audit logs? To see the audit logs, there are two places. First is activity page on GCP dashboard. Here on this page, you can see all the admin activities happening inside your GCP. Like these are the activities because of changing the IAM policy in your project. And these are the activities because of creating the dataset in BigQuery in our previous demo. From here, you can do the filtering of these logs. Like here, you can filter these logs either based on the activity types or you can filter these logs based on the resource type. Like if you want to see the BigQuery logs only, then select this option and click on OK button. And now it will show you the logs which are related to BigQuery only. And from here, you can change the time range for the logs which are appearing over here on this page. Like if you are interested in seeing the logs for last 6 hours only, then select this option. So this is how you can see the admin activity logs in GCP via Cloud Console. In addition to this admin activity page, you can also check your audit logs in Cloud Logging, which is also known as Stack Driver Logging. Cloud Logging, in fact, is a general purpose tool to capture and view logs in GCP. Now let's go to Cloud Logging. Here in cloud logging, you can see all types of logs which are captured in GCP in more detailed manner. Here on this page, you can select the particular type of log as well. Like if you want to select the activity log only, then select this option and then click on add button and now run this query. Now it will show you the logs which are related to activity only. If you want to see the detailed message of the log, then click here and then from here you can see the full detailed message of the log. You can also do various other kinds of filtering as well on this page. I will create a separate video for cloud logging and you can learn cloud logging later in this course. This is all about the audit logs in GCP that I wanted to show you in this video. If you have any queries related to this, please post your queries. Hello friends. In this section, we will learn about Google Compute Engine service. Google provides various compute options as part of its compute offering. And all these compute services here allow us to create resources in GCP which help us in deploying our application code and executing it. To deploy and use any application, we primarily need three types of resources. First, we need the physical machine or you can say virtual machine to host the application. Earlier, we used to have actual physical machine in our own premise data center. But nowadays in cloud, we prefer to use compute service like Compute Engine VM instance. In cloud, we use all the cloud services using a rental model. We cannot buy any physical device in cloud. Second thing that we need to deploy our application is disk and memory, which is used to store the application data. We also need networking to interact with the application and to connect with the hosted machine inside the cloud. As of now, GCP provided compute offerings are Google Compute Engine, Google App Engine, Google Kubernetes Engine, Cloud Function, and last option in this category is Cloud Run. Google Compute Engine, or you can say GCE, is a part of Google's infrastructure as a service offering, where you can build high performance, fault tolerant, and massively scalable compute nodes to handle your application's need. Fully customized virtual machine instances can be created by using the Compute Engine service. Google App Engine is a platform as a service compute offering for developing and hosting the web applications inside the Google's managed data center. In this case, applications are deployed and run across the multiple servers. Google Compute Engine is used for the container-based application and it manages the whole container lifecycle for deploying, managing, and scaling your containerized application using the Google's infrastructure. The GKE environment consists of multiple machines which are grouped together to form a cluster. Cloud Function is a scalable pay-as-you-go function as a service to run your code with zero server management. It is purely serverless compute option in GCP. It manages both your code as well as your infrastructure. It makes easier for the developer to run and scale your code in the cloud. Cloud Run is the latest offering as compute service by GCP, which allow you to run HTTP invocable containers. It is fully managed compute platform for deploying and scaling the containerized application quickly and securely. We can use Kubernetes engine to run the containerized application in Google Cloud, but at the cost of management overhead. On the other hand, Cloud Run is Google managed and serverless service. We can categorize these compute services based on how much control user has on these cloud services. We can select either infrastructure as a service option like compute instances, which gives almost full control to the user. In this case, user can select any kind of configuration based on the business needs. We can also go with platform as a service option like Google App Engine, which is a kind of balance between the configuration and agility. It is faster for the user to use these services as this option requires less configuration to start with. Another option is software as a service like Cloud Function. These are serverless auto-scaled services, which means no operation headache for the user. While deploying any application in on-premise environment in traditional way, we usually have various concerns, like predicting the traffic for each service. and we need to take care of scalability of application in this case. To meet the challenging demand of application traffic, we must deploy our application in a way that can scale up or scale down automatically. We also have the risk of service going down, maybe due to some hardware failure, or it could be because our application is not able to scale well to meet the increasing load on application. Another challenge in case of on-premise environment is overpaying for the unused capacity. Actually, in case of on-premise environment, we generally buy resources by keeping peak load in our mind. But that peak demand happens only for small amount of time. So all the resources are not used all the time, which means we pay extra for the idle resources. And definitely in case of on-premise environment, we have to manage all the services on our own, which is definitely a big pain. As we move towards software as a service option, we can offload these concerns to Google Cloud and focus more on the business use case. But it comes at the cost of less control over the resource configuration in cloud. As per this diagram, as we move from bottom to top of this triangle, user will lose more control in terms of configuring the resources in Google Cloud. But this will give more agility to the user. It means as we move more towards the software as a service model, we will have faster turnaround for running our application. But in this case, we will have less option for the environment customization. But there are many cases where managing resources on our own is really very painful for customer. So it makes complete sense to use software as a service model and focus more on implementing the business use case. For example, setting up of big data cluster and machine learning model is not easy in our own data center because of high dynamic scalability requirement and lack of enough data to create the machine learning models. In this case, it makes more sense to use cloud service in software as a service model. It will save both time and money for the customer. So here we can see the pyramid of the Google Compute Services in terms of how much configuration control user has for the particular compute service. Virtual machine here is at the bottom of this pyramid and provides the complete flexibility and infrastructure control. Using this service, we can decide the size of machine, type of operating system, type and size of the disk as well. We can also choose networking options as well and various other customization we can do with this. It can be used to execute any kind of workload. It is part of infrastructure as a service. Kubernetes also provides great flexibility in terms of controlling the configuration of the compute service, but it is primarily used for container-based application. Using this, we can launch container both in Google Cloud or in our own data center. Cloud Run and Cloud Function are at the top of this pyramid. Both these are completely Google managed and serverless option to execute the code in Google Cloud. Cloud Function is used for the event-based application processing and it is highly scalable. Since these are Google managed services, so in this case, users do not have much control on configuration of the machine or VM used for executing your code. Both of them follows the pay-as-you-go model. It means you are charged only for the time when your code is running. Google App Engine is good option for hosting the web application with less maintenance overhead. So it lies somewhere in the middle of this pyramid. That is all about the introduction of compute service offered in GCP. In this section, we will mainly focus on Google Compute Engine. In this video, we will discuss about the features of Google Compute Engine and some of the use cases where we will prefer to use Compute Engine as a compute service. A Google Compute Engine instance is a virtual machine running on Linux or Microsoft Windows configuration. A compute engine allows you to create and run virtual machines on Google's infrastructure. Compute engine offers scale, performance, and value that allow you to launch large compute clusters on Google's infrastructure. There is no upfront investment, and you can run thousands of virtual CPU on a system that offers quick and consistent performance. GCE competes with other cloud provider services like Amazon's EC2 service. It is a part of infrastructure as a service offering in Google Cloud. And in case of compute engine, users have full control over the infrastructure customization. VMs are available in number of CPU, RAM configuration, and Linux distribution. Users can easily create fully customized VMs by using the instance template and instance group, where they can customize the hardware, OS, disk, and other configuration options. GCE allow you to do the network customization as well for the VM. Users can select the region and the zone where certain data resources will be stored and used. It also supports the OS level customization, which is not provided by any other compute offering in Google Cloud. Compute Engine Service allow users to create and use the custom image to create VM. Customers may use their own system images for creating the custom virtual machines. GCE service can be managed through a RESTful API, command line interface, or web console. GCE API provides administrator to define the virtual machine configurations, DNS server, and load balancing capabilities. Also notice that with Compute Engine, data is stored in persistent disk and data at rest is encrypted. In case of Compute Engine service, user can do SSH into VM instances. GCE supports per second billing after minimum 1 minute of billing. It means after 1 minute, instances are charged in 1 second increment. GCE also supports CDN. In GCE, network performance is defined by number of CPU. Compute Engine Service also supports live migration of VM, which means VMs can be moved to different physical machines without affecting the running application. GCE offers flexible pricing and various kinds of discount like committed use discount, sustained use discount, or inferred discount. To achieve high availability, you can use the load balancer with GCE via instance group and configure the auto scaling for the VM. GCE also supports the auto restart of VM in case of some kind of failure. We prefer to use Compute Engine service when we have use cases where we need full infrastructure control of the hosting platform, or we need some kind of OS level customization which is not possible in other compute services like GKE or App Engine or Cloud Function, or we want to port the existing application to cloud without much rewriting the existing application. We also prefer Compute Engine when our application does not support the containerization. So this is all about the introduction of Compute Engine service. Next, we will learn about all these things in more detail. So just continue with your learning. Whenever you need to run some application, then there is one important question that you have to answer for sure, and that is what kind of machine configuration is needed for this application. Answer to this question always depends upon the nature of your application and based on your use case. You might need either a VM which is more compute intensive, or it could be a memory intensive if you are running some kind of data analytics workload, or it could be a balance between both compute and the memory for the workloads like some kind of a web application. If you are running your application in your own data center, then you generally purchase the machine which match your requirement. But how you will do the same thing in Google Cloud? Definitely, you cannot buy machines in Google Cloud, but Google Cloud helps you in answering this question by giving you an option to choose the machine type for your application. These machine types are actually the template of the virtualized hardware that will be available to the VM instance. And these machine type defines the CPU, memory, disk capabilities, I/O operations, and so on. In Compute Engine service, machine types are actually grouped based on the different kind of workloads, and we call each machine type group as machine type family. While creating a VM instance, you need to select one of the machine type from any of these machine family, and each machine type has different pricing. So we are charged based on the type of machine selected at the time of VM creation. In GCP, there are predefined machine type and custom machine type. And whenever you create a new VM instance, then you have the option to choose either predefined machine type or custom machine type. In case of predefined machine type, which CPU is used and how much memory will be available, and many other such configurations are decided by the selected machine type. But in case of custom machine type, you have the complete freedom to choose any CPU and memory size supported by Google Cloud. In GCP, predefined machine types are managed by Google, and there are three machine type families at high level. First one is the general purpose machine. General purpose machines are balanced between the processing power and memory, and it is good for the most common application needs like small database, your development or testing environment, web applications, and mobile gaming. and it offers the best price to performance ratio for a variety of workload. Second option here is memory optimized machine type. Memory optimized machine type are ideal for the memory intensive workload because they offer more memory per core than any other machine type, and it can provide up to 12 terabyte of memory. These are used for the workloads like large in-memory database like SAP HANA and in-memory data analytics workloads. Last option is compute optimized machine type. Compute optimized machine type offers the highest performance per core on compute engine, and these are optimized for compute intensive workload. You prefer such machine type for the workloads such as high performance computing, gaming servers, and latency sensitive API. Most of the time, your requirements will be met by using one of the predefined machine type because Google Cloud provide a good range of options under each machine type. But still, if none of these predefined machine types match your requirements, then you can completely customize the machine type to fit your CPU and the memory needs. This is ideal if you have a workload that requires more processing power or memory than what is offered by the Google provided predefined machine types, or if you need GPUs. But before using a custom machine type, just notice that you might need to pay small premium amount to use the custom machine types. It means it will cost slightly more to use a custom machine type than an equivalent predefined machine type. In addition to predefined and custom machine types, Compute Engine also provides graphics processing units that you can add to your virtual machine instance. You can use these GPUs to accelerate the specific workloads on your instance, such as machine learning and data processing. Just remember that as of now, GPU is not supported for each machine type. You can attach GPU only to general purpose N1 machine types. Now let's talk about CPU platform as well. It is closely linked with machine type. When you start a VM instance on Compute Engine, the instance uses one of the CPU platform available on Compute Engine. CPU platform determines the CPU processor used in that instance. Compute Engine offers both Intel and AMD processor for your VM, and each zone has the default processor for that zone. If you do not specify the CPU platform at the time of creating a VM instance uses the default processor of that zone where instance will run. You can also specify another processor instead of using default processor if it is available in the selected zone. Choice of CPU processor also depends on the type of machine selected, and each processor type is not available for all the machine types. For a list of zones and the available CPU processor for different machine types and the machine type comparison, please look at the page mentioned by the URL in the resource section of this video. In this video, I will show you various machine type options available in GCP. And to look at the machine type options, first let's go to Compute Engine. Now click on Create button. Now let's try to create a new VM instance. And for this, here you need to provide the name for your VM instance. Next, add labels for this VM instance. These labels are key value pairs which helps in organizing the resources in your project. Generally, labels are given to any resource in GCP to identify which team or environment particular resource belongs to. You can also apply labels for the resources based on the function or application name as well. And by using these labels, you can group together related resources. For example, a common practice is to label the resources that are used for the same purpose. Like we apply label for the production, staging, and development environment separately, so that you can easily search for the resources that belong to each development stage. Now I will add one label to this VM instance to identify the purpose of this VM. In this way, you can add one or more labels to this VM instance by clicking on the Add Label button. Now click on this Save button to save these labels. Next, Here you need to specify the location of your VM in terms of region and zone. Ideally, you should prefer to create a VM closer to your customer. If VM is created in one zone, then other associated resources like storage disk or IP address must also be in the same location for the better performance. I will keep the location as it is for the timing, and after location, you need to select the machine configuration as per your business needs. Here under this machine family section, you can see four type of machine family: general purpose, compute optimized, memory optimized, and GPU. And you can choose any of the machine family based on the processing and the memory needs of your application. Here under general purpose, you can select either first generation or the second generation of machine. And this machine generation specify the type of processor used in your VM. Under compute optimized, only C2 series is available. Here C represent the compute optimized. And in the same way, under memory optimized, only M1 series option is available. Here M represent the memory optimized. Another machine family type option is GPU, which is optimized for machine learning and high performance computing needs. And here you can select either A2 or the N1 series type. After selecting machine family, you need to select the machine series type, which determines the number of CPU and memory size available for the VM instance. Like if you select E2 general purpose machine series over here, then you will have various options of machine type available like shared core, standard, high memory, and high CPU. Just remember that shared core machine type is the cost-effective way for the workload which are not resource intensive. And shared core machine type use the context switching to share a physical core between CPU for the purpose of multitasking. This can be a good option for running the small and the non-resource intensive application. Also notice that these shared core machine type offers the busting capabilities that allow instances to use additional physical CPU for the short period of time. And this busting happens automatically when your instance requires more physical CPU than the originally allocated. And this share core option is not available for all machine series. Like if you select N2 series, then you will not have any choice to select the share core machine. And let me show this to you. Let's select the N2 series this time. And this time we do not have any choice to select the share core machine. Under compute optimized, you have only one machine type option available for your VM, and that is standard machine type. Similarly, in case of memory optimized, you have mega memory and ultra memory machine type options available for you. And under GPU, you can select either A2 high GPU or A2 mega GPU machine type. You can add GPU to your VM instance only if you choose A2 or the N1 machine series. And if you add GPU to your VM instance, then the cost of your VM will increase significantly. Let me show you the cost as well. Here you can see that this GPU is added to your VM, and this is the cost of this GPU only. If you remove this GPU and select any other machine family, then the cost of your VM will go down significantly. And here now you can see the cost of your VM. Here you can override the CPU platform as well if the option is available to you. Like if you select the E2 series here, then you have no option to override this CPU platform. On the other hand, if you select the N1 machine series here, then you have various options to override this CPU platform. So this is all about how you can choose the machine type for a VM as per your application need. Next, we will learn about the various disk type options available in Compute Engine. After choosing a machine type which covers the CPU and memory, it is time to choose disk or the storage option for your VM. While creating a VM, we need to create at least one disk, which is your boot disk. Boot disk contains the operating system. If your application requires additional storage space, then you can add one or more additional storage options to your instance. Compute Engine offers several types of disk storage options for your instances, and each disk option has the unique price and performance characteristics. You choose these disk types based on the factors like data reliability that your application needs, or performance or IOPS requirement for your application. Now let's look at each disk type option. First option is local disk. Local disk is actually the physically attached disk to your VM instance, and local disks have high IOPS and lower latency than the persistent SSD disk. It is ephemeral in nature. It means data is lost if the instance is stopped or deleted. In case of local disk, data is encrypted at rest using the Google managed keys. Customer managed keys for the encryption are not supported as of now for the local disk. These storage disks are good for caching of data that is not stored for long-term use, or data that can be easily rebuilt in case of data loss. Local SSD disk cannot stretch across zones, and it cannot be load balanced. Since local SSD disk is physically connected to your VM instance, data in the local disk will be lost during the live migration of VM instance. Next disk type is persistent disk. Persistent disks are the durable network storage devices that your instances can access like a physical disk in a desktop or a server. Data on each persistent disk is distributed across several physical disks, and Compute Engine manages the physical disk and the data distribution for you to ensure data redundancy and optimal performance. Data is distributed across zones or regions based on the location of disk. Regional persistent disks provide durable storage and replication of data between two zones in the same region. So, regional persistent disks provide more availability than zonal disks. Regional persistent disks provide synchronous replication for the workloads that might not have application level replication. Persistent disks are located independently from your virtual machine instances, so you can detach or move the persistent disk to keep your data even after you delete your instances. A persistent disk lifecycle is not tied to the particular instance, making them flexible and easily migrated. If you use persistent disk with your VM, then data will not be lost even if you stop or delete the VM instance. Data in the persistent disk remain encrypted either with system-defined keys or customer-supplied keys. If you are using persistent disk, then you can resize the disk and migrate instances with zero downtime. You can resize your disk to add more storage space, throughput, and IOPS. Persistent disk scale in performance as the capacity increases. Persistent disk also support the snapshot, and each persistent disk can be up to 64 terabyte in size, so there is no need to manage the array of disks to create the large logical volume. Also notice that you cannot attach a persistent disk to an instance in another project. Since persistent disk is independent of your VM instance, so persistent disk can be used during the live migration of VM instance. Data in the persistent disk will not be lost during the live migration of your VM instance. And also remember that it can be shared as read-only disk between the multiple VMs as well. Compute Engine service offers the several type of persistent disk for your instances. First option here is standard persistent disk, and it is backed by standard hard drive, and it is ideal for efficient and reliable block storage. Standard persistent disk is available with a single zone only. Next option is balanced persistent disk. Balanced persistent disk is backed by SSD, and it balances the performance and the cost, and it is a good alternative to SSD persistent disk. Last option here is SSD persistent disk, which is highest performing persistent disk, but it has highest cost too. In addition to local and persistent disk, you can also use file server or distributed file server with NFS v3 or SMB3 capabilities with your VM. Now let's look at how to create a boot disk and the additional disk in a VM. To create boot disk for your VM, go to boot disk section, and here it will show you the default image for this boot disk. You can change this default image by clicking on the Change button. To create a boot disk, you need an OS image, and for this, you can select either public image or custom image. You can also create boot disk using the snapshot or existing disk as well. Here, you can select the operating system that you want to choose for this boot disk. And here, you can select the specific OS version for the selected operating system. And here, you can define the type and the size of your boot disk. Here, you can select the disk type as either balanced persistent disk or SSD persistent disk or standard persistent disk. That is based on the business use case and the throughput that you need. As of now, I do not want to change the default image or any other setting for this demo, so let's cancel it. Now to specify the additional property for this boot disk, click here and then select the disk option. Here you can select this checkbox if you want to delete this boot disk when the instance is deleted. And here you can select the encryption option for this boot disk. Here you can choose either Google managed keys or customer managed keys or customer supplied keys. It will basically determine who is responsible to manage the encryption keys. And these encryption keys will be used to encrypt the data stored on this boot disk. Here you can give the meaningful name to this boot disk. You can refer this boot disk by this name while mounting or resizing this disk. This name can be either decided by the compute engine based on the instance name, or you can give the name of your choice as well. So this is how you can add a boot disk to your VM. You can also add additional disk to your VM if you want to do so. And to create additional disk for your VM, click on the Add New Disk button. Here you need to provide the name and the description for this additional disk. Here again, you need to select what kind of disk you want to create. You can select either balanced persistent disk or SSD persistent disk or standard persistent disk or local SSD disk as well. Before choosing the local SSD disk option here, keep one thing in your mind that if you choose the local SSD disk option here, then you will lose the data stored on this disk in case your VM is restarted or deleted. Here you can define the snapshot schedule to create the automated backup for your disk. I will cover this later on in this chapter. In source type, you have to decide how you want to create this disk. Do you want to create the blank disk or you want to create this using the image or the snapshot? Under mode, you have to decide whether you want to create read-write disk or you want to create the read-only disk. Read-only disk can be shared across multiple VM and may contain the common shareable data. Here, this deletion rule specifies what should be done with the disk after this instance is deleted. You can either choose to delete the disk or keep it as well after the instance is deleted. Next, you need to provide the size of the disk over here. Here, it will show you the performance metrics of the disk based on the type and the size of disk. If you increase the size of your disk, then your performance metrics will also increase. Here again, you can decide how you want to manage the encryption keys for this disk, and here you need to give the name to this disk. Once you define the whole configuration for your disk, then click on the Done button and it will add the disk to your VM as per your selected configuration. And this is how you can create the disk in Compute Engine VM instance. Now let's try to understand what is an image and how to use it. But to understand about the images, first go to the Images section under Compute Engine. An image basically contains a bootloader, an operating system, file system structure, and any other software customization needed for your deployment. And the image describes what actually gets loaded onto the boot disk of your Compute Engine VM instance. As you can see on this page, Compute Engine offers many pre-configured public images that have compatible Linux or Windows operating system. Your own custom images will also be listed here if you create some custom image for yourself. You can select any of these operating system images to create and start the Compute Engine VM instances. And Compute Engine use your selected image to create a persistent boot disk for each instance. Like if you want to use this image, then select this image, then click here and select the Create Instance option to create the instance using this image. While creating a VM instance, there are two options in terms of choosing an image to create a VM instance. First option is public image. Public images are provided and maintained by either Google or open source communities or third-party vendors. And by default, all Google Cloud projects have access to these public images and you can use them to create the VM instances. Generally, you can use most of the public images at no additional cost, but there are some premium images as well that can add the additional cost to your VM instances. Another option is custom image. A custom image is a boot disk image that is actually owned by you. It means you have complete control access for such custom image. You can create custom images from boot disk and then use the custom image to create a VM instance. But keep in mind that custom images are available only inside your cloud project. And also remember that custom images that you use to create the Compute Engine VM instances add no cost to your instances. But you have to pay an image storage charges while you keep your custom image in your project. You can also import custom images from your on-premise environment or another cloud provider like AWS as well. Custom images can be created from a VM inside your on-premise environment that has all the necessary settings and the additional software configured. Also notice that images are stored in GCS image service, which is a separate cloud service on its own. In this video, I will show you how to create a disk from a public image. For this, click on Disk option under Compute Engine. Now click on Create Disk button. Here you need to provide name and the description for this disk. Here you need to choose the location for the disk in terms of region and zone. Under source type, you can choose to create this disk either as a blank disk, or you can create the disk based on an image, or you can create a disk by using a snapshot as well. So for this demo, I will use the image option. Now from here, you can select any image from this list that you want to use for this disk. And based on whatever image you choose from this list, operating system and the set of softwares will be configured on this disk. For this demo, I will use this public image. Here you need to choose the type of disk. Here you can choose either balanced persistent disk or SSD persistent disk or standard persistent disk based on your business requirement and the required IOPS and throughput. Next, you need to choose the right size for this disk. And based on this type and the size, performance metrics of the disk will be shown over here. Here you need to select the snapshot schedule for this disk. This snapshot schedule will create the automatic backup for the disk at the regular interval. And here you can choose how you want to manage the encryption keys that will be used to encrypt the data stored on this disk. You can choose either Google Managed Encryption Key or Customer Managed Encryption Key or Customer Supplied Encryption Keys. Here you can provide the labels for the disk. These labels are used to group the related resources in Google Cloud. Like you can apply the same label to all the related resources that you create in the test environment. And then you can analyze the cost of these related resources in the billing section by using the label. Finally, click on Create button to create this disk. So here this disk is created, and just observe that this disk is not used by any instance as of now. If you click here, then you can do the various operations with this disk. Like you can create the instance using this disk. You can also create snapshot from this disk. You can also create image from this disk. You can clone the disk as well. And if you want to delete this disk, then click here. So this is how you can create a disk by using a image. In previous video, I just created this disk. Now in this video, I will show you how to create an image from this disk. Now to create image from this disk, click here and select the create image option. Here you need to provide the name for this image and then select the source type as the disk. And from here you need to select the source disk. In my case, this disk is already selected. Here you need to select whether you want to copy this image to the single region or you want to copy this image to multiple regions. From here I will select the Asia region. From here you can select the family, description and the labels for this image. But these are the optional fields, so I will leave them as it is for the time being. And from here you can again choose how to manage the encryption keys for this image. Finally, click on the create button to create this image. So finally this custom image is successfully created and you can use this image to create the another instance as well. So this is how you can create an image from a disk. Now let's look at another important aspect while creating a VM instance, that is networking. If you want to create a VM in cloud, then definitely you would like to configure its networking aspects as well. Like if you do not open SSH port for your VM, then definitely you cannot connect to that VM via SSH. To look at the networking aspects of VM, let's go back to the VM creation page once again. Here you can configure the firewall rules for your VM to restrict the access to that VM via HTTP protocol. Like if you want to run some kind of a web application inside your VM, then you have to open the HTTP port and need to configure the firewall rules to restrict from where this VM can be accessed. By selecting the right checkbox over here, you can allow either HTTP or HTTPS traffic for the application running inside your VM. To configure the more networking aspect for this VM, click here and then select the networking tab. Just remember that configuring the proper networking is very important to ensure the security of resources in GCP. Here you can attach the network tags with your VM, which will be used to define the firewall rules. Just remember that you can apply the same network tags for the multiple VMs and then create the firewall rule for all of them by using the same network tags. In networking chapter, I will show you how to create firewall rules by using the network tags. Here you can give the custom hostname as well for this VM and you can use this hostname to connect with this VM later on. Next is the network interface, which controls the choice of network where this VM should be created. By default, this VM will be created inside the default network, which is created by default with every project at the time of project creation. Network interface also controls what will be the IP address of your VM. As you can see over here, ephemeral IP address is assigned to both internal IP and the external IP of this VM. But if you want, then you can also associate the external IP address as well with this VM. Just notice that each VM will have a single network interface by default, but you can add multiple network interface as well if there are multiple networks defined inside your project. So this is all about the networking of a VM as of now, and I will explain other networking concepts in detail later on in this course. Hello friends, in this video I will show you how to create a compute engine VM instance in GCP, how to connect to this VM via SSH connection, how to start a Apache web server inside this VM, how to deploy a web application inside this web server, and how to access this web application from local machine web browser. Now let me explain what steps we will follow for this exercise. Definitely, first we will create a VM inside GCP. And to create a VM, we need to select CPU, memory, boot disk, and operating system. For CPU, I will use E2 series general purpose machine. For boot disk, I will use standard persistent disk. And for OS, I will use Linux operating system. And to connect to the web server running inside this VM from local machine, we must assign the public IP address to this VM and open the port to allow HTTP traffic. IP address that I will assign to this VM will be ephemeral IP address. Ephemeral IP address is actually a temporary IP address that is assigned to the VM every time VM is started. And this IP address goes away once VM is shut down. In case of ephemeral IP address, every time VM is started, a new IP address will be allocated to the VM. If you want to fix the IP address for your VM, then you must use the static IP address. But keep in mind that you will need to pay charges for any static IP address which is not allocated to any VM. Now let me explain the commands which are required to configure the Apache web server inside this VM and to create the web application inside this web server. And here are those commands. Here first sudo command will give you the root access to execute any other command. Second, apt update command will update the existing software package inside the VM. Third, apt install command will install the Apache web server inside the VM. And last command will actually create a single page web application inside the Apache web server. It will create an index page for your web application which will display hello world web application message. Now let's go to the cloud console and create this web server. Now to create this VM, you need to go to compute engine option from here and then click on the create instance button. Here, if you are creating your VM for the first time, then you must first enable the compute engine API for your project. This API allows you to create and run VM inside the project. Now click on this create instance button. Here you need to provide the name for this VM and from here you can add the labels for the VM. These labels are the key value pairs which will help you in grouping the related resources. And you can use these labels to analyze the cost of all the related resources together in billing section. So let me add labels to this instance. If you want to attach more labels with the VM instance, then click on the add label button once again. Now click on save button. For this demo, I will use E2 general purpose machine. And from here, you can select the location where you want to run this VM in terms of region and zone. For the timing, I will leave it as it is. Now let's create a boot disk for this VM instance. For this demo, I will use a boot disk with standard persistent disk and with Linux operating system. So let me change the boot disk type as standard persistent disk. And by default, Linux operating system is already selected. So click on select button. I will also allow HTTP traffic for this VM so that we can connect to the web server running inside this VM from local machine. To assign the ephemeral IP address to this VM instance, expand the networking section, expand this as well. And here you can see that by default, ephemeral IP address is already allocated to this VM. Here it shows that ephemeral IP address will be assigned for the internal IP and ephemeral IP address will be assigned for the external IP address as well. If you want to assign the static IP address to this VM, then you can choose this option. But for this demo, let's go with the ephemeral IP address. Now click on the create button to create this VM instance. It will take some time to create the VM instance, so I will pause this video till then. Now this VM instance is created and started successfully. And this is the external IP address assigned to this VM. From here, you can connect to this VM via SSH. So let's connect to the VM via SSH. It will open the Cloud Shell session. Here you can run any kind of Linux command like ls or pwd. Now we will configure the Apache web server inside this VM by executing all these commands one by one. Now first let's get the root access to execute any other command. Next, update the existing software package. Now we will install the Apache web server inside this VM by using this apt install command. So Apache web server is also installed on this VM. And finally, we will create a sample web application for this web server by using this last command. So my web application is also created successfully. Now I will try to access this web application from local browser. And to check this web application, open the external IP address of this VM inside your local browser. And here you can access your web application. So this is how you can create a VM in GCP and run a web server inside that VM. And this is all I wanted to show you as part of this video. In this video, we will learn about what is a snapshot and how snapshot works. So let's first discuss what is a snapshot. So snapshot is a incremental backup of your disk data, and you can also create disk using a snapshot. Compute Engine Snapshot provide a way to create one or series of persistent disk backup and each one at a specific point in time. When you take the first snapshot of your disk, then first snapshot is actually the full backup of your entire disk data. But any subsequent backup of the same disk is not the full backup of disk data. Any subsequent snapshot is just an incremental backup of your disk data that has changed since the last snapshot. Since it is an incremental backup of your data, so it takes less space to store the data backup. This way, it uses the storage space more efficiently to store the snapshot data. And definitely, because of its incremental nature, it is very fast way to take the disk data backup. You can create the snapshot in two ways. One is the manual snapshot and other is via snapshot schedule. Snapshot schedule allow you to create the automatic regular backup of your disk data, and as a practice, you should create the snapshot schedule to avoid the disk data loss. Snapshots are stored in cloud storage bucket and you cannot change the storage location of an existing snapshot. Also remember that snapshots are the global resources and any snapshot that you create is accessible by any resource within the same project. You can also share the snapshots across the projects. A snapshot can be used to create a new disk in any region and a zone, regardless of the storage location of the snapshot. Also note that snapshots are different from public images or custom images, which are primarily used to create the boot disk for the instances or to configure the boot disk for the instance templates. Snapshots are incremental and automatically compressed, so it is faster to create a snapshot than the disk, and snapshot take the less space as compared to image, so snapshot cost is much lower than the image. Just keep in mind that snapshots should not be captured while any data is being written to the disk by any application. Snapshots are generally used for migrating a VM from one zone to another zone, and you need to perform three steps for such VM migration. First, you need to create the snapshot of the boot disk of the VM that needs to be migrated. Then, create a new disk in another zone from the same snapshot, and then use the new disk in creating a VM in another zone where you want to migrate your VM. Now let's talk about how snapshot actually works. For this, just look at the diagram on this page. Diagram on this page explains the process of snapshot creation. Let's consider a case where you take the daily snapshot of your disk data, and first snapshot of your disk was taken on Monday. Since in this case it is the first snapshot, So the first successful snapshot of a persistent disk will be the full snapshot of all the data on the persistent disk. So all the files are copied in case of first snapshot. The second snapshot on Tuesday only contains any new data or modified data since the first snapshot was taken. Data that has not changed since the first snapshot is not included. Instead, second snapshot contains the reference to the first snapshot for any unchanged data. As shown here, on Tuesday, only blue color files will be considered for the snapshot since these are the only modified files since the first snapshot was taken. In the same way, the third snapshot on Wednesday contains only any new or changed data since the second snapshot. It will not contain any unchanged data from the first or the second snapshot. Instead, this third snapshot contains reference to the blocks in the first and the second snapshot for any unchanged data. So in this case, only red color file is considered for this snapshot since this is the only changed file since the second snapshot was taken. So this is how snapshot works in cloud. Now I will show you how to create a snapshot for a disk. You can create a snapshot for a disk either manually or you can configure the snapshot schedule for the disk to create the automated regular backup of the disk. In this demo, I will create a manual snapshot for the disk. And for this, go to disk option first. Now on this page, first you need to choose the disk for which you want to create the snapshot and then click here. Then select the create snapshot option. Here you need to provide the name and the description for this snapshot. Here you need to select the source disk for this snapshot. This source disk is already selected for me. Next, you need to choose the location for this snapshot. Here you have to decide if you want to create this snapshot in a single region or you want to create this snapshot in multiple regions. For this demo, I will select the Asia region. Here you can add the label for the snapshot. It is very much similar to the labels attached to your disk and it will just help you in grouping the related resources in GCP. Here you observe just one thing that this snapshot will use the same encryption which is used by your source disk. Now finally click on this create button to create this snapshot. If you are creating first snapshot for the disk, then it can take some time because it will be the full snapshot for the disk. Subsequent snapshot will not take that much time because those will be the incremental snapshot. This snapshot creation will take some time, so I will pause this video till then. So here you can see the first full snapshot of your disk. Just remember that this snapshot is bound to this project and stored in cloud storage. So this snapshot is accessible by any resource within the same project. Now this snapshot can be used to create a new disk in any region or a zone regardless of the storage location of the snapshot. So this is how you can create a manual snapshot from a disk. In this video, I will show you how to create the snapshot schedule to take the automated backup of the disk at the regular interval. And for this, first you need to go to the snapshot option and then click on the create snapshot schedule. Here you need to provide the name and the description for the snapshot schedule. Next, you need to choose the region where you want this schedule to be available and you can select any region from this list. So I will select the Asia region for this demo. Here you need to choose the location where snapshot will be stored which are created by this snapshot schedule. Just remember that you might need to pay for the network transfer fee in case the location of the source disk is different from the location of the snapshot. Here you can choose whether you want to store your snapshot in single region bucket or in multi-region bucket. For this demo, I will select the Asia region. Here you need to define the timing and the frequency for this snapshot schedule. And you can select the frequency as hourly or daily or weekly. For this demo, I will select the daily option. And here you can select the time window for this snapshot schedule. For the time being, I will leave it as it is. Here you can specify the retention period of the snapshot in terms of number of days. Any snapshot older than this period will be automatically deleted. Here you can choose what should happen with the snapshot in case the disk which is associated with this schedule is deleted. You can either choose to keep the snapshot or snapshots will be deleted after 14 days. Here you can add the labels with this snapshot schedule in the same way as it was used with the disk. Now finally click on the create button to create this snapshot schedule. Now go to snapshot schedule tab, and here you can see that snapshot schedule is successfully created. Now you need to attach this schedule with a disk to create the regular backup of the disk by using this schedule. And for this you need to go to disk option first. This time I will use this schedule with this particular disk. Now click on edit button, and from here you need to select the schedule that you just created. Now click on save button to save this configuration. This way you can attach this snapshot schedule with a disk, and this snapshot schedule will take the regular snapshot of the disk at the desired frequency. Now I will delete the association between the disk and the snapshot schedule, because otherwise it will create the multiple snapshots of my disk and I will have to pay the storage charges in this case. So to remove this association, click on the edit button once again and then select the no schedule option from here. Finally click on the save button. So this is how you can use the snapshot schedule to create the regular snapshot of your disk. Now let's look at another important concept related to Compute Engine VM instance that you must know for your exam. For this, click here. Here you can enable this checkbox to avoid any kind of accidental deletion of your VM. Here you can provide the startup script for this VM. This startup script is the piece of code that will always be executed when your instance boots up. And your VM will always run these set of commands in automated manner every time your VM is started. Here, Compute Engine allows you to create and run your own startup script for your VM to perform the automated task. Let's say if you want to install Apache Web Server in your VM, then you can create a startup script for your VM to install this Apache Web Server. By using these startup scripts, you can perform various initialization tasks such as environment configuration, downloading the dependencies, initializing services, or downloading updates, etc. Just remember that here you can define Bash or Python script as your startup script, and it can be used for both existing VM or new VM. Startup script can be linked to cloud storage as well. It means startup script can be present in cloud storage. I will show a demo later in this Compute Engine section to showcase how to use startup script while creating a new VM instance. Next is your metadata. Here you can specify the metadata while creating a new VM instance. This metadata is just like a key value pair, and every instance stores its metadata on metadata server. And you can query this metadata server programmatically from within the instance via Compute Engine API. By using this query API, you can query for the information about the instance, like instance hostname, instance ID, startup and shutdown script of the instance, custom metadata of instance, or service account information. And your instance automatically has access to the metadata server API without any additional authorization. Metadata that you define over here is actually your custom metadata. But in addition to this custom metadata, there is a default set of metadata entries that every instance has access to. Metadata is generally used in combination with startup or shutdown script because you can use this metadata server to programmatically get the unique information about an instance. For example, you can write a startup script that gets the metadata key value pair for an instance external IP. and use that IP in your script to set up a database. Now let's discuss about the preemptible VM. What is preemptible VM and when it should be used? A preemptible VM is an instance that you can create and run at the much lower price than the normal instance. But Google Compute Engine Service might terminate these VM instances if it requires these VMs for other tasks. Actually, in each zone, Google has surplus compute engine VM capacity available, and Google provides these resources at the discount rates rather than keeping those resources idle. Since preemptible instances are the excess compute engine capacity, so their availability also varies with the usage. And you can do the cost saving by using such VM in some cases. By using the preemptible VM, you can get maximum up to 80% discount. You can use these instances maximum for 24 hours and there is no SLA for such VM. Also notice that preemptible instances cannot be live migrated to regular VM instances. If your applications are fault tolerant and can withstand the possible instance preemption, then preemptible instances can reduce your compute engine cost significantly. For example, your Spark batch processing job can run on the preemptible instances because those jobs are generally fault tolerant. And if some of those instances terminate during the processing, then job slows down a bit, but it does not stop completely. So, if your job is not very time critical and can sustain the failure of few VM instances, then you can think of using the preemptible VMs for such jobs. These preemptible instances complete your batch processing task without placing any additional workload on your existing instances and without requiring you to pay full price for the additional normal instances. This way, it will lead to good amount of cost saving for you. If you want to use preemptible VM for your instance, then you need to toggle this flag to on state. Next is on host maintenance feature. This feature determines what should happen to your VM in case Google need to perform some kind of infrastructure maintenance. Do you want your instance to be terminated or you want to opt for the live migration of your VM instance to new VM instance? On host maintenance is on by default. If you opt for the live migration, then Google can automatically migrate your VM instance to another hardware in the same zone during the maintenance window, and it will ensure that your VM operates with no downtime. This is called as live migration of VM instance, and it is the key differentiator for GCP. Just remember that you can feel some slowness in your VM during this live migration window, but still your application will not be completely unavailable. Just notice that instances with the GPU attached cannot be live migrated. Also, live migration cannot be done for the preemptible VM. Now, last thing under maintenance tab is automatic restart feature. Automatic restart feature of Google Compute Engine can automatically restart the VM instances if they are terminated due to non-user initiated reason like maintenance events or hardware or software failure. If you do not want your instance to be live migrated, then you can choose to terminate and optionally restart your instance during the maintenance window. And this option is ideal for the instances that demand constant and maximum performance. And your overall application is built to handle the instance failure or reboots. Now let's do a quick recap of what we have learned under this maintenance tab, starting with startup script. Startup script is a piece of code that will always be executed when your instance boots up, and it can perform actions like environment configurations, downloading the dependencies, initializing services, or downloading the updates, etc. And you can use both Bash and the Python script for your startup script. It can be used for both running as well as the new VM, and you can store your startup script in cloud storage and you can use it from there. Metadata is the key value pair and it is stored in metadata server. And metadata server can be reached just inside from the VM. Your VM can read this metadata by querying the metadata server. Both default metadata and the custom metadata is supported, and metadata is generally used with startup and shutdown script. Preemptible VMs are the discounted VM in Google Cloud and it uses the surplus inventory available in the same zone in cloud. You can get maximum up to 80% discount and it can be used maximum for 24 hours. It is allocated based on the bidding process and the highest bid wins. It can be preempted at any time with the short notice of 30 seconds, and discounts are given only for the compute resources. Storage resources attached to the VMs are not the preemptible resources. Data will not be lost if persistent disk is used to store the data in case of preemption. And always remember that preemptible instances cannot be live migrated to the regular VM instance. On-host maintenance feature determines what should happen to your VM during the infrastructure maintenance window. And you have two options here. Either your instance will be terminated or you can opt for the live migration of your VM instance to a new hardware. Automatic restart feature can automatically restart your VM instances if they are terminated due to the non-user initiated reasons like the maintenance event or the hardware or software failure. So far, I have explained the concepts related to compute engine. Now it is time to create a VM. In this demo, I will create a VM and I will also use startup script. This script will install Apache Web Server in VM and start a web application inside VM. To create your first VM, you need to go to Compute Engine option from here and click on Create button to create your first VM instance. Here you need to provide the name for your instance. Here you can add labels for your VM and it is similar to the labels that you create during the disk creation. These labels are key value pairs which will help you in grouping the related resources, and you can use these labels to analyze the cost of all the related resources together in billing section. Let me add labels for this VM. If you want, you can add multiple labels as well for the VM. Now click on Save. Here you can choose where you want to create this VM instance in terms of region and zone. For the time being, I will leave it as it is. From here, you can choose the machine configuration that you want to use for this VM instance. Here, based on your use case requirement, you can choose either general purpose or compute optimized or memory optimized machine. Or you can choose a machine with the attached GPU. Here, first you need to select the machine series and then the machine type. And based on the what zone and the machine type you choose, default CPU platform will be selected for your VM instance. But if you want to change the default CPU platform, then you can change it from here if more CPU platform option is available for the selected machine type in the selected zone. Like if you select the N1 series over here, then you have many choice to select the any CPU platform of your choice. And you can also add GPU for your instance if you choose the N1 series over here. For this demo, I will use E2 general purpose machine. After selecting the machine configuration, you need to attach at least one disk for your VM, that is your boot disk. And from here, you can choose which image you want to use for your boot disk. Here you have choices like public image or custom image or snapshot or an existing disk to create your boot disk. Like if you want to create a boot disk based on the custom image, then click here. Here it will show you all your custom images inside this project and you can choose any custom image to create this boot disk. Currently it is showing this image which we created in our previous demo. Similarly, if you want to use snapshot to create a boot disk, then click here and here it will show you the list of snapshots that you have created and you can choose any snapshot to create this boot disk. From here, you can select an existing disk. To create a boot disk, if an existing disk is available in the same zone where you want to create your VM. For this demo, I will use default public image to create this boot disk. And from here, you need to select the boot disk type. You can select either balanced persistent disk or SSD persistent disk or standard persistent disk based on your use case requirement. Here, you need to give the size for your boot disk. Once you are done with this whole configuration, then click on select button. After creating the boot disk, here you can select the service account that you want to associate with this VM and the permission that you want to give to this particular service account. You can give either default access or full access to this service account. Or you can do the complete customization by selecting this option. Here you can select each API access explicitly that you want to give to this service account. For the time being, I will use default access for this service account. Now, if you do not want to make any other customization, then you can directly click on Create button to create your first VM instance. But I will make customization here to install the Apache web server with the help of startup script. But before doing any customization, let me show you the cost as well. So cost of this VM is $25.46 per month. And here you can see the cost of each component individually. Now to use your custom script, click here and then paste your custom script over here. This custom script will install the Apache web server in this VM and will start the web application inside VM. I will also share this script in resource section of this video. I will also allow HTTP traffic for this VM so that I can reach to the web server running inside this VM. If you want to add additional disk for this VM, then you can do it from here. Here you can do the network customization for this VM. If you want to use preemptible VM here, then you need to toggle this flag to on state. And if you use preemptible VM here, then you will observe that cost of your VM instance has gone down to $8.34 per month. And this price is much lower than the normal VM price. Also remember that preemptible VM cannot be used for more than 24 hours. For this demo, I will not use any preemptible VM. Now click on Create button to create this VM. Now this VM is created and started successfully. And you can connect to this VM via SSH by clicking over here. And you can run any command over here. This is the external IP address associated with this VM, and if you open this IP address in your browser, then it will take you to the home page of the web application running inside your VM. If you want to check other details of the VM, then click here. Here you can see the details like instance ID, machine type, reservation, CPU platform, zone, label, etc., which are associated with this VM. Now, if you want to see the logs which are generated during the VM creation, then click here. Here you can find the log entries which will show you that startup script was executed for your VM at the time of VM creation. And from here, you can either stop this VM or reset this VM, or you can delete this VM if it is not needed anymore. So this is all about how to create a VM in Google Cloud. So far, we have seen how to create a compute engine VM instance via Cloud Console. Now, we will look at how can we create a VM instance via command line interface by using gcloud compute command. So, first very simple command that we will try is gcloud compute instances create. This command will create a VM instance in GCP. Let's try this command in Cloud Shell. It will take some time to create the instance and I will pause the video till then. So this instance is created now. Here just notice that while creating this instance, we did not specify the zone or the machine type for this instance. Then from where these values are picked up for the instance. For this instance, value of the zone is same as the default zone in your gcloud configuration and you can check this via command line gcloud config list. Here you can see that value of the zone in your gcloud configuration is same as the zone of this compute instance. And N1 standard is the default machine type that is used by GCP if no machine type is specified while creating any VM instance. We can also check the list of VM instances in our project by using the command gcloud compute instances list. Let's try this. And this command will list all the VM instances created in your GCP project. These instances might be in running or terminated state. So as of now, there are 3 instances in my GCP project, and out of this, only one instance that we just created is in running state. The other 2 instances are in terminated state. Now, can we do some customization while creating the VM instance? Like, can we define the machine type while creating this VM instance? Yes, we can do that by specifying the value for the optional parameter machine type. But first, let's check the list of all available machine types by using the command gcloud compute machine type list. Here it has printed all the available machine types in GCP, and you can use any machine type from this list for your VM. This list is quite huge, and if you want to filter this list, then you can use filter option with this command. You can also use this link to read more about the options related to gcloud compute machine type list command. For the time being, let's try to create another VM instance by using F1 micro machine type. So here you can see that F1 micro machine type instance is created successfully, and this is the machine type information for this VM instance. Similar to machine type option, there are other options as well to customize the configurations of your VM instance. Like if you want to create a VM in zone other than the default zone of gcloud configuration, then you can give the value of zone by using the zone option. If you want to use some other image, then you can specify the image by using image option. By default, whenever you delete an instance, its boot disk is also deleted. If you want to stop the boot disk deletion on the deletion of VM instance, then you need to specify the no boot disk auto delete option. You can also customize the boot disk size by using the boot disk size option. I would like you to go through the other possible options with this command at this link and try these options on your own. On this page, you can find the complete details about each option. In this video, I will explain while creating a VM instance how to decide which zone should be used for the VM instance. We know that if we have to create a VM instance via command line interface, then we need to use gcloud compute instances create command. And if you want to create an instance in some particular zone, then you can specify that zone information via zone option. If this zone information is not provided in gcloud command, then gcloud configurations are looked up to find the value of zone. And if default zone is configured in the active gcloud configuration, then that zone is used to create the VM instance. In addition to gcloud configuration, you can also define the default region and the zone for the compute service at the project level. For this, you need to go to Compute Engine page, then select the settings, and then again select the settings under the settings menu. And here you can define the default region and the zone for the Compute Engine VM instance. If zone information is not specified by any of the first two choices, then your project level zone will be used as the default zone. So just for a recap, first priority is given to command line zone information. Then second priority is given to gcloud zone configuration. And third priority is given to project level zone configuration. We have already seen how to create a VM instance and check the list of VM instances via command line interface. In this video, we will learn some more commands related to Compute Engine VM instances that you must know. First such command is gcloud compute instances start. This command is used to start a terminated instance. Next is gcloud compute instances stop command, which is used to stop the running VM instance. Next is gcloud compute instances delete command, and this command is used to delete an existing instance from your project. While deleting an instance, you can choose what you want to do with the disk associated with the instance. Your instance can have two types of disk. One is the boot disk, which is mandatory disk, and other is optional data disk. While deleting your VM instance, you can decide which disk you want to delete by using the --delete disk flag. Possible values for this flag are boot, data, and all. If you want to delete just boot disk, then set the value of this flag as boot. If you want to delete all the data disk, then set the value of this flag as data. If you want to delete all the disks, then you can set the value of this flag as all. In the same way, you can also specify the keep disk flag, which is opposite of delete disk flag. And this flag specifies which disk to keep while deleting the VM instance. Next important command in queue is gcloud compute instances describe command, which will describe the specified instance. Another important command is gcloud compute instances add tags, and this command is used to associate tags with the specified VM instance. Now let's try these commands in Cloud Shell. So first, let me do the listing of the VMs currently existing in my project. Currently, there are 3 instances in my project, and that too are in terminated state. Now I will start instance 1 by using gcloud compute instances start command. So it is starting the instance 1. It will take some time to start this instance. I will pause this video till then. So this instance is started now. Let's do the VM listing once again. So here also you can see that VM instance 1 is in running state. Now I will stop instance 1 by using gcloud compute instances stop command. So it is going to stop this instance. So this instance is stopped now. Let's do the VM listing once again. So here also you can verify that instance 1 is in terminated state as of now. Now I will describe the instance 1 by using gcloud compute instances describe command. So here you can see the full detail about the instance 1 by using this describe command. Now I will associate tags with this instance 1 by using gcloud compute instances add tags command. So this way tags are also added for this instance 1. You can verify those tags by using the describe command. So here you can see the tags that we just added. Now I will delete this instance 1 by using gcloud compute instances delete command. Say yes over here. So this instance is deleted successfully. We can also verify this thing by doing the VM listing. So here you can see that instance 1 is not appearing anymore. So this is all for this demo, and I will recommend you guys to practice all these commands for sure. In previous videos, you have seen how to create a VM instance in Google Cloud by explicitly defining each and every configuration for your VMs. If you have to create your VM with different configuration, then you can create those VM like this. But if you have to create many identical VM with the same configuration, then creating VM like this is definitely not a good idea. There are some challenges in this case. First, it is error prone. You might make mistake in defining the same configuration every time for all your VMs. Second, it will be very time consuming as well to define the same configuration again and again. So, how to solve this problem? Google Cloud solves this problem by allowing you to define the template of the configuration that you need for your VM. And this template is known as instance template. By using instance template, you can define machine type, boot disk image or container image, labels, and other instance properties. In Google Cloud, an instance template is a resource that you can use to create identical virtual machine instances and manage instance groups. Just remember that instance template just define the configuration for your VM like machine type, memory, networking, and security, etc. But it does not define the location like region or a zone where you need to create the instance. It just defines the VM configuration that you need to create the VM instance. Location of the VM will be defined at the time of creating a VM instance. An instance template is a global resource that is not bound to a zone or a region. But if you specify some zonal resource in an instance template, then it will limit the usage of the template to that zone where that resource resides. For example, if you include a read-only persistent disk from your central 1B zone in your instance template, then you cannot use that template in any other zone because that specific disk exists only in zone US central 1B. Instance templates are designed to create the instances with identical configuration. So you cannot update an existing instance template or change an instance template after you create it. If you want to make some changes in an existing instance template, then you first create a copy of the existing instance template and then make the required changes. Instance templates can save your effort in case you have to run multiple VMs with the same configuration because you do not have to define the same configuration again and again to create your VM. Next, I will show you how to create an instance template and create VM using that instance template. In last demo, we learned how to create a VM by defining all the required configurations directly. In this video, I will show you how to create an instance template and use this instance template to create a VM. Instance template is a template for the VM configurations like image, disk, labels, networking, etc. And once you create an instance template, then you do not need to define these configurations individually for each similar VM that you want to create. In fact, instance template is more preferred way to create a VM. Now to create an instance template, go to instance template option over here, then click on create instance template button. Here you need to provide the name for this instance template. Just notice that at the time of creating this instance template, I will not define any location for the VM to be created by this instance template. We will define the location of the VM at the time of VM creation. Rest, all the configurations are similar to what you have already defined at the time of direct VM creation. So let's quickly define the similar configuration once again. Here you need to select the machine configurations for your VM. Let's go with E2 general purpose machine for this demo, and I will not use any GPU for this demo because it is very costly to use the GPU. I will keep all other settings like boot disk and the networking configurations as default because we have already covered how to define all these configurations at the time of direct VM creation. So now let's click on create button to create this instance template. So here this instance template is created and you can see the machine type, image and the disk type used by this instance template over here. Now to create a VM from this instance template, click here and select the create VM option. Here you can see that this instance template is already selected, but if you want to change it, then you can change it by clicking on the change button. So just observe here that you can provide the location of the instance over here in terms of region and the zone. Rest all the configurations are same what you have provided in your instance template. But if you want to customize these settings, then you can do all those customization on this page. Once you are satisfied with all these configurations, then click on Create button to create this VM. So here this VM instance is created and you can see the zone, internal IP and the external IP address associated with this VM over here. So this is how you can create and use an instance template. Similarly, you can create other VMs with the same configuration by using the same instance template. Next, we will discuss about instance group. In previous videos, to create a web server, you basically followed three steps. First, you use the free Linux OS image provided by Google to create the boot disk for your VM. Then you started this VM. And then you basically install the Apache web server and configure the web application for this web server. You perform this third step either by running the commands manually by doing the SSH into VM or with the help of startup script. It is a right solution to create the web server if you have to create only one such web server. But in case you want to run multiple identical web servers, then this is not the right approach because installing and configuring the Apache web server again and again like this is a slow process. And you can also make some mistake as well in this case. So in such case, you must follow this VM creation flow. Here, first three steps are identical to the previous flow. But once this first VM is created, then you should create a custom image of the boot disk of this VM. This image will contain all the software and their configuration required for any subsequent VM with the similar configuration. Just remember that creating a VM from the custom image is much faster than installing the software via startup script. In case of an image, no command will be executed to install any software. Everything that you need for the subsequent VM is already installed and configured in this image. So next, you must create an instance template using this custom image and then create all other VMs by using that instance template. We have already learned how to create an instance template via Cloud Console. And in this video, we will look at how can we create an instance template via command line. Actually, like Compute Engine VM instance, we will use gcloud only to manage the instance template in GCP. gcloud commands for the instance template are very much similar to gcloud commands for the Compute Engine VM instances. Like to create instance template via CLI, we will use the command gcloud compute instance template create and then name of the instance template. Let's try this command in Cloud Shell. Here I will create an instance template via this create command. And here this instance template is created successfully. Similar to compute instances, you can also do the listing of instance templates via command gcloud compute instance template list. Let's try this as well. And here you can see the listing of instance templates. And in this list, you can see your previously created instance template. You can also describe the instance template via command gcloud compute instance template describe and then the template name which you want to describe. Let's try this as well. Here I will describe the instance template that we just created. And here it has printed all the information about this instance template. If you want to delete an instance template, then you will use the command gcloud compute instance templates delete and then the name of the template that you want to delete. Let's try this as well. Here I will delete the instance template that we just created. Say yes here to confirm the deletion operation. So here your instance template is deleted successfully. You can also verify this by doing the instance template listing operation. So this time there is no instance template in this result. If you have already created a VM instance and you want to create an instance template from that VM instance, then you can do that as well by using --source instance and hyphen hyphen source instance zone flag, where source instance zone is the zone where your source VM is running. Similarly, you can also create an instance template from another instance template by using the flag hyphen hyphen source instance template. For the complete details about other possible options related to G-Cloud Compute Instance Template command, please refer to this page and practice these commands for sure. Now we have learned how to create multiple VMs with the similar configuration by using instance template. But whether we use instance template to create multiple VMs or we explicitly create multiple heterogeneous VMs one by one, we will have to manage each VM separately. It means if we create VM like this, then we will have to start and stop each VM separately. Now consider a case where all the VMs are actually different instances of the same application. It means all the VMs are logically related to each other. In such case, we might need to start or stop all the VMs together to apply any application update. So, how can we solve this concern? Google Cloud solved this concern with the concept of instance group. Instance group is another way to create and manage VMs in GCP. An instance group is basically a collection of virtual machine instances that you can manage as a single entity. There are two types of instance groups in Compute Engine: managed instance group and unmanaged instance group. Managed instance group is a group of identical VMs. It means all the VMs in this group have the similar configurations like same image, similar disk, etc. In this case, all the VMs are created by using an instance template, which ensure that all the VMs have the similar configurations. On the other hand, unmanaged instance group is a group of non-identical, or you can say heterogeneous VMs. Managed instance group is further divided into two categories based on the location of VM created by instance group. A regional managed instance group deploys instances to multiple zones across the same region, but a zonal managed instance group deploys instances in a single zone only. Just remember that you can also use preemptible VM in an instance group to reduce the cost. In case of managed instance group, VM instances are created from an instance template, and managed instance group is good for the use cases like database, batch workload, or website frontend. Managed instance group offer advantages like high availability. If a VM in the group stops or crashes, a new instance with the same configuration will be created again in case of managed instance group. You can also set up an auto-healing policy that configures the health check for your VM inside the managed instance group, which regularly monitor the health check of your VMs. You can also configure health check based on the application state running inside your VM. By using instance group, you can also configure load balancing to distribute traffic across all the instances in the group. And regional managed instance group allow you to create application which is load balanced across multiple zones. And this way, you can protect your application against zonal failure. Instances in the managed instance group can easily scale up and scale down based on the demand, and automatic updates can be easily applied in such groups. Unmanaged instance group can contain heterogeneous instances that you can add and remove from the group at any time. And in this case, instances are not created via instance template. Unmanaged instance group do not offer features like auto scaling, auto healing, rolling update support, or multi-zone support, which are provided by managed instance group. And it is not a good fit for deploying highly available and scalable workloads. You can also configure load balancing in case of unmanaged instance group. You can use such group if you need to apply load balancing to group of heterogeneous instances or if you need to manage the instance yourself. In last demo, we saw how to create an instance template. Now I will show you how to create a managed instance group using that template, which will create collection of VM in one go. And for this, you need to go to instance group option over here. Then click on create instance group button. Here on this page, you have a choice to create both managed instance group or unmanaged instance group. But for this demo, I will create managed instance group. Here you need to provide the name and the description for this instance group. Here you need to choose whether you want to create a regional instance group or you want to create a zonal instance group. Here, if you choose single zone instance group, then all the VM in this group will be deployed in single zone. On the other hand, if you choose multiple zones over here, then your VM will be created in multiple zones in the same region. And here you can select the zones where your VM will be created. For this demo, let's use this single zone option. Here you can select the instance template that you want to use with this instance group. Just remember that this instance template will ensure that all the VM in this group have the same configuration. For this demo, let me select this instance template that we created in last demo. Here, managed instance group allow you to select the auto scaling mode to automatically add or remove VM instances from this group based on the increase or decrease in load. Here, you can select any of these choices, like you can select auto scale or do not auto scale or auto scale only up option. Like if you do not want to auto scale this instance group, then you can select this option, and then here you can define the number of instances that you want to create in this instance group. On the other hand, if you want to use auto scaling, then you also need to define the auto scaling policy that the auto scaler use to determine when to scale your group. And in this auto scaling policy, you need to define the auto scaling metric and the target utilization level that will be used by the auto scaler. Here you can select any of these metrics to decide when to auto scale. You can either do auto scaling based on the CPU utilization, or you can do the auto scaling based on the HTTP load balancing serving capacity, which can be based on either utilization or request per second, or it can be any stack driver monitoring metrics. After you define the auto scaling policy, the auto scaler perform the auto scaling based on the measured load. Let me select this option for this demo, and here you need to define the target CPU utilization level. And autoscaler will add or remove the VM instances in this group to maintain this CPU utilization level on each VM instance. Now click on Done button. When you configure autoscaling for your instance group, then here you can specify the cooldown period. That basically determines the length of time that it takes for your application to initialize from instance bootup time until it is ready to serve the request. By default, this cooldown period is 60 seconds, and this cooldown period ensures that autoscaler does not launch or terminate the additional VM instances before previous scaling activity takes effect. It is generally set based on your VM startup time plus your application warm-up time running inside your VM. Here you can define the minimum and the maximum number of instances in this group. So let me define the minimum number of instances as 2 and maximum number of instances as 3. With instance group, you can also configure health check as well for the VM, which will check VM instances inside this group at regular interval. And in case any of these instances is found unhealthy, then it will be replaced by another instance. Instance group can do the health check using both instance state, or you can define your own custom health check at application level to determine the health of your instance. Now let me show you how to create a health check. To create health check, click here and then select the Create Health Check option. Here you need to define the name and the description for this health check. Next, you need to select the protocol for this health check. Here, if you select this HTTP protocol, then here you can define the path inside your application, which will be monitored by this health check. And here you can define the expected response and expected header in the response for the health check request. For this demo, I will use TCP protocol and port number as 22. Here you need to define the health check interval, which determines the frequency of your health check request. And this is the health check request timeout, which defines how long to wait for the completion of any health check request before considering the request as failed request. And these are the healthy threshold and unhealthy threshold for the health check request. Here, healthy threshold determine the minimum number of consecutive success response to consider an instance to be healthy, and unhealthy response determines the minimum number of consecutive failure responses to consider an instance to be unhealthy. Also remember that to make this health check work properly, you need to open the firewall in your network to allow these incoming health check requests, which comes from specific IP range only. For the time being, I have shared one link in the resource section of this video to explain how to create this firewall rule. In that page, firewall is open for the port 80, but remember that for this video, you need to open the firewall for the port number 22. I will explain about the firewall rules in detail later on in this course. Now, once you are done with all these settings, then click on Save button. Now click on this Create button to create this instance template. It will take some time to create this instance group along with all the VM inside this group. So I will pause this video till then. So this instance group is created with the two instances inside it. Now click here to check the more details about this instance group. So these are the two VM instances which are created by this instance group, and both the VMs are in healthy state. Here you can see the internal and the external IP address of each VM. You can also connect to these VMs via SSH from here. Also observe that the name of the instances are based on the name of instance group. You can also remove any of these VMs from this group as well. Let me show you what happens if a particular VM is removed from the group. So let me remove this VM from this group. To remove this VM from the group, click here. So now you can see that this VM instance is getting replaced by another instance because we have configured an auto scale policy with minimum number of instances as 2 instances. It will take some time to replace this VM instance, so I will pause this video till then. Now this VM has been successfully replaced. Now if you want to delete this group, then click here. So this is how you can use the instance group in Compute Engine. So far we have learned how to create a stateless managed instance group from this option. But from here you can also create stateful managed instance group. But what is the difference between stateful and stateless managed instance group, and how to decide which one to use and when? So basically there are three differentiating factors in these two types of managed instance groups in terms of what kind of workload is handled by the VMs inside these instance group, what feature each instance group supports, and what all items make a state for the VMs in stateful managed instance group. Basically, in stateless instance group, all the VMs are similar to each other, and VM do not hold any state information. And because all the VMs are similar to each other, so you can easily recreate or replace any instance in such group. VMs in stateless instance group are interchangeable. You can easily scale stateless workloads horizontally by adding or removing the VMs inside the stateless instance group. In case of stateless instance group, while updating your application, you can either delete the machine or replace that machine with a new machine with a different name, metadata, and disk. When a stateless VM is deleted or recreated, then all the data on that machine is lost. The disk is either deleted or recreated from the scratch in this case. And you generally prefer stateless instance group for the application like web front-end server. On the other hand, VMs inside the stateful instance group holds the stateful information. And in such group, each VM is like a custom machine because of its state, and it is not interchangeable by the other VM in the group. You cannot easily scale stateful workloads horizontally because scaling could require the data replication, creation or deletion of the data shard, or changing the overall application configuration. When recreating or updating a machine with a stateful workload, you must preserve the VM's unique state. You generally prefer to use such stateful instance group for the stateful applications like Cassandra, Elasticsearch, MongoDB, MySQL, Postgres, and Kafka. You can also prefer to use stateful instance group for the legacy application, which store the application state on the boot disk. Also remember that with a stateful managed instance group, you can create a failed machine while preserving its data disk. Both the managed instance group supports the features like auto-healing, automatic rolling update, and multi-zone deployment. But because of the stateful nature, you cannot use the auto-scaling for the VMs inside the stateful managed instance group. This is only possible for the stateless managed instance group. Now, what all things actually make up the state for the VMs inside the stateful managed instance group? First is the name of the instance. Second is the persistent disk attached to the VM, where each VM stores the stateful information specific to that VM. And last is the instance specific metadata for each instance in the stateful instance group. Just remember that to achieve the resilience against the zonal failure for any instance group, your application must create multiple instances in multiple zones. In the event of zonal failure, your data is served from the available replicas in the remaining zones. In this video, we will learn about what is rolling update or canary update and then how to perform such operations within the managed instance group. So first, what is rolling update? Basically, a rolling update is an update that is gradually, or you can say incrementally, applied to all the instances in a managed instance group until all the instances have been updated to the latest configuration. In case of rolling update, update is not applied on all the servers or tiers simultaneously. In fact, organization install the updated software package either on the one server or subset of the server at a time. And update here can be anything like your application version upgrade or some OS patch. Some of the benefits of the rolling update is the reduction in the application downtime and unforeseen errors while doing the software update. Next, what is canary deployment? Actually, canary deployment is very much similar to rolling deployment only. The only difference is that in case of canary deployment, first end user testing is also performed on the latest release on few instances before release is rolled out to all the instances in managed instance group. And latest update is applied to all the VMs only if end user testing is successful. While doing any such deployment via managed instance group, you need to provide bare minimum 4 things: instance group name, instance template, and then zone and the region where new instances will be created as part of the rolling update. Here, instance group name is the name of the managed instance group, and instance template is the new template name which specify the latest version of the software that needs to be updated. In addition to these 4 things, you can also define some advanced level configurations for such update, like mode, which determines when to apply an update in an instance group. And possible values for this are opportunistic and proactive. Managed instance group applies an opportunistic update in 2 conditions. One, when you manually initiate the update on the selected instances, or when new instances are created in the managed instance group. And these new instances can be created when either you or some other service like Autoscaler resize the managed instance group. And opportunistic update is generally preferred when you have a non-critical update that can be applied as necessary without any urgency. In such case, whenever new instance is created or instance is restarted in instance group, then your update will be applied on that instance. On the other hand, proactive mode is more user controlled. In case of proactive mode, updates start proactively or you can say immediately on the subset of the instances as per your specification. You can also select the instances that you want to update in case of proactive mode. Like if there are 4 instances in your managed instance group, then you can specify that update should happen only in 2 instances. So this way, it also provides you an opportunity to do the canary testing as well on those 2 instances before update is applied on all the instances in your managed instance group. Next advanced option is maximum search, which configures how many new instances in your managed instance group can be created above its target size during an automatic update. For example, if your instance group has maximum limit of 10 instances and you set the maximum search to 5, then instance group use the new instance template to create up to 5 new instances above your target size. So during this rolling update, the number of instances in your instance group can go up to 15 if your instance group is already running with maximum limit of 10 instances. Next option is maximum unavailable, which configures how many instances can be unavailable at any time during the automatic update. For example, if there are 5 instances in your instance group and you set the maximum unavailable value to 3, then only 3 instances can be taken offline at any time during the update. The other 2 instances will still remain available for serving the request traffic. And if you do not want any machine to be unavailable during the update, then set the value of maximum unavailable as 0 and maximum search value should be greater than 0 in this case. With these settings, Compute Engine removes each old machine only after its replacement new machine is created and running. Next option is minimum wait time, that specifies the amount of time to wait before considering a new or restarted instance as updated. Or you can say that it is time to wait between the consecutive instance updates. And measurement of this time starts when instance starts running and its health check also becomes healthy. So this is all about the configuration options related to rolling or canary update. In this video, I will tell you how to do the rolling update in a managed instance group. But before that, let's look at the initial setup that I have done for this demo. For this demo, I have already created 2 instance templates, where this template is used for the first version of the application and this template is used for the second version of the application. Actually, both the templates use the startup script to create the web server that print the hello world message. But this time, I have also added the version information along with the hello world message so that it becomes easy to distinguish which version of the application is actually giving the response when we make the HTTP call. I have also created this managed instance group with minimum 3 instances that use the instance template of version 1. And here you are getting this warning message because for this instance group, both minimum and the maximum number of instances are equal. Just ignore this warning message for this demo. I just created this for the simplicity purpose. If both minimum and the maximum number of instances for the instance group are same, then autoscaler cannot add or remove the instances from the instance group. Now let's check the instances of this instance group. So if you click on any of these external IP address, then you will get the hello world message that is written from the version 1 of the application. And right now, all the instances in this instance group are using the same instance template. So all of them will give the same response as of now. And now we will deploy the second version of our application by using the rolling update feature of this instance group. And for this, click here. So here also you can see that currently there are 3 instances in this instance group. And all the 3 instances are running with the version 1 template. Now to update the VM with the version 2 of the application, either you click here and then select the version 2 template to update all the VM with the second version. Or you just click here and then select the second template from here. And then here you specify the target size. Here this target size specifies how many instances in this instance group should run with the second version of the application. And you can specify this number either in terms of percentage or as a fixed value. For this demo, I will apply the second version on 2 instances only. This way, once rolling update is complete, then one instance in this group will still be running with the version 1 and 2 instances will run the application version 2. And this way, you can perform the canary testing on those 2 instances. Once testing is successful, then you can do the rolling update again to do the full rollout of the second version for all the instances. Here, under this update configuration, you need to decide how you want to apply this update. Do you want to take opportunistic approach or you want to take proactive approach to apply the update? Here, by default, opportunistic mode is selected. But for this demo, I will use the proactive mode. And this proactive mode will trigger the rolling update immediately. In case of opportunistic mode, update will happen when VM in this group are replaced or restarted, or some new VMs is created due to the auto-scaling activity. If you select the proactive approach for the rolling update, then you can also decide if you want to replace the existing VM with the new VM, or you want to restart the same VM for the update. By default, replace action is selected, and I will also use the same option over here. And if you opt for the replace option, then you can also keep the VM name for the new VM same as old VM. But I do not need this for this demo, so I will leave it as it is. Here in this section, you can define other advanced configurations. Like here, you can specify the maximum search value. That specify maximum number of new instances that can be created temporarily above the maximum number of VM allowed for this group. And here, you can define the maximum number of instances that can be unavailable at the same time. If you cannot afford to have any downtime or reduction in traffic serving capacity, then set value for this as 0. And here you can specify the minimum wait time in seconds. That determines the time to wait between the consecutive instance update. For the time being, I will keep all the settings with default value only. Now click here to start the rolling update. And after you click on this button, it can take few minutes to complete the rolling update. Now I will pause the video till then. So here you can see that rolling update is happening. This instance is getting deleted. So I will pause this video until this rolling update is complete. Now this rolling update is complete. And here you can see that these two instances are running with the second version of the instance template. And if you click on the external IP address of any of these two new instances, then you will see the hello world message that is written from the second version of the application. Let's go back. Here, this old instance is still running with the version 1 of the instance template. And if you click here, it will still give the older response. Let's go back once again. In case of canary testing, you can do the testing on these two new instances. And once you are satisfied with the testing, then you can roll out the update on all the VMs. So this is how you can do the rolling update in your managed instance group. In addition to rolling update, if you just want to replace or restart the VM instances in your managed instance group, then you can use this option. In this option, you cannot change the instance template used by any instance. You can just restart or replace the instances in the instance group. And like rolling update, here also you can define the maximum search, maximum unavailable, and minimum wait time value. And this is all what I wanted to show you in this demo. In this video, let's look at some of the important gcloud commands related to managed instance group. And first gcloud command in this list is gcloud compute instance groups manage list. And this command will give you the list of managed instance group in your project. So let's try this command in Cloud Shell. So here it is showing that as of now, there is only one instance group in this project. And here you can also see the information like name of the instance group, location where this instance group is running, then the target size of this instance group, name of the instance template used by this instance group, and here you can see that auto scaling is not configured for this instance group as of now. Next command is to create the managed instance group, and you can create the managed instance group via command gcloud compute instance groups manage create. In this command, to create the managed instance group, you need to provide name of the instance group, zone where instances in this group should be created, name of the instance template to be used by this instance group, and size of the instance group, which specify the number of instances in this instance group. And if you want to create the regional instance group, then you can also provide the regional information by using the flag -- region. So let's try this command to create the new managed instance group in Cloud Shell. Now with this command, I will create another managed instance group test mig2, and this instance group will have only one instance. Now press enter. So it will take some time to create the instance group. Here just notice that size of this instance group is currently showing as 0. It is because this instance group is just created and instance in this group is still under the creation process. So let's wait for some time for the instance to be created. Now let's try to do the listing of instance groups. Now you can see that there are two instance groups in this list, and this is the instance group that we just created. And this instance group is created with fixed number of instances, and it is not using auto scaling as of now. If you look at the help of this create command, then here you can see the list of all possible options that you can use with this create command. Like you can also configure the health check while creating the instance group. Just notice that in this list of options, there is no way to configure the auto scaling for the instance group. Actually, there is a separate command for this, which I will explain you in just few minutes. But before that, I will recommend you guys to play around with these options. If you want to describe an instance group, then use the command gcloud compute instance groups manage describe. Now, if you want to describe the instance test mig2 that we just created, then use this command. And here it will give you the whole information about this instance group. Similarly, to delete an instance group, you can use this delete command. Like if you want to delete test mig2 instance group, then you can use this command. Here I will not execute this command because I do not want to delete the instance group, but you can try it at your end. Now let's look at how can you configure the auto scaling for an instance group. And for this you can use the command gcloud compute instance groups manage set auto scaling, and then pass the group name and zone information of the instance group along with the other parameters like maximum number of replicas or cooldown period. For all the other possible options for this command, please refer to this page. So if you look at this page, then you will observe that the only mandatory option here is maximum number of replicas. All other options are not mandatory. And I have already explained all these options in the demo while creating the instance group via Cloud Console. So you can easily correlate these parameters with the auto scaling configuration that I explained you in that demo. Now let's try this command. Here I will configure the auto scaling for the instance group test mig2. Now press enter. So this way auto scaling is configured for the instance group test mig2. So here if you do the instance group listing, then this time you will see that auto scaling is on for this instance group test mig2. Also observe that the size of the instance group has been increased to 2 because we specify the value of maximum number of replicas as 2. Now if you want to stop the auto scaling for an instance group, then you can use this stop auto scaling command. So if you want to stop the auto scaling for test mig2 instance group, then execute this command. Now press enter. Let's do the instance group listing once again. So now here you can see that auto scaling is stopped for this instance group test mig2. In this video, let's look at some of the commands to update the existing managed instance groups. So first command to update existing managed instance group is gcloud compute instance group manage update. This command will allow you to specify or modify the stateful policy and auto healing policy for an existing managed instance group. So if you look at here, then you will observe that for this test mig2 instance group, I have not defined any health check as of now. And if you click here, you will see one health check is defined over here. So if you want to update instance group test mig2, to use this health check, then use this command. In this update instance group command, you can specify the health check like this. Now press enter. So this way, this instance group is updated to use this health check. And on Cloud Console also you can verify that health check is working fine for this test MIG2 instance group. You can also verify this thing by using the describe command. So let's scroll up, and here you can see that under this auto healing policy, health check is defined. Next important command is to resize the instance group. If you want to change the number of instances in your instance group, then you can use this command, gcloud compute instance group manage resize. Here you can specify the size by using the -- size parameter. Currently, this test MIG2 instance group is running with 2 instances. Now I will use this resize command to change the number of instances to 1. For this, I will use this resize command. Here notice that I have specified the value of -- size to 1. Now press enter. So this instance group has been updated with the target size of 1. But it will take some time to stop extra running instance. So let's wait for some time. So here you can see that for this test MIG2 instance group, the number of instances have been reduced from 2 to 1. Now another thing that you might want to try out is to change the instance template used by the instance group. And for this you can use the command gcloud compute instance group manage set instance template. Here you can specify the name of new template by using the flag -- template. So if you look at here, currently this test MIG2 instance group is using this template, rolling template version 1. And there are 2 templates as of now. Let me show it to you. And here you can see the 2 templates, rolling template version 1 and rolling template version 2. Now I will change the instance template of test MIG2 instance group from version 1 to version 2. And for this I will use this set template command. Just observe here that I have specified this new rolling template version 2 by using the -- template flag. Now press enter. So this way this instance group has been updated to use this rolling template version 2. So now for this test MIG2 instance group, we have changed the instance template from rolling template version 1 to rolling template version 2. But notice that still instance within this instance group is using the rolling template version 1. So how to fix this? This can be fixed by recreating the instances within this instance group. And for this you can use this command, gcloud compute instance groups manage recreate instances. Here you can pass the instance that you want to recreate by using the flag -- instances. Now I will recreate this instance by using this recreate instances command. For this, let me paste the command over here. So here you can see that I have specified the instance name like this. Now press enter. So this command is successful. Let's also verify this thing on Cloud Console. So now here you can see that this instance is now using the rolling template version 2. Another command to manage the individual VM within the instance group is update instances command. And here also you can specify the instance name by using -- instances flag. By default, this command will replace the specified instances with the new instances in the instance group. Like if you want to replace this instance within this instance group, then you will write the command like this. Just notice here that I have specified the instance name to be replaced by using the -- instances flag. Now press enter. So this is how you can replace an instance within the instance group by using the update instances command. So here on this page, you can find the documentation for this update instance command. Though this command can be used to replace an instance, but it is generally preferred when you either just want to refresh the instance or you want to restart the instance. And for this, you need to pass some optional parameter like minimal action or most disruptive allowed action. And default value for the minimal action is none, whereas default value for the most disruptive allowed action is replace. And other possible values are refresh and restart. If you just need to update the metadata of the instance, then I would say refresh option is better than the replace or restart. On the other hand, if you need to restart the instance to update the configuration, then choose the restart option. And this is all what I wanted to show you in this video. In previous videos, you learned how to create, list, describe, and delete an instance group in your project. We also looked at set instance template command, which is used to change an instance template of an instance group. And you must have noticed that once you change the instance template of the instance group via set instance template command, then all the instances in that instance group does not move to new template immediately. In fact, we recreated all the instances in that group to move all the instances to use new instance template of version 2. You have also seen that on Cloud Console, there are two options to update the instances in an instance group. One is for doing the rolling or canary update. This option first update the instance template and then move the instances in an instance group to use that new template. This option just restart or replace the VMs inside an instance group. It does not change the instance template of an instance group. Now, in this video, I will show you how you can perform these two operations via command line. So, if you want to perform just restart or replace action similar to this option, then you will use the command rolling action restart or rolling action replace. In case of restart, you can define maximum unavailable value, either in terms of fixed number of instances or in terms of percentage. In case of replace, you can provide values for maximum surge, maximum unavailable, and replacement method. Here, maximum surge represents the maximum additional number of instances that can be created during the update process. And this can be either a fixed number or it can be a percentage of the size of the managed instance group. And maximum unavailable represent the maximum number of instances that can be unavailable during the update process. This can also be a fixed number or a percentage of the size of the managed instance group. And replacement method represent the type of replacement method. It specifies what action will be taken to update the instances. It can be either recreate or substitute. In case of recreate, instances are recreated with the same name. The instance IDs and the creation timestamp might change. On the other hand, in case of substitute, old instances are deleted and new instances are created with the new names. So currently this test MIG2 instance group is using the rolling template version 1. Let's try the restart rolling action in Cloud Shell to restart the instances of this test MIG2 instance group. And for this, I will use this command. Here just notice that I have specified the value of maximum unavailable as 1. Now press enter. Click on authorize. And this way you can restart instances of an instance group via command line. Now, if you want to do the rolling update or canary update for your instance group, the way to do this from this option, then you can do that via start update rolling action. With this action, you can do simple rolling update where all the instances will be updated gradually to use the new instance template. Here, with version parameter, you can specify the name of the instance template to be used by the instances in the instance group. If you do not want to update all the instances, rather you are interested in canary update, then you need to provide -- canary version parameter with this action, which specify both new instance template name to be used and number of instances for the update. Now let's try to do the rolling update for this instance group test MIG2 via Cloud Shell. For this, just go to Cloud Shell And here I will use this command. Here with this command, I will update all the instances of this instance group to use the new instance template, rolling template version 2. Now press enter to apply this rolling update. It will take some time to complete this rolling update, so I will pause the video till then. And now this rolling update is complete. And here you can observe that the instance of this instance group have migrated to new instance template, that is rolling template version 2. And this is all what I wanted to show you as part of this video. And I will highly recommend you guys to practice these commands for sure. Now we will talk about pricing in Compute Engine, and it is very important to understand about the various pricing options for a cloud user, because reducing the cost of cloud solution is one of the primary objectives for any cloud user. In GCP, Compute Engine is priced based on the resource usage. It means you are not charged for a VM as a single entity, but you will be charged separately for each resource that a particular VM uses. Like, you will be charged separately for the number of CPU that a particular VM used, or amount of memory used, amount of egress traffic, and so on. Just remember that custom machines are charged more than the similar predefined machine. So it is always better to use the predefined machine if possible. You can also reduce the cost by using the preemptible VM if your application is fault tolerant and can sustain the sudden outage of the VM. In case of preemptible VM, you can get discount of up to 80%. But before using the preemptible VM, just keep one thing in your mind, that preemptible VM can be stopped at any time and it cannot be used for more than 24 hours. You can see the estimated cost of the VM before launching it via Cloud Console or Billing API. You can also check the estimated cost by using the pricing calculator as well. In case of Compute Engine, both CPU and the memory are charged minimum for 1 minute, and after that you will be charged on per second basis. You can also get some discounts like sustained use discount or committed use discount for your VM. In addition to sustained use discount and committed use discount, you can also get infer discount by combining the usage of multiple identical VM. Now we will discuss about the various discount options available in case of Compute Engine, starting with sustained use discount. The idea of sustained use discount is that longer you run a VM instance in any given month, the bigger discount you will get from the list price, and it is applied in your bill automatically. You do not need to do anything for this. It means that you pay only for the number of minutes that you use for your instance, and Compute Engine automatically gives you the best price. There is no reason to run an instance for the longer period than you need it. Just remember that sustained use discounts are applied on incremental use after you reach a certain usage threshold. As you can see over here, both table and chart shows how to calculate the sustained use discount for your VM based on the VM usage. For example, just look at this table. As per this table, the minimum threshold usage is 25%. It means you will not get any discount if you run your Compute Engine VM instance for less than 25% in whole month. But once you cross this 25% usage limit, then you will start getting the sustained use discount for your VMs. And how much discount you will get? This discount will keep on increasing as your usage for the VM increases. Like, if you use your VM between 25 to 50% in whole month, then you will get 20% discount. Similarly, if you use your VM between 50% to 75% in whole month, then you will get discount up to 40%. Just notice that the numbers shown in the table or the chart are just to explain the discount concept here. These do not represent the actual discount numbers. Also notice that here usage means the total usage of the VM in whole month of billing cycle. It does not mean that VM needs to be run continuously to get this discount. All the used minutes in the billing month will be added first and then will be used to apply the sustained use discount. And you need to pay lower than the actual base rate after sustained use discount is applied to your bill for your VM. One thing that you must remember about this sustained use discount is that this discount is not applicable for the VM which are created by either App Engine Flexible or Dataflow service. And this discount is not applicable for all the machine types, like it is not applicable for the E2 or A2 machine type. There is a concept of inferred instance as well while calculating the sustained use discount. And by using the inferred instance, sustained use discount can be increased for the VM. So what is inferred instance and how does it help in increasing the discount? An inferred instance basically combines the usage of multiple identical non-overlapping instances in the same zone into single instance for the billing purpose. With inferred usage, you are more likely to qualify for the sustained use discount. If you look at this picture on this page, you will observe that Google has combined 5 instances into 3 inferred instances that will give you the longest sustained usage for the better discount. In this picture, VM1 and VM3 have the similar configuration, but running in different interval of months. At the time of billing, the total usage of the similar VM are combined, so that you qualify for the maximum sustained use discount for such similar VM. If you do not combine these VMs, then each VM will be billed separately and none of these two VM will qualify for the sustained use discount or will get the less sustained use discount because each instance individually run for the lesser period. Similarly, VM2, VM4 and VM5 are also combined to get the maximum sustained use discount. Another type of discount that is applicable for the VM is committed use discount. And you can get this discount if you commit the usage of the VM for a longer period, like 1 year or 3 years. In such case, you can get the VM at much lower rate than the normal price. Committed use discounts are ideal for the workloads which have predictable resource needs. Because if your workload is not predictable, then it is not easy for you to commit for the long-term usage for the VM. Based on the machine type and GPU, you can get up to 70% discount. And committed use discounts are generally more than the sustained use discount. So if you know that you are going to use certain application for longer period like 1 year or 3 years, then it makes more sense to go for the committed use discount rather than going for the sustained use discount. Committed use discounts are simple and flexible and it requires no upfront cost. This discount is applicable for both predefined or custom machine and allow user to get the VM at the deep discount than the normal price. But this discount is not applicable for the VM created by App Engine Flexible or Dataflow service. Now let's take an example. Let's say you purchase a commitment for 8 cores, but you run 24 cores during the month. In this case, you will receive the committed use discount for 8 cores only. The other 16 cores will be billed at standard non-committed use rates. Also keep in mind that you will be charged every month for the 8 cores even if you do not use them. Now, if you want to purchase a long-term commitment for any VM, then go to Committed Use Discount option in Compute Engine section. Here on this page, you can see your existing commitment. But if you want to purchase some new commitment, then click on Purchase Commitment button. And then you need to fill this whole form. On this page, you need to provide the information like region where you want to use your VM instance, the type of machine for which you want to make the commitment, and the commitment duration, which can be either 1 year or 3 years. You can also provide information like number of cores, amount of memory, number of GPU, and local SSD that you want to use with your VM instance. Once you fill this whole form, just click on the purchase button to purchase the new commitment. Now let's do the quick recap of all this. In Compute Engine, each resource like CPU, memory, and egress traffic is charged separately. And minimum chargeable interval is 1 minute, and you are charged per second after this. Once your VM is stopped, you do not need to pay anything for any CPU or network traffic, but you need to pay for the disk that you use with your VM, even if VM is stopped. because disk space is still getting utilized in cloud. You should always keep a check on your cloud resources cost by setting up the budgets and alerts. You can reduce your monthly bill for Compute Engine VM instance by using the various discounts like sustained use discount or committed use discounts. In addition to discount, to reduce your Compute Engine VM expense, you can use preemptible VM to run your application. But remember that you can use preemptible VM for non-time critical and fault tolerant applications because preemptible VMs can be terminated by Google Cloud anytime with the short notice of 30 seconds. And you can use preemptible VM maximum for 24 hours only. You can use this 30-second notice period for any kind of cleanup activity like data backup. Like if you want to save some important data before preemptible VM gets terminated, then you can do that in these 30 seconds. So this is all about the pricing and discount of Compute Engine. If you have any queries related to this, please post your queries. In this chapter, we will learn about the load balancers in GCP, what are the various types of load balancers in GCP, and how to decide which one should be used. Typical function of a load balancer is to distribute the user traffic across the multiple backend instances of your application based on the load on each backend machine. It tries to ensure that each backend application server has uniformly distributed load. By spreading the load, load balancer reduces the risk that your application experience related to the performance issue. Let me explain some of the features of load balancer in GCP with the help of a diagram. Load balancer provides the single IP address to your backend instances. All the backends are represented by a single IP address, which is the IP address of your load balancer. Here you have customers in the different regions like US or Asia region, but all the requests interact with your application by the single load balancer IP address. Load balancer in GCP is a software defined component which scales up based on the number of requests, and you can easily configure the load balancer in cloud with few configuration. You will understand it in a better way once I will show you the demo about how to create the load balancer in GCP. It supports the intelligent routing of the customer request by serving the request from the nearest backend. So as per this diagram, if request is coming from any US based customer, then it will be served by either US Central 1A or US Central 1B zone. If the request is coming from Singapore, or you can say Asia region, then it will be served by the Asia region. Now, what will happen if the services in the Asia region goes down? Does it mean that customer in the Asia region will not be able to use the application? No, it will not be like that. In this case, request from the Asia region will also be redirected towards the US Central region. Only thing in this case will be the increase in the latency in response. GCP support both external and internal load balancing. As you can see, there are two types of load balancers here. At first level, we have external load balancer, which accept the request coming from internet. Once request is routed by the external load balancer to one of the regional web server, then it is routed to one of the internal application server by the internal regional load balancer. Load balancer enable automatic auto scaling up and down of your backend resources. You can configure to auto scale resources if the load goes beyond the configured threshold value. Similarly, resources will be downscaled if the load goes below a certain lower threshold. Load balancer in GCP support load balancing in both single region and multi-region. Like here, external load balancer is a multi-region load balancer and internal load balancer is a regional load balancer. Load balancer in GCP support various protocols like HTTP, HTTPS, TCP, and UDP. In this diagram, this external load balancer is HTTP or HTTPS load balancer, which accept the request from user via internet. On the other hand, this internal load balancer is TCP load balancer. You can also configure health check with both external and internal load balancers, which allow the monitoring of your backend instances, and it automatically replaces a backend which becomes unavailable due to some failure. It can also manage client certificate and can act as a SSL proxy which offload the backend VM instance from encryption and decryption of request. Load balancers in GCP also support Cloud CDN. Cloud CDN works seamlessly with HTTP or HTTPS load balancer to deliver the content to your users. Now let's do the quick recap of load balancer features. Load balancer provides the single IP address to your backend services, and all backends are represented by single IP, which is the IP of your load balancer. Load balancer in GCP is a software-defined component which scales up based on the number of requests. It supports the intelligent routing of the request by serving the request from nearest backend. It supports the load balancing in both single region and multi-region. It also supports various protocols like HTTP, HTTPS, TCP, and UDP. You can configure health check with the load balancer, which allow the monitoring of your backend, and it automatically replaces a backend which becomes unavailable due to some failure. It can act as a SSL proxy, which offload the backend VM instance from encryption and decryption of the request, and certificate can be managed at one place. It also supports Cloud CDN. Cloud CDN works seamlessly with HTTP or HTTPS load balancer to deliver the content to your users. When it comes to choosing the right load balancer in GCP, then there are many options in terms of the load balancer in GCP, and you can pick the right load balancer based on the various conditions, which I will discuss later in this section. But before this, first let's look at how we can categorize the various load balancers available in cloud. First criteria is the location of the backends served by the load balancer. As a best practice, you must deploy your backends near to your customer, and based on the location of the backend resources in GCP, at high level you have two load balancers available: global load balancer and regional load balancer. Global load balancer means the backend are distributed across the multiple regions, and you can use this global load balancer to serve the HTTP or HTTPS or TCP traffic. You can also use this global load balancer as SSL proxy for the incoming traffic, which means incoming SSL connection will be terminated at the load balancer, and your load balancer will take care of SSL handling between the client and your application. Your backend application does not need to do any kind of SSL handling in this case. In case of regional load balancing, your backends are in one region. If you want to use regional load balancer to handle external traffic, then you must use network load balancer. On the other hand, if you want to use regional load balancer to handle the internal traffic, then you must use the internal regional load balancer. You can use internal regional load balancer for both HTTP traffic and layer 4 TCP traffic. Another way to look at load balancer is based on the type of request served. And based on the type of request, you have either external load balancer or internal load balancer. External load balancer distribute the external traffic coming from internet to your VPC. Just remember that if you want to use global external load balancer, then you need to use the premium tier of networking service tier. And for the regional external load balancer, you can use standard tier. And what is premium or standard tier networking service? This I will explain in networking chapter. Internal load balancer distribute internal traffic to instances placed inside your Google Cloud. Like if you want to do the load balancing between your web server and the application server, then you use the internal load balancer to load balance the traffic among backend instances of your application server. Just remember that internal load balancer is accessible via internal IP address only inside the selected region of your VPC network. Another way to choose the right load balancer is type of traffic served by the load balancer. For HTTP and HTTPS traffic, you can use HTTP or HTTPS load balancer. For external traffic, you can use external HTTP or HTTPS load balancer. And for internal traffic, you can use internal HTTP or internal HTTPS load balancer. And for external TCP traffic, you can use either TCP proxy load balancer or you can use network load balancer. And for internal TCP traffic, you can use internal TCP load balancer. In the same way, for the external UDP traffic, you can use the network load balancer, and for internal UDP traffic, you can use internal UDP load balancer. After learning feature and the categorization of the load balancer, now it is time to discuss about each load balancing option in Google Cloud. Let's start with Network Load Balancer. Network Load Balancer is an external load balancer and it balances the external traffic originating from internet. Also remember that it is a regional load balancer which distribute traffic among VM instances in the same region only in your VPC network. And it is a software-defined managed service and highly scalable load balancer that runs on Google standard infrastructure. Also notice that it works on layer 4 and support load balancing of TCP or UDP traffic across the regional backend via hashing. One unique feature of this network load balancer is that it is a pass-through load balancer. Generally, in case of other external load balancer, source IP address of the client which initiate the request is not known to the backend server machine which serve the request. But in case of network load balancer, source IP address of the client is preserved. It means this network load balancer forward the information about the source IP address of the client to the backend destination VM, and it enables the destination machine to send the response directly back to the source IP address without going through the load balancer. And this feature is called as direct server return. And since it is a pass-through load balancer, you must define your own VPC firewall rules to control access to the backend VMs. Also remember that it is a non-proxied load balancer. It means in this case, TLS connection terminates at the destination machine rather than at the load balancer, and your backend VM instance will have to do the SSL handling in this case. As you can see in this diagram, there are three applications: My App, Test, and Travel, running in US, Europe, and Asia region. And each application has the corresponding regional network load balancer to route the traffic from the user in that region to the corresponding application. Here, these network load balancer route the TCP or the UDP traffic to your backend instances. Here, just notice that when these backend VM receive the client request via these regional network load balancer, then these backend VMs are aware of the source IP address of the client who actually initiated the request. And because of this feature, they can send the response directly to the client via their source IP address. And this feature is called as direct server return. In this case, backend VM do not need to send the response traffic via the network load balancer. Also remember that if you use TLS or SSL connection with networking load balancer, then SSL handling will be done by the backend instances. These network load balancer does not provide the SSL handling. In previous demo, we learned about the network load balancer. Network load balancer is a regional load balancer which is capable of routing traffic to regional instances only. But we also might have requirement where our backends are running in multiple regions. And in this case, we need to route the customer request to nearest backend among all the globally spread backends. This is where you can use the global load balancer. This is another way to manage the external traffic among globally distributed instances in an efficient way. As you can see in this diagram, global load balancer provide a single anycast IP address for your application that can distribute user traffic among application backends in an intelligent manner. It provides multi-regional traffic distribution, which means your backend instances can be in any region. This global load balancer routes the traffic to the backend instances based on its distance, capacity, and availability. As per this diagram, there is one application, that is My App application, which is running in three different regions: US West, US East, and Singapore region. And by using this global load balancer, you can easily route your user traffic for your application among these three regions: US East, US West, and Singapore region. You can use global load balancer for any kind of traffic like HTTP, HTTPS, TCP, and UDP traffic. As compared to DNS-based global load balancing solution, this global cloud load balancer reacts more faster to the changes in condition like user traffic, network, backend health, and other related conditions. Because DNS record change take more time to reflect as compared to this global load balancer. So nowadays, it is better approach to achieve the load balancing at global scale by using this global cloud load balancer rather than using the traditional DNS-based global load balancing technique. Now, let us try to understand how to use external and internal load balancers in cloud by considering an example of typical three-tier web application running at global scale. As per this diagram, here at the top, you prefer to use HTTPS Global External Load Balancer because this application need to serve HTTPS traffic and backends are spread across the multiple regions like US West 1, US Central 1 and US East 1. In this case, your user traffic enters from internet and it is load balanced by this global external load balancer. Once request is received by this external load balancer, it will intelligently route your user traffic to the one of the web front-end server based on its distance, availability, and the existing load. After this, web server routes this traffic to one of the middleware application instance inside your VPC by using this regional internal HTTP or HTTPS load balancer. Just observe that each region has its own internal regional load balancer and each of these internal load balancer is accessible via internal IP address inside the selected region of your VPC network. After this middleware managed instance group send the traffic to internal TCP or UDP load balancer, which load balance the traffic to the data storage clusters. Now let us discuss the data models, or you can say steps required to configure any kind of load balancer in cloud. It will help you in understanding various components of the load balancer. As per this diagram, if you want to do the load balancing of HTTPS internet traffic among these VM instances, then first you need to define the front end, or you can say forwarding rule. Then you need to define the target proxy, then URL map, and in last you need to define the backend service for your load balancer. Here, first your client send the request to external IP address defined inside this forwarding rule. Then this forwarding rule directs the request to the target HTTP proxy. And then this target proxy use the rule defined inside the URL map to determine the single backend service that can handle the request. After this, load balancer determine the single VM instance in your backend service that can handle the request and direct the request to the virtual machine instance. And finally, VM serve the content requested by the user. Now let me explain each of the component of the load balancer. Frontend or the forwarding rule in your load balancer actually define the anycast IP address exposed by the load balancer for your application. And each forwarding rule defines the IP address and the port on which the load balancer accepts the traffic. And this is the page to create the forwarding rule for a global external HTTPS load balancer. Here, this forwarding rule defines the mapping of IP address and the port for this load balancer. And from here, you can choose either ephemeral IP address for this load balancer or you can create a static IP address for this load balancer. Also notice that here you can define the multiple forwarding rules for the same load balancer. And this is very handy when you want to add another IP address or you want to enable IPv6 or you want to add additional port for the load balancer without redeploying the whole load balancer. Once traffic is received on any of the IP address created by these forwarding rules for your load balancer, then traffic is forwarded to the target proxy. Another type of data model that you must define for your load balancer is target proxy. And target proxy specify how to handle the connections. You can define target proxy for any kind of traffic like HTTP, HTTPS, TCP or SSL. If you want to use load balancer as SSL proxy for TLS or HTTPS traffic, then you can configure SSL certificate in target proxy and terminate the SSL connection at the load balancer. This can offload the backend from SSL handling and encryption or decryption of the request and response. Like if you select HTTPS protocol over here, then here you can configure the SSL certificate for this load balancer. And this way, load balancer will take care of the SSL handling for your client traffic. In case of HTTP load balancer, here you can define the multiple URL map for your backend VMs, which enables you to load balance your traffic among the multiple backend services. This is generally used when you have to load balance your traffic among the multiple microservices based on the URL map. Now let me explain how this content-based routing works with the help of an example. As per this diagram, here your application is composed of three different microservices which serve the different type of content like video, images or some kind of API. And each microservice here is mapped to the different URL based on the content. Like this video's microservice is mapped to the /video and this image microservice is mapped to the slash images, and this API microservice is mapped to the slash API URL. When a client sends a request to the load balancer's external IP address, the load balancer evaluates the request according to the URL map and sends the request to the correct backend service. Each URL map has three subcomponents: host rule, path matcher, and backends, which determine how the traffic will be routed to the backend. And by using these host and the path-based rule, you can redirect traffic to either your backend service or to cloud storage bucket. And any traffic that is not matched by any specified host and the path-based rule will be sent to the default service selected on the first row. Last thing that you need to define for HTTP load balancer in cloud is backend service. Backend service of a load balancer in GCP determine the group of server or network endpoint that can handle the request. And you can add one or more instance group or network endpoint as your backend. You can also use cloud storage bucket as your backend service in case you want to serve some kind of static content. Like here, you can choose either cloud storage bucket as your backend service, or you can create the backend service based on the instance group or network endpoints. In your backend service, you can also define health check for your instances, which will configure health checker to monitor your backend instances, which will ultimately serve your request. And you can also enable logging, which will help you in debugging in case of any issue. These logs will appear in cloud logging service. If you want to enable session-based load balancing for your traffic, then here you can configure the session affinity while creating a backend service. Here you can define two types of session affinity. It can be either client IP based or it can be cookie based. If you enable session affinity, then all the requests from the same client will be directed towards the same backend machine as long as machine is healthy. In case of cookie based session affinity, you can also define the cookie expiration time over here. Session affinity is enabled where you want to manage some kind of session information for the client, but keep in mind that it can limit the scalability of your application. Now let us discuss the data models, or you can say steps required to configure any kind of load balancer in cloud. It will help you in understanding various components of the load balancer. As per this diagram, if you want to do the load balancing of HTTPS internet traffic among these VM instances, then first you need to define the front end, or you can say forwarding rule. Then you need to define the target proxy, then URL map, and in last you need to define the backend service for your load balancer. Here first your client send the request to external IP address defined inside this forwarding rule. Then this forwarding rule directs the request to the target HTTP proxy. And then this target proxy use the rule defined inside the URL map to determine the single backend service that can handle the request. After this, load balancer determine the single VM instance in your backend service that can handle the request and direct the request to the virtual machine instance. And finally, VM serve the content requested by the user. Now let me explain each of the component of the load balancer. Frontend or the forwarding rule in your load balancer actually define the anycast IP address exposed by the load balancer for your application. And each forwarding rule defines the IP address and the port on which the load balancer accepts the traffic. And this is the page to create the forwarding rule for a global external HTTPS load balancer. Here, this forwarding rule defines the mapping of IP address and the port for this load balancer. And from here, you can choose either ephemeral IP address for this load balancer, or you can create a static IP address for this load balancer. Also notice that here you can define the multiple forwarding rules for the same load balancer. And this is very handy when you want to add another IP address, or you want to enable IPv6, or you want to add additional port for the load balancer without redeploying the whole load balancer. Once traffic is received on any of the IP address created by these forwarding rules for your load balancer, then traffic is forwarded to the target proxy. Another type of data model that you must define for your load balancer is target proxy. And target proxy specify how to handle the connections. You can define target proxy for any kind of traffic like HTTP, HTTPS, TCP, or SSL. If you want to use load balancer as SSL proxy for TLS or HTTPS traffic, Then you can configure SSL certificate in target proxy and terminate the SSL connection at the load balancer. This can offload the backend from SSL handling and encryption or decryption of the request and response. Like if you select HTTP as protocol over here, then here you can configure the SSL certificate for this load balancer. And this way, load balancer will take care of the SSL handling for your client traffic. In case of HTTP load balancer, here you can define the multiple URL map for your backend VMs, which enables you to load balance your traffic among the multiple backend services. This is generally used when you have to load balance your traffic among the multiple microservices based on the URL map. Now let me explain how this content-based routing works with the help of an example. As per this diagram, here your application is composed of three different microservices which serve the different type of content like video, images or some kind of API. And each microservice here is mapped to the different URL based on the content. Like this video microservice is mapped to the slash video, and this image microservice is mapped to the slash images, and this API microservice is mapped to the slash API URL. When a client sends a request to the load balancer's external IP address, the load balancer evaluates the request according to the URL map and send the request to the correct backend service. Each URL map has three subcomponents: host rule, path matcher, and backends, which determine how the traffic will be routed to the backend. And by using these host and the path-based rule, you can redirect traffic to either your backend service or to cloud storage bucket. And any traffic that is not matched by any specified host and the path-based rule will be sent to the default service selected on the first row. Last thing that you need to define for HTTP load balancer in cloud is backend service. Backend service of a load balancer in GCP determine the group of server or network endpoint that can handle the request. And you can add one or more instance group or network endpoint as your backend. You can also use cloud storage bucket as your backend service in case you want to serve some kind of static content. Like here, you can choose either cloud storage bucket as your backend service, or you can create the backend service based on the instance group or network endpoints. In your backend service, you can also define health check for your instances, which will configure health checker to monitor your backend instances, which will ultimately serve your request. And you can also enable logging, which will help you in debugging in case of any issue. These logs will appear in cloud logging service. If you want to enable session-based load balancing for your traffic, then here you can configure the session affinity while creating a backend service. Here you can define two types of session affinity. It can be either client IP based or it can be cookie based. If you enable session affinity, then all the requests from the same client will be directed towards the same backend machine as long as machine is healthy. In case of cookie based session affinity, you can also define the cookie expiration time over here. Session affinity is enabled where you want to manage some kind of session information for the client, but keep in mind that it can limit the scalability of your application. Now also look at how SSL or TCP proxy load balancing works. These are like global HTTP load balancer, what we have already discussed. It exposes single anycast IP address for your application, and you can deploy your backends in multiple regions, and the load balancer automatically directs the traffic to the closest region that has the capacity. By using Google Cloud Proxy load balancing for your SSL traffic, you can terminate your SSL connection here at the load balancing layer itself, and then load balance the connection across your backend instances by using the SSL or TCP protocol. By using these load balancers, you can manage the certificate, security, and SSL handling at one place, and that is your load balancer, rather than handling at the individual backend machine. In this example here, your user traffic is terminated at the load balancing layer itself, and then the separate connection is established between the load balancer and the backend VM instances. One more important thing that you must configure while creating a backend service in cloud is load balancing mode. Load balancing mode determines how the load balancer distributes the request among the backend instance groups. Based on the configuration of distribution algorithm, your traffic will be distributed among multiple backend instances. HTTP or HTTPS load balancer support two balancing modes. First is the utilization and second is the rate. Utilization is the CPU utilization of VM instances in an instance group, and rate is the target maximum number of requests per second. If you select the CPU utilization mode, then you can define the CPU utilization over here. In the same way, if you select the rate balancing mode, then you can define the maximum number of requests per second over here. Before request is sent to any backend instances, load balancer check which backend instance have the capacity to receive the request, and then route the request to an instance which has the capacity to handle your request. When a backend has reached a configured maximum utilization or rate, then load balancer will direct new requests to other backends that have not reached to their configured maximum capacity. So far, I have covered various load balancing options in Google Cloud. Now, let's see how to decide which load balancer should be used in a particular use case. Google provides a very nice decision tree to decide which load balancer should be used, and it will help you in deciding the right load balancer for your use case. Before choosing the right load balancer for your use case, you need to take various decisions. And first decision is whether you want to use external or you want to use internal load balancer. Like for the internal traffic, you should use internal TCP or UDP load balancer for TCP and UDP traffic. And for HTTP or HTTPS traffic, you should use internal HTTPS load balancer. If you want to load balance your external traffic, then you need to take some more decision before deciding the right choice for yourself. Like if all the backends are in the same region, then the network load balancer is the perfect choice for you. If the backends are in multiple regions, then for HTTP or HTTPS traffic, you should use the global external HTTP or HTTPS load balancer. If you want to use SSL proxy, then you should use the SSL proxy load balancer. For TCP traffic, you should go with TCP proxy load balancer. You should also choose TCP proxy load balancer if you want to use the IPv6. Just keep in mind that network load balancer does not provide the proxy support. In this case, source IP address is passed to the backend instances. So you cannot use the network load balancer in case you do not want to preserve the source IP address. So this is all about how to pick the right load balancer. And you may get some question in your exam based on the load balancer. I have also shared the link for this tree in resource section. Now, after enough theory related to load balancer, it is time for demo. Here, I will show you how to create a HTTP external load balancer in GCP, and to showcase usage of HTTP load balancer, I will create two instances in US East region and will do the load balancing of traffic from internet between these two instances. In this video, I will deliberately use unmanaged instance group just to show how an unmanaged instance group can be created along with the load balancer creation. Ideally, managed instance group is more preferable, and you can try similar flow using the managed instance group as well. For this demo, I have already created two VM instances in US East 1 region. One of the instance is running in US East 1 B zone and second instance is running in US East 1 C zone. And both the VMs are up and running. I have used custom script to create both these instances to show which VM is actually serving the request. Like if you click on the IP address of the first VM over here, then it will show you that this particular request is actually getting served by the VM running in US East 1 B. In the same way, if you click on the IP address of second VM, it will show you that this request is actually served by the VM running in US East 1 C. I will share this custom script in the resource section of this video for your use. Now I will create two different unmanaged instance groups for both the VMs and will add one VM in each group. Now to create an unmanaged instance group, click on the instance group option over here. Then click on create instance group button. On this page, you have option to create both managed instance group and unmanaged instance group. But for this demo, let's select the unmanaged instance group option from here. Now provide the name and description for this instance group. After this, select the location of the instance group in terms of region and the zone. For this demo, I will select the region as US East 1 and zone as US East 1B. Keep the networking as default for the time being, and I will explain about the networking later on in this course in another section dedicated for the networking. Now add one VM that you created in US East 1B in this instance group. Now click on Create button to create this unmanaged instance group for you. So this unmanaged instance group is created for you. In the same way, create one more unmanaged instance group. Once again, select the option of unmanaged instance group from here and provide the name and description for this instance group. This time, create this instance group in US East 1 C zone. So let me select the region as US East 1 once again, and this time select the zone as US East 1 C. Now add second instance into this instance group and now click on Create button. This way, your both unmanaged instance group are created. Next, I will show you how to create load balancer using these two instance group as the backend service. Now to create load balancer, go to load balancer service. Click on Create Load Balancer button. On this page, here you have a choice whether you want to create a HTTP load balancer, or you want to create TCP load balancer, or you want to create UDP load balancer. For this demo, I will create a HTTP load balancer. So click here to create the HTTP load balancer. On this page, you need to select what type of HTTP load balancer you want to create. Do you want to create external load balancer which will distribute the internet traffic among all your backend instances, or you want to create an internal load balancer which will load balance your internal traffic only? Internal load balancer does not have a public IP address, so it is not reachable from internet. Since in this demo we are interested in creating an external HTTP load balancer, so let's select this option to create the external load balancer and click on Continue button. Now give some name to this load balancer. On this page, we will define backend configuration, host and URL map, and the front-end configuration for this load balancer. Now let's create each of them one by one, starting with the backend configuration. To create the backend configuration, click here and select the Create Backend Service option. Here you need to provide the name for your backend service. Backend service determines the set of VM instances which will handle the request for our application. In this backend service, we need to add both the unmanaged instance group that we created a while ago. So let's add both the instance group one by one. For this, let's select the backend type as instance group and select the protocol as HTTP protocol. Here we can add the instance group in this backend service. So let's select the first instance group here from this list. Next, select the balancing mode. Balancing mode determines how to evenly distribute load among your backend instances. You can distribute the load either based on CPU utilization of your backends or number of requests getting served by each instance in your backend. For this demo, I will select the CPU based balancing mode. And here you can provide the maximum backend utilization if you choose the CPU based utilization for your backend. I will keep it as it is for the time being. Here you need to provide the port number for your backend. Now click on Done button. Now add the another instance group in the same way. Now both the backends have been added to your backend service. In backend service, you can also create a health check. You can either choose an existing health check or create a new health check for this backend service. Since there is no existing health check as of now, so let me create a new health check. Here you need to provide the name and description for this health check. Next, we need to select the protocol for this health check. Here I will use the HTTP protocol to define the application-based health check. Here you can define the application request path on which the application health check will be performed. Here you can define the health check interval frequency and the request timeout for any health check request. You can also define healthy threshold and unhealthy threshold for this health check over here. Healthy threshold determines the number of consecutive successful requests after which any instance in your backend service can be considered as healthy instance. And unhealthy threshold determines the number of consecutive failure requests after which any instance in your backend service can be considered as unhealthy instance. For this demo, I will reduce the health check interval. Now click on Save and Continue. So health check is also configured for this backend service. Under this Advanced tab, you can also define the session affinity if you want. You can either choose client IP address based session affinity or cookie based session affinity. If you choose the cookie based session affinity, then you can also define the cookie expiration time over here. For this demo, I will not use any kind of session affinity. And finally click on Create button to create this backend service. So your backend service is created in this load balancer along with the default URL map. In case of HTTP load balancer, here you can define the multiple URL map which allow you to do the load balancing of your traffic among the multiple backend services based on the URL. Here, by using the URL map, you can send the traffic to either backend service or cloud storage bucket. Cloud storage bucket is generally used as a backend service to host a static website, where cloud storage bucket will store all the static content of the website. Since in this demo, only one backend service is defined, so we will use the default URL map entry, which will enable this load balancer to direct all the traffic to our created backend service. But if there are multiple backend services defined, then you can use the multiple URL map entry here to route the traffic to different backend services based on the matching path of the URL map entry. Like in case of microservice, you can define the different backend service for each microservice and route traffic to different microservice by using the path-based URL matching over here. For this demo, let's go with the default URL map entry. Now, finally, we will define the front-end configuration for this load balancer, which will define any cast IP address and port on which it will receive the traffic from internet. Here, you need to give the name to this front-end configuration, and from here, you need to choose the protocol for this configuration. From here, you can either choose an ephemeral IP address or you can create a new static IP address. For this demo, let's use the ephemeral IP address. Here, you can define the port for this front-end configuration and finally click on Done button. So this way, we have defined all three things: backend configuration, URL map, and front-end configuration for this load balancer. Now, before actually creating this load balancer, if you want to review these configurations, then click here. Here, you can review all the configurations for backend service, URL map, and frontend on a single page. Once you are satisfied with all these configurations, then click on the Create button to create this load balancer. It might take some time to create a load balancer in GCP, and I will pause this video till then. Now, this load balancer is created, and if you click on the name of this load balancer, then on this page, it will show you the complete details about this load balancer. Here you can see the IP address assigned to this load balancer. And since this is an external load balancer, so this IP address is reachable from internet. Here you can see the backend services defined for this load balancer. Also notice that both the instance group defined in this backend service are in healthy state. Now let's try to hit this load balancer IP address in your browser. And this time you got the response from a VM running inside US East 1B. Now I will stop this VM instance and see what happens in this case. For this, let's go to Compute Engine service and stop the instance running in US East 1B. So select this instance and stop it. So this VM is stopped now. And since we have already configured health check in our load balancer, so this health check will detect that this VM has failed in few seconds. Now let's go back to load balancer URL once again and refresh the page sometime. So this time you got the response from another VM running inside your backend service, and that is from US East 1C. This is how load balancer can intelligently route your traffic to another VM in case one instance has become unhealthy, and that too without any manual intervention. So this is how we can create an external HTTP load balancer in GCP. And this is all what I wanted to show you as part of this demo. If you have any queries related to load balancer in GCP, please post your queries. Now let's discuss about another compute offering in GCP, that is App Engine. App Engine is one of the oldest running service in GCP, and it is part of platform as a service option available in compute offerings. So how we can describe the App Engine? Basically, App Engine is a fully managed and serverless compute service offered by GCP, and it is primarily used for web application deployment. Serverless here means that if you deploy your web application on App Engine, then you do not need to manage the server provisioning and other infrastructure maintenance. App Engine's infrastructure remove many of the system administration and development challenges of building the application that can scale up to hundreds of requests per second. If you deploy your application in App Engine, then Google handles various activities such as deploying code to a cluster, monitoring the instance of your service, failover, and launching the application instances as per your requirement. Since Google handles so many activities for you, so you being a developer can easily focus more on developing the application features rather than worrying about the infrastructure to host your application if you are hosting your application on App Engine. As I already explained, the cloud services provides a range of options from fully managed to less managed services, where less managed service gives the more control to the developer. Now let's see how App Engine is different from other compute offerings. It is different from Compute Engine, where you have to first provision your VM with the required configurations to host your application. Compute Engine gives you the maximum flexibility in terms of customizing the infrastructure in cloud, but managing this infrastructure on your own is not easy thing, especially for the very standard use case like hosting a highly scalable web application. In such cases, App Engine gives you the ready-made solution to host your application with few customization options compared to Compute Engine. But it is very quick solution as compared to Compute Engine. You can do the OS level customization in case of Compute Engine, which is not possible for the serverless solution like App Engine or Cloud Function. App Engine is not purely serverless like Cloud Function. Though it is not as customizable as Compute Engine is, still it provides some option to customize your hosting environment. I would say that App Engine is more useful when you want automated deployment or automated scaling of your application. Unless your application requires some OS level customization, App Engine is more advantageous over configuring and managing the VM on your own. Now let's look at some of the features of App Engine. By using App Engine, you can build and deploy your applications quickly by using the popular languages like Node.js, Java, Ruby, C Sharp, Go, Python, or PHP. You can also bring your own language runtime if you use the flexible environment in App Engine. By using flexible environment, you can customize the runtime, which allows you to bring any library and framework to App Engine by supplying a Docker container. And I will explain the flexible environment later in this chapter. By using App Engine, you can focus on writing the code without having to worry about the infrastructure management. And you can quickly test and release your product in market, which can be the differentiating factor for your business in a competitive environment. By using App Engine, you do not have to hire engineers to manage your servers, which will save money for you. And you can invest this money into other parts of your business. If you deploy your application in App Engine, it means you operate in a serverless environment without worrying about over and under provisioning of the resources. App Engine automatically scale up and scale down depending on your application traffic and consume resources only when your code is running. The application hosted on Google App Engine can scale both in compute and storage, just like other Google products. And platform provide the distributed storage with the replication and load balancing of client requests. In fact, in case of standard environment, project running on App Engine can scale down to 0 instances if there are no requests coming in. And this is the extremely useful at the development stage, as you can go for the weeks without any deployment on App Engine. In case of flexible environment, it will need at least one instance for running your application. App Engine also provide diagnostic tools. App Engine use cloud monitoring and cloud logging to monitor the health and performance of your application. You can use Cloud Debugger and error reporting to diagnose and fix the bug quickly using the App Engine. App Engine make your application testing very easy for you. You can easily host different versions of your application and route the incoming request to different application version. You can also do the A/B testing and do the incremental feature rollouts. By using App Engine, you can easily create development, test, staging, and production environments. And finally, App Engine also provides tools to ensure the security of your application, like Security Scanner. You can also define your own firewall rules to protect your application, and you can also manage certificate by using App Engine. In fact, by using App Engine, you can use the same security standard which Google use for its own applications. And we all know that Google infrastructure is one of the most secure internet infrastructure around the world. In this video, we will talk about how does your application look like in App Engine and what are the components of an application in App Engine. So in case of App Engine, at the top we have application. To create your application under Google Cloud Project, the App Engine application is a top level container that include the service, version and instances that make up your application. For creating an application in App Engine, you just need to select the region for your application and all your resources are created in the region that you choose, including your app code along with a collection of settings, credentials, and your app's metadata. It means App Engine is a regional service in nature. Once your application is created, you cannot change the location of your application. So be very careful while creating an application in project. You must choose the location closer to your target customer for the best performance. Also notice that App Engine application cannot be deleted once they are created. If you want to delete this application, you have to delete the entire project to delete the application. An application can have one or more services, and these services are loosely coupled and are developed and maintained independently by the developers. You can either run your whole application as a single monolithic service, or you can design and deploy multiple services to run as a set of microservices. Like in case of e-commerce application, there can be multiple services defined under single application, like inventory service to manage the inventory, billing service to handle the billing. There can be pricing service as well for handling the product prices, and so on. Each service in App Engine consists of the source code for your app and the corresponding App Engine configuration files. And each deployment of your service is considered as a different version of that service. Each service in App Engine application can have different versions, runtime, and performance settings. Every App Engine application includes a default service which is the first service deployed in the application. You must deploy the initial version of your app to the default service before you can create and deploy additional service to your app. Also notice that this default service cannot be deleted. You can have multiple versions of the same service, or you can say that everything that you deploy in App Engine has the specific version. By having multiple versions of your app within each service, allow you to quickly switch between the different versions of that app for the rollback, testing, and other temporary events. You can also route the traffic to one or more specific version of your app by migrating or splitting the traffic. You can perform the A/B testing for your service by using the multiple version of the same service. Also notice that each service and version has independent logs, and you can view them either separately or you can view them together as well. Each version of your service run on one or more instances, and by default App Engine scale your application to match the traffic load. Your app will scale up the number of instances that are running to provide the consistent performance, or scale down to minimize the idle instances and reduce the cost. Here you can define how many instances should run for your application. There are three scaling types: automatic, basic, and manual, by which Google can control how the instances are created. Now let's try to understand the relationship between application components in another way by looking at how a typical microservice application deployment in an app engine will look like. In an app engine, you can either run your whole app as a single monolithic service, or you can design and deploy multiple services to run as a set of microservices. Like here in this diagram, there are two services which are completely isolated from each other, and these are service 1 and service 2. You can call any functionality of these services just by making a HTTP call over the network. In fact, even if these two services need to talk to each other, then it must be via RESTful HTTP call only. One service cannot directly call any functionality in another service. You can also deploy multiple versions of each service simultaneously. Like here for this service 1, these are the two versions which are deployed simultaneously, and for service 2, these are the two versions which are deployed simultaneously. Also notice that you can directly access any deployed version of a service, as each version has its own address. And having multiple versions of the same service helps you in doing the traffic splitting or A/B testing. So services in an App Engine application are isolated from each other, but there are some shareable resources as well, which are shared across all the services running inside your App Engine application. For example, Cloud Datastore, Memcache, Task Queue, Cloud Storage, or Mail Service. These all are the shared resources between the services in an App Engine project. You can use Cloud Datastore as a storage solution for your microservice. Cloud Datastore is a highly scalable NoSQL data storage solution, and it is a managed service offered in GCP. Memcache can be used for any kind of data caching based use case, and it is a distributed cache available in App Engine. In case you want to execute some long running tasks in background in App Engine, then you can use Task Queue. These tasks are executed later by the worker services. Similarly, Cloud Storage and Mail Service are also the shared services available in App Engine. Just keep in mind that it is your responsibility to maintain the code and the data isolation in your microservice using these shared services. In this video, I will show you how to create an App Engine application in a project. But before you create an App Engine application, you just remember that you can create only one App Engine application in one project. So first, you need to select the project in which you want to create the App Engine application, and then go to App Engine. Now click on Create Application button. To create App Engine application in your project, you just need to define the region where you want to create resources for your application. You must always choose a location that is nearest to your customer due to the performance reason. And keep in mind that you cannot change this location once application is created inside your project. And also remember that you cannot delete the application once it is created. So If you want to either change the application location or want to delete the application once it is created, then you will have to delete the entire project. So be very careful while selecting the location for your application. On this page, from here, you can select any of these locations for your application. And once you select the location, then just click on the Create App button to create the application. This is an optional step, so click on Next here. So here you can see that your App Engine application has been successfully created. Click on this. In next demo, we will learn how to deploy a service in App Engine application. In previous video, we learned how to create an App Engine application in a project. In this video, I will show you how to deploy a service inside the App Engine application that you created in last demo. Here, I will use one quick start tutorial to deploy Hello World Java-based web application. And to open that quick start tutorial, click here, then select this option, select Java. Java application used here is Maven-based web project. And App Engine Maven plugin is used in this project to test and deploy the application in App Engine. And code for this web project is present in Git repository. And you can clone this repository by using this git clone command. I will use Cloud Shell to test and deploy this web service in this demo. So let me open the Cloud Shell. I have already cloned this project in my Cloud Shell VM instance and done some basic steps required for the first deployment. Because some of the steps are a bit time consuming, like if you are doing the Maven build for the first time for this project, then it can take good amount of time in downloading all the dependencies for the project. You can also create required directory and cloning of this project by using these commands from here. Now move to next step. Before testing and deploying this web project, let me show you the project directory and some of the important content in this project. For this, let me open the Cloud Shell in another window. Open the editor here. This project contains a servlet which will serve your request with the greeting message of Hello World. And you can find this servlet in this project directory. It is under source, Maven, Java, and my app. And this is the code for this particular servlet. Another important file to notice in this project is app-engine-web.xml, which you can find under the webinf directory. This file defines the configuration for your service which are required to host application in App Engine. And this file be used to generate the app.yaml file for your configuration. Let me also show you the Maven plugin used for testing and deployment of this service. For this, let's go to form.xml file. Here, if you go at the bottom, so this is the App Engine Maven plugin which will be used to test and deploy this service. Now let's go back to Cloud Console. Go to project directory. Before you do the deployment of your service in App Engine application, you can test your service as well by using this command. And for this, you just click here. It will copy this command in your Cloud Shell window. Now execute this command. It has started your application in test mode. Now let's do the web preview of this application. For this, click here. So here it is showing your greeting message successfully. Now let's go back to Cloud Console once again. Now come out of the test mode. Let's move to next step. Now here to deploy your application, you need to execute this command. For this, just click here. Once you execute this Maven App Engine deploy command, it will deploy this service in your App Engine application. So let's execute this command. It will take some time to deploy your service in App Engine application. Click authorize here. I will pause this video until this deployment is complete. And finally, this deployment is complete. This deployment will create a service in your App Engine application, and it will be called as default service because this is the first deployment in your App Engine application. This is how you can deploy your service in your App Engine application. And these deployment steps will remain same whether you are doing the deployment for the first time or you are creating a new version of your service. Now close this tutorial and close this Cloud Shell session as well. Now just refresh this page. And here you can see your first default service running inside your App Engine application. Just remember that first service that you will deploy in your App Engine application will be known as default service. Now, if you click on the name of this service, then you can see the output of your application. And here is the greeting message printed by this application. Let's go back to Cloud Console once again. Here you can see that this is the first version of your service. Now, if you want to see the logs of your service, then click here and select the logs option. If you click on the log option, then it will take you to cloud logging. Here you can see all the logs related to your service. Now let's go back to Cloud Console once again. If you want to see the more information about the versions of your service, then click here. Here you can see that there is only one version which is currently running for this particular service, and it is deployed under standard environment using Java 8. Similarly, to check the information about the instances, click here. Here on this page, you can see the number of instances which are currently running for your service. Here there is no instance appearing as of now because we are using the standard environment for this service. And in case of standard environment, if there is no traffic for the service, then the instances can scale down to 0. And this is the reason why there is no instance appearing over here for this service, because there is no request coming in for this particular service as of now. And it is very interesting feature of App Engine which can help you in saving the cost in case there is no traffic coming in for your service. Now let's check the dashboard. Here you can see the number of requests received per second for your service. Here you can see the billing status for your application, and it will show you how much resource you have used and what are the charging rate for each resource. Here you can see the errors in your application. So this is all about the relationship between application, service, version and instance in your app engine. And it is very important concept to understand for the exam. You can run your application in app engine using either flexible environment or standard environment. You can also choose to simultaneously use both the environments for your application and allow your service to take advantage of each environment's individual benefit. Now let's try to compare both the environments and see how to choose the right option for your use case. In case of standard environment, application instances run in a sandbox, and these standard environment provide the runtime environment for the commonly used languages like Java, Python, Node.js, PHP, Ruby, or Go. By using standard environment, you can run your application for free or at very low cost. In this case, you pay only for what you need and when you need it. In case of standard environment, your service can scale to zero instances as well when there is no traffic. In standard environment, instance startup time is in seconds, and because of this, it is preferable for the service where you can experience sudden and the extreme spike of traffic which require immediate scaling. It also supports all type of auto scaling like automatic, basic, and manual auto scaling. Maximum request timeout in case of standard environment depend upon the runtime and the type of auto scaling. Keep in mind that you cannot modify the runtime in case of standard environment and it does not support the WebSocket. Standard App Engine environment does not allow the application to write on the disk as well. So far, we have learned about how to deploy a service in standard environment. Similarly, you can also deploy service in flexible environment in App Engine. Now let's talk about how flexible environment is different from standard environment. As the name suggests, flexible environment gives you lot of flexibility in deploying your application. In case of flexible environment, application instances run within the Docker container on compute engine virtual machines. So it is preferable if you have developed your application in a language which is not supported by standard environment or your application use some framework that includes the native code. You prefer flexible environment in case you want to host application that receive the consistent traffic or you experience regular traffic fluctuation. In case of flexible environment, your application scale up and down gradually because in this case, instance startup time is in minutes and it support only automatic and manual scaling of the instances. Also notice that you need minimum one instance to run your application in case of flexible environment and it cannot scale down to zero like standard environment. And maximum request timeout in flexible environment is 60 minutes. If you choose to use flexible environment, then your application can access the resources or services of your Google Cloud project that reside in the same compute engine network. With flexible environment, you can modify the runtime environment with the use of Docker file and it support WebSocket too. In this case, you can install any third-party libraries as well. There are few things which you must keep in mind while choosing the flexible environment for your application. Like flexible environment VM instances are restarted on a weekly basis for the maintenance activity on VM instances. And by default, SSH access to the VM instances in the flexible environment is disabled. But if you choose, you can enable it and you have the root access to your app's VM instances. In this case, code deployment can take longer as the container images are built by using the Cloud Build service. Also notice that location of the VM instance is determined by the location of your application in which you want to deploy your service. In case of flexible environment, you can define the number of CPU and memory to be used by your application. This is not possible in case of standard environment. In last demo, I showed you how to deploy a service in standard environment with the help of one quick start tutorial. In the similar way here, I have deployed a Python-based service in flexible environment with the help of another quick start tutorial. And you can find that quick start tutorial by going here like this This time you need to select the tutorial related to the flexible environment, and this is the tutorial which I have used. You please try this at your end on your own, and by following this tutorial you can also deploy your service in flexible environment. But just keep in mind that this deployment will be slower as compared to standard environment, as in this case whole Docker container need to be built using the Docker image. Here in this demo, I just want to focus on how flexible environment is different from standard environment, especially some differences in app.yaml file. Here for this demo, I have already deployed this service in flexible environment which use the Python based runtime. And if you want to check the app.yaml file for this particular version, then click here, and here is your app.yaml file for this version of deployed service. Just notice that in case of flexible environment, you can define number of CPU, memory, disk size, health check, and so on. And you can see these configurations in the app.yaml file over here. This app.yaml file is actually generated at the time of deployment, in which you can see all these configurations. But if you look at the source code of the app.yaml file for the service which we deployed, in this service we just define these many configurations. Here we define the scaling type as manual scaling with one instance, and we also define number of CPU, memory, and disk size for this particular version of the service. This level of customization is not possible in case of standard environment. Also notice that both these versions belong to the same default service. It means in one service you can deploy different version in different environment, and these versions can use the different runtime as well. Like here, in this case, this particular version is deployed in standard environment and it uses the Java 8 runtime. And this version is deployed in flexible environment and it uses the Python runtime. Just notice that in case of flexible environment, minimum one instance will always run for your deployed version. It cannot scale down to 0 like in case of standard environment. And if you want to see this instance, then click here, and here is the instance for the version running in flexible environment. You can also do SSH into this instance by clicking over here, and this option is not available for the instance running in standard environment. So this is all I wanted to show you in this demo. Now let's look at very important concept in App Engine, that is traffic splitting. Let's see what is traffic splitting and when it should be used using a scenario. Consider a case where you are running version v1 of your service and you found some bug in this version. So now you deploy another version v2 of your service with the fix of this bug. But you do not want to make version v2 available to all your customers. In fact, you just want to limit the availability of this version v2 to very few customers only. This is the case where traffic splitting can help you. By using traffic splitting, you can control what percentage of traffic goes to which version. You can choose to send either 100% of traffic to version v1, or you can choose to send some percentage of traffic to version v1 and remaining traffic to version v2. As shown over here, I have deployed two versions of the same service and traffic is equally split between these two versions, and one instance is running for each version. Now, if you want to change the percentage of traffic allocated between these two versions, then select both the versions and click on Split Traffic button. Here, you can split the traffic based on three conditions. It could be either based on client IP address, or it could be based on cookie present in the client request, or it could be distributed randomly between these two versions. If you choose client IP address based traffic splitting, then all the requests from one IP will always go to one version only. In case of cookie based traffic splitting, cookie is read from the client request, and based on the value of the cookie, client request will be directed towards a particular version. In case of random traffic splitting, version of the service will be selected randomly. Currently, I have distributed the traffic between these two versions randomly and traffic is equally split between these two versions. But if you want to change this percentage of traffic allocation between these two versions, then you can change it from here. So let me change this traffic percentage allocation. Now click on Save button. So this is how you can change the percentage of traffic allocation between these two versions. Now let's see the response of the service. For this, refresh this page sometime. So this time you got the response from version V1. This time you got the response from version V2. This is how you can test your second version without exposing it to all your customers. And once you are satisfied with the result of version V2, then you can shift whole traffic to version V2, which means version V2 will become live for all the customers in this case. We call this type of testing as A/B testing. This is how you can do A/B testing by using the traffic split feature of App Engine. In addition to splitting the traffic between these two versions of your service, you can also choose to migrate the traffic from version V1 to version V2 by selecting this migrate traffic option. And for this, you just select the target version and then click on migrate traffic button. When you select this migrate traffic option, then traffic will be migrated to the new version either gradually or immediately, which depends upon this warm-up request setting. Here, this checkbox is disabled, which means warm-up request is currently enabled. And when warm-up request is enabled, then traffic is migrated gradually by first sending some warm-up request to the new instance before those instance can receive any user request. This way, warm-up requests improve the user response time by creating the required instances in advance for the selected version. But if you want to disable this warm-up request setting, then you can select this checkbox to migrate the whole traffic immediately to the new version. But keep in mind that if you immediately migrate your entire traffic to new version without a running instance of the new version, then you will experience a spike in latency for some initial request because instance creation may take some time in this case for the new version. For this demo, I will select this checkbox and then click on this migrate button to immediately migrate the traffic to the new target version. Now your whole traffic has been migrated to the new target version. Now let's see the response of this service. Refresh this page couple of times. So you can see over here that whole traffic has been migrated to the new target version and all the responses are same in this case. So this is how you can use the traffic migrate feature in App Engine to migrate traffic from one version to another version so easily. In this video, I will show you some of the important commands related to App Engine. And for this, I will use this project, App Engine Learning. And in this project, I have already created one App Engine application in Asia Southern region. And here, I have already deployed one default service in standard App Engine environment. And this service has one version. And this version uses the Python 3.9 runtime environment. I deployed this service by using gcloud app deploy command, which is one of the most common and important commands that you must know. This gcloud app deploy command is used to deploy any application in App Engine. To deploy this service, I used one quick start tutorial, and to check that tutorial, click on the dashboard, then click here, then select this option App Engine Quick Start, and then select the Python here to select the Python based tutorial. And this is the quick start tutorial which I used to deploy this service. Now coming back to commands. So after this deployment, if you want to list these services in your App Engine application, then you will use command gcloud app services list. Let's try this command in Cloud Shell. Press enter, click on authorize. So here you can see that currently there is only one service, that is default service. And this default service has only one version. If you want to see the list of all the versions in your application, then you can use the command gcloud app version list. Let's try this as well in Cloud Shell. So here it has printed all the information about all the versions in your App Engine application. And here there is only one version that is serving the 100% traffic for the default service. And this is the version ID of this version. And this version ID is an auto-generated number which is generated by GCP at the time of deployment. So this way, this gcloud app versions list command will give you the list of all the versions in your application. But in case you want to see the list of versions for a particular service, then you need to pass the service name as well in previous command. So let me check that as well. This time I will pass service name as a default. So this time it will give me the version list for the default service only. Similarly, if you want to see the list of all running instances, then use the command gcloud app instances list. Let's try this as well. So it is showing that no instance is running right now. But why so? It is because I deployed the default service in App Engine standard environment. And in case of standard environment, if there is no traffic for the service, then instance count will reduce to 0. Now let's try to make some request. And to make some request, click on the service name over here. So it will show you the hello world response. Now let's try to rerun the command. And this time you can see that one instance is running for the default service and this version. And if you want to check the instances for a particular service only, then you need to pass the service name as well. So let me try that as well. So this time it will give you the instances for a particular service only. Similarly, if you want to see the list of instances for a particular version, then you can pass the version name as well. Let me try that as well. This time I will use this version. Now press enter. Now this way it will give you the list of instances for the given version only. Now if you want to deploy the second version of your service by using gcloud app deploy command, but you do not want to use the auto generated version name, then you can use the command gcloud app deploy -- version, where you can specify the name of the new version by using the -- version flag. Now before doing the second deployment, let's make some code changes. And for this you need to go to Cloud Shell editor. Then you need to go to the folder that contains the code. And for this, click here. And then select this folder and click on open. Then select this App Engine folder. Then within App Engine, select this standard underscore Python 3. And within this folder, select the hello world. So this is the folder that contains the code for my deployed service as of now. And this main.py file contains the code that is giving you the current response of hello world. Now I will make some changes in the current code so that we can see the difference in the response of version 1 and version 2. So I will change this message to hello world version 2. Now save this file. Now close this Cloud Shell editor and try to deploy this second version. Before doing the deployment here, first you need to go to the directory that contains the code and then use the command gcloud app deploy -- version equal to version 2. Now press enter. So here just observe that this time target version name is version 2. Now say yes. Now it will take some time for this second deployment to get completed, and by the time this second deployment is getting completed, you can observe that your response is still coming from version 1. And once this second deployment is complete, then all the traffic will be served by the second version by default. This way, your application will never be unavailable at any point. Now let's wait for some time for this second deployment to get completed. And I will pause the video till then. Now this deployment is complete. And if you check the service URL once again, then you will observe that now response is coming from the version 2. You can also verify this thing by doing the version listing. So here you can see that the entire traffic is getting served by the version 2 now. Now you have noticed that as soon as we deployed the second version of our Hello World service, the entire traffic was getting served by the second version after the successful deployment. But in case you do not want this to happen, then you can pass one extra argument with your gcloud app deploy command, that is --no promote. Let's try this as well. For this, first I will change this Hello World version 2 message to Hello World version 3. Now save this file and then close the editor. Now I will deploy the third version by using --no promote option. Press enter. Here just observe that this --promote is used to be the default option when you make some deployment in App Engine application. And because of this default option, the entire traffic gets shifted to the latest version which you deploy. On the other hand, if you specify --no promote in your App Engine deploy command while doing the deployment, then entire traffic will not be shifted to the latest version which you are going to deploy in your App Engine application. Now say yes over here and wait for the deployment to get completed. I will pause the video till then. Now this deployment is complete. Let's do the version listing once again. And here you can notice that version 2 is still serving the entire traffic. No traffic is getting served by the version 3. You can also verify this thing over here. Let's do the page refresh. So you can see that response is still coming from the version 2. Now, so far we use this service URL to access our deployed service. And you can reach to this URL by clicking on the service name over here. But how can you check this URL name via command line? For this, you can use gcloud app browse --service command. Here, this --service parameter is optional. If you specify the value of this parameter, then it will give you the URL of the specified service. Else, it will give you the URL of the default service. Let's try this as well. So here it has printed the URL of the default service because I did not specify any service name over here. In addition to service level URL, each version also has its own URL, which you can use to access the particular version of the specified service. Like if you click over here, then here you can see the version level URL, and you can use this URL to access the particular version of the service. Now, if you want to check the version specific URL via command line, then you need to pass the additional parameter --version with gcloud app browse --service command. Like just now you deployed the third version of your default service and traffic was not migrated to this third version. But you want to test this third version. And for doing the testing, you need the version specific URL of this third version. So in such case, to get the URL of your third version, you can use the command gcloud app browse --version equal to version 3. Now press enter. And here it will give you the URL of your third version. If you open this URL in your browser, then you will get the response from version 3. And you can see that now you are getting Hello World version 3. If you compare your version specific URL with your service URL, then you will observe that in version specific URL, just version and then hyphen dot is added as a prefix to the default service URL. Rest everything remains same. Next, if you want to split the traffic between version 2 and version 3, then how can you do this via command line? For this, you can use command gcloud app services set traffic hyphen hyphen split, where hyphen hyphen splits parameter will specify how you want to split the traffic among the different versions. Like if you want to split the traffic between version 2 and version 3 in a way that half of the traffic is served by version 2 and other half of the traffic is served by version 3, then you will write this command. Here, just notice that for both version 2 and version 3, I have specified the value of split as 0.5, so that half of the traffic is served by version 2 and other half of the traffic is served by version 3. Now press enter, say yes, and now this traffic split is complete. And here also you can see that both version 2 and version 3 are serving 50-50% traffic. You can also verify this thing by doing the version listing. So here also you can see that both version 2 and version 3 are serving half of traffic each. Now let's try to access the service URL, and for this click here. Now refresh this page couple of times. Now question is that if both version 2 and version 3 are serving equal amount of traffic, then why I am getting the same response again and again? Actually, while doing the traffic split between the two versions, we can split the traffic either based on the IP, which is the default option, or we can do the traffic split based on this cookie, which is set by your application, or we can split the traffic randomly between the versions. So currently this traffic split is done by IP address. So if you refresh your service URL page multiple times, then you will see that same response is coming all the time. It is because traffic split is done by IP address by default. So all the requests from one IP address will be served by one version only. Now can we also configure how do we want to split the traffic between two versions while doing the traffic split via command line? Yes, if you want to configure this setting as well while doing the traffic splitting, then you need to pass extra parameter hyphen hyphen split by in your set traffic split command. And possible values of this split by flag are cookie, IP, and random. Now I will split the traffic randomly between both version 2 and version 3. And for this I will use this command. Press enter, say yes. Now this traffic split is complete. Now again refresh the service URL page couple of times. So here you can see that now response is coming from both version 2 and version 3. Now after doing some testing, if you want to migrate the entire traffic to version 3, then you can use this command. Press enter, say yes. Just notice that here in splits I have specified the version 3 only, which will serve the entire traffic. And here also you can verify that now entire traffic is getting served by version 3. Okay, now so far we have used gcloud app commands for default service only. But next question is how to create another service which is not a default service. You can create another service in the same way with gcloud app deploy command. But only change that you need for this is just specify the name of your second service in your app.yaml file in your service code. Just notice that for our hello world example, currently in this app.yaml file, service name is not specified. And that is the reason that this service is deployed as default service. Now I will specify the service name for this service. I will also make changes in main.py file for this second service. Now let's deploy this service. First go to the directory where code is written. Now run command gcloud app deploy. Say yes over here. Now let's wait for some time for this deployment to get complete. Now this deployment of service 2 is complete. And here also you can see your service 2 in this list. Now if you want to get the URL of this service 2, then run this command gcloud app browse -- service equal to service 2. And this is the URL of this second service. Now click on this URL. And here you can see the response from your service 2. Just notice that this time you need to specify -- service parameter value to be service 2 to get the URL of this service 2. If you won't specify this parameter, then you will get the URL of default service only. So this is all about the important commands related to App Engine. Now let's see how instances are created and scaled inside App Engine. Basically, App Engine supports three scaling types, which control how and when instances are created inside App Engine. And these scaling types are automatic scaling, basic scaling, and manual scaling. And among these three scaling type options, the default scaling option is automatic scaling, where instances are auto-scaled based on the traffic load. In this case, App Engine will decide when to start or stop the new instance for you based on few metrics, such as number of concurrent requests or the longest time a given request should wait around in a queue, or it could be the number of instances that can be idle at any given time. All these settings have default values, but you can change them in your app.yaml configuration file. This scaling type is generally preferred for the continuous workload. With automatic scaling, you can configure settings like minimum and maximum number of instances for your deployment. You can also define settings like target CPU utilization, target throughput utilization, and maximum concurrent request. Here, target CPU utilization specify the CPU usage upper limit at which more instances will be started to handle the traffic. And target throughput utilization set the overall maximum number of concurrent requests after which more instances will be started to handle the traffic. And maximum concurrent requests set the maximum number of concurrent requests that one particular instance can accept before scheduler creates a new instance. Basic scaling is another scaling option that App Engine standard provides, and it is like a slimmed down version of the automatic scaling. In case of basic scaling, instances are created when your application actually receives the request. And in this case, each instance will be shut down when application becomes idle. It can even go down to 0 instances if there is no request. Basic scaling is ideal for the workload that is intermittent or driven by the user activity, because in such kind of workload, you do not need to run instances all the time. So in such case, to minimize the cost, basic scaling is a good option. Basic scaling has only two options to control scaling. What is maximum number of instances, and second is how long to keep an idle instance around before turning it off. One concern that you might feel with basic scaling is high latency, because in case of basic scaling, if all the instances are shut down and a request is received, then request can be served only after instance is created on demand. So for latency sensitive application, basic scaling is not a good idea. And one more thing about basic scaling is that it is not supported by App Engine flexible environment. It is only supported by App Engine standard environment. Another scaling option is manual scaling, in which scaling of the instances is controlled by the user manually. And this scaling type is generally preferred either for the task that requires complex initializations or the application that rely on the state of memory over time. In case of manual scaling, you have to specify the number of instances that continuously run, regardless of the load level, and you can change this value as per your need. The only challenge with manual scaling is that it is very difficult to estimate the correct number of instances required for your service. In this video, let's talk about what is app.yaml file and what is its purpose. Actually, App Engine does not understand the source code of your application. Then, how does App Engine deploy your code? How does App Engine find what should be the service name or other configurations for your deployment? Actually, for this, you need to add one configuration file in your code, and this file is known as app.yaml file, which tells App Engine how to configure an application. YAML file format is both human and machine readable syntax for some structured data, and App Engine look for this app.yaml file when you deploy your application. Each service in your application has its own app.yaml file, which acts as a descriptor for its deployment. This app.yaml file defines all the configuration required for the deployment, like name of service, runtime involved, handlers for the URL mapping, scaling information, latest version identifier, or environment variable needed for the deployment, and so on. Just remember that you must first create the app.yaml file for the default service before you can create and deploy any additional service in your application. So we have seen how to deploy a service in App Engine and how to invoke that service via HTTP endpoint. In this video, let's discuss how request routing can be done for a HTTP request in App Engine. So basically, there are three ways by which you can specify the request routing rules in App Engine. First is routing with URL, second is routing with dispatch file, and third is routing with cloud load balancer. In case of routing with URL, there are a couple of ways to specify the URL which is targeted to a particular service or a version. First is the very simple pattern which is targeted for the default service in your application. In this case, URL pattern is project ID dot region ID and then this suffix r.appspot.com. In this URL, no service or version is specified. So when you hit this URL, then response will come from the default service. Like if you click on the default service over here, then it will open this kind of URL. In this URL, this is the project ID and this EL is the region ID. Second URL pattern is for a particular service and this service specific URL pattern look like this. Here just notice that service ID is specified before the project ID and region ID. Like if you click on this service 2 over here, then it will open this kind of URL. Third URL pattern is for the specific version of the specified service. And this version specific URL pattern look like this. Here just notice that version ID is specified before the service, project and region ID. You generally use this pattern for the version which is not serving the traffic as of now. Like if you deploy some version for the canary testing, then you can use this URL pattern to test that version before shifting the actual traffic onto that version. Like currently there are two versions for this service 2 and this particular version is serving the whole traffic. But in case you want to test this particular version, then click over here. And in this case, it will open this kind of version specific URL where this particular number actually represents the version ID. Similarly, if you are using manually scaled services, then you can target and send the request to a particular instance by including the instance ID in your URL, like this. Here just notice that instance ID is the first thing in your URL. Now also look at one very special case. In this case, I will change this URL and I will change this service name from service 2 to service 1, which does not exist. And now hit this URL. Now you got the response from the default service. But why so? You got the response from the default service because of the soft routing rule. And this soft routing rule says if your request matches with this particular portion of the hostname, but it includes a non-existing service, version or instance name, then your request will be routed to the default service. Now, if you want to override these URL based request routing rules, then you can add dispatch.yaml file in your code. And this dispatch.yaml file allows you to define custom rules for request routing. And you can create this file either in root of your project directory or in root directory of your default service. And with custom rules defined in this file, you can route the incoming request to a specific service based on the path or the hostname in the request URL. Like if you define these kind of rules in your dispatch.yaml file, then any URL that ends with /mobile like this will be routed to mobile frontend, and any URL that ends with /work like this will be routed to static backend. Another way to route the incoming traffic for App Engine application is based on Cloud Load Balancer. And in this case, first incoming request will be received by Cloud Load Balancer. And you also need to configure a serverless network endpoint group that in turn points to the App Engine service. Like this diagram here represents the request flow for such use case. In this diagram, request is first received by the Cloud Load Balancer, then it is routed to App Engine service, which is configured as a backend service in your load balancer via serverless network endpoint group. We have learned how to invoke a HTTP endpoint of a service deployed in App Engine application. But in addition to direct invocation of HTTP endpoint, you can also create a schedule job that can invoke the service URL either at the defined time or at regular interval. And to schedule a job, you need to create a cron.yaml file in your project root directory that will define all the information required to schedule the job. And App Engine has a built-in cron service that will read this cron.yaml file to determine the time at which your job should run and which endpoint it should hit. This way, App Engine cron service allow you to configure schedule tasks that operate either at the defined time or at regular interval, like sending out a report email on a daily basis, or update some cache data every 10 minutes, or update some summary information once an hour. One such example of cron.yaml file is this. In this cron.yaml file, one daily summary job is configured that is scheduled to run once in every 24 hours. And this job invokes the /task/summary URL of your service. In this chapter, we will learn about very important service in Google Cloud, that is Google Kubernetes Engine. And you will surely get some questions based on this cloud service. So let's see what is Google Kubernetes Engine, or you can say GKE. GKE is a management and orchestration system for container clusters that run within GCP, and GKE runs Kubernetes. GKE helps in deploying, managing, and scaling your containerized application using Google infrastructure. Kubernetes cluster consists of many compute engine instances, and you can run your application inside them as container. GKE is a part of infrastructure as a service, or you can say container as a service offering provided in Google Cloud. Kubernetes is a portable, extensible, and open source platform for managing the containerized workload and services. Since GKE is based on Kubernetes, it allows the declarative configuration and automation for your services deployed in GKE cluster. In addition to this, it also provides advantages like automatic management, monitoring the health for your application container, automatic scaling, running update, and so on. And Google has been using this platform for hosting its own application since a long time. So they have good expertise in managing the GKE clusters. Now, before doing the deep dive into GKE service, let's quickly look at why and how the container-based technology has evolved. Traditionally, this is how we used to deploy our applications on physical servers directly. In this approach, we have deployed multiple applications on physical server directly. This approach of deployment had few drawbacks. There was no way to define the resource boundaries for your application in a physical server, and this caused the resource allocation issue. For example, if multiple applications run on a physical service, there can be a case where one application would take up the most of the resources, and as a result of this, other application would underperform. A solution for this would be to run each application on a different physical server. But this approach did not scale well as the resources were underutilized in this case, and it was expensive for the organization to maintain the many physical servers. To solve the issue of underutilization of the resources or the headache for maintaining the multiple physical server, virtualization was introduced. This virtualization allows multiple virtual machines on a single physical server CPU, and virtualization allows applications to be isolated between the VMs. Virtual machines are the secure way to deploy your application, as these are isolated from each other and one application cannot be freely accessed by another application running inside the VM. Virtualization allows better utilization of resources in a physical server and allow better scalability because an application can be added or updated easily. It also helps in reducing the hardware cost because with this approach, multiple VMs run on a single physical server. In this virtualized approach, virtual machines allow a piece of hardware to host multiple operating systems as software. Virtual machines are added to the host machine so that the hardware power can be shared among different users, and these virtual machines appear as a separate server or machines. In this approach, under each VM, there is a common VM monitor, or you can say hypervisor, which ensure that one or more VM are able to run on host machine and interact with hardware and other infrastructure. With this hardware virtualization, each VM is like a full machine running all the components, and it has its own operating system as well on top of the virtualized hardware. So this way, VM virtualization has solved one problem of efficient use of hardware resource by providing the hardware virtualization to deploy your application. But there are some issues with this virtualization approach as well. Like VM is very heavy weight in this case because it contains the full OS image. And because of this issue, it is not easy to port a VM to other machine quickly. And another problem is how to bundle an application in an isolated way for the different environment and how to deploy your application quickly. And this problem was answered by containers by defining the portable application bundle in terms of containers. A container image is a lightweight standalone executable package that also encapsulates everything that is needed to run it. This would include code, the runtime, system tools, system libraries, and the settings. Containers are lightweight as compared to virtual machine because containers do not require hypervisor and it does not need a guest OS like a virtual machine. Similar to a VM, a container also has its own file system, CPU, memory, process space, and more. Also note that containers are easily portable across cloud and the VM. So now it is good that we can define the application bundle as container, which can be easily executed. And in a production environment, we need to manage the container that run the application and ensure that there is no downtime. But there are still some questions that needs to be answered, like who will manage the life cycle of these container. And in a production environment, if one container goes down, then the another container should be restarted. But who will restart the another container in this case? This is where Kubernetes helps us. It takes care of scaling and the failover for your application. Kubernetes has built-in command to handle a lot of heavy lifting that goes into application management. This allows you to automate day-to-day operation. You can make sure applications are always running the way you want them to run. When you install Kubernetes, it handles the compute, networking, and storage on behalf of your workload. This allows developers to focus on the application without worrying about the underlying environment. Kubernetes helps you to build cloud-native microservice-based application, and it also supports containerization of existing applications. Kubernetes continuously run health check against your services and restart the container that fails. It makes service available to user when it has confirmed that services are running successfully. Kubernetes can be used anywhere, which allows you to run your application either in your on-premise data center or in public cloud. You can also run application in hybrid mode as well. Now let's try to understand GKE architecture in GCP. But before I explain GKE architecture, just understand that GKE is not the Kubernetes cluster. In fact, GKE is just a management service in GCP that allows you to run Kubernetes cluster in GCP and orchestrate containers running inside those clusters. This diagram here represents the Kubernetes cluster running inside GCP in terms of various Kubernetes objects and how this is managed by GKE. In GKE, a cluster consists of at least one control plane and multiple worker machines called nodes. The control plane runs the control plane processes like Kubernetes API server, scheduler, and core resource controllers. The lifecycle of control plane is managed by GKE, like when you create or delete a cluster. GKE also manages when to upgrade this control plane and which version of Kubernetes will run inside this. This control plane runs Kubernetes API server inside it, which exposes the Kubernetes API. These API endpoints are the single way to interact with your cluster and manages all type of interaction with the cluster. So if you want to interact with the cluster, then it must be via the same API. And similarly, if there is any internal cluster process such as cluster nodes or controllers or scheduler or any other system process, they also talk to the control plane via the same API. And this control plane is the only source of truth for the entire cluster. This control plane manages the entire cluster and it is responsible for deciding what to run and when to run inside the cluster. This can include scheduling workloads, managing the workload's lifecycle, scaling and upgrade. The control plane also manages the network and the storage resources for those workloads. Now come to nodes. A cluster also has one or more nodes, which are the worker machines that run your containerized applications and other workloads. These nodes talk to API server for the work assignment and then execute the work and then report the result back to the control plane. Each node runs multiple pods inside it and each pod runs the application as a Docker container. Each node is managed by the control plane and control plane controls the auto scaling of both node and the pods running inside that particular node. Now we will talk about various objects in Kubernetes cluster, and first such object is node. A node is the actual working machine in Kubernetes cluster and it can be either a physical machine or a VM. A cluster typically has one or more nodes and your containerized application run inside these workers. And in case of GKE, these nodes are compute engine VM instances that GKE creates on your behalf when you create a cluster. Lifecycle of these nodes is managed by the control plane and GKE performs the automatic repair and automatic upgrade on your cluster's node. Whenever you create a Kubernetes cluster via GKE, you need to specify how many nodes you need in your cluster. And each node has all the required configurations required to run a pod on it. And each node also runs the Docker runtime required to support the Docker container which contains your application. Like in this diagram over here, there is one master control plane and there are three nodes inside this cluster. Each node also contains the Kubernetes node agent known as kubelets, which communicates with this master node via Kubernetes API, and these kubelets are responsible for running the pod inside the worker node. The master control plane talks to the node instance via kubelets, and these kubelets in turn manage the pod and the container inside the node. In GKE, there are also a number of special containers that runs as per node agents to provide the functionalities such as log collection and intra-cluster network connectivity. Another important object in Kubernetes cluster is pod. A pod is the atomic unit of Kubernetes cluster orchestration, and inside each pod there can be one or multiple containers, and all the containers inside pod share the same underlying resources, like they will all have the same IP address and they can share the disk volume. Based on the availability of the resources, master control plane schedule the pod on a specific node, and it also coordinates with the container runtime to launch the container inside the pod. In case if any pod fails to perform their task due to any reason, then Kubernetes engine does not attempt to fix them. Instead, it starts a new pod in its place. And due to this flexible nature of Kubernetes architecture, you must design your application in a way that is agnostic of the location of the pod in the cluster. there can be multiple containers inside one pod. And if we consider an example of a web server pod, then there will be one container for the web application inside your pod and other containers for the logging and the metrics infrastructure in the same pod. You can define pods using the configuration file specified either in JSON or YAML format. You can create or delete a pod by invoking a REST endpoint exposed by the Kubernetes API server. And this API server is responsible for serving the REST request like scheduling the pod creation, deletion, and synchronizing the information across the different pods. There is one more important point that you all must understand about nodes in GKE is that all the nodes in the cluster do not need to have the similar configurations. In fact, you can create different group of the nodes with the similar configuration and each such group is called as node pool. And there can be multiple node pools in a cluster. It means a node pool is the subset of machines within the cluster that share the same configurations. It is like a pool of compute engine VM instances in an instance group which are created from the same instance template. Just remember that you can run different Kubernetes node version on each node pool in your cluster and update each node pool independently. You can also target different node pools for the specific deployment. When you create a cluster, a default node pool is created for your cluster and the number and the type of nodes that you specify at the time of cluster creation becomes the part of this default node pool. You can create, upgrade, and delete the node pool individually without affecting the whole cluster. When you create a GKE cluster or a node pool, you can choose the operating system image that runs on each node, and you can also upgrade an existing cluster to use a different node image type. Now let's see how can we create a Kubernetes cluster in GCP in few minutes. To create a Kubernetes cluster, click over here and select the Kubernetes engine option. Then click on the Create Cluster button. On this page, you have two options to create your cluster. Either you can create the cluster by selecting the My First Cluster option. If you choose this option, then it will create a cluster for you with the default configurations, and it is the easiest way to launch your cluster in GCP. Second option here is to create your cluster with complete customization based on your requirements. If you choose this second option, then you will have the full control to define the various aspects of your cluster like default pool, automation, networking, security, etc. Here you need to give the name to your cluster and then select the zone or the region for your cluster. You can either create a single zone cluster by selecting a single zone from here, or you can choose to create a regional cluster by selecting the region for your cluster. You can also choose to create a multi-zone cluster if you choose the multiple zones from here. For this demo, I will select a single zone cluster with the default location. Here you can also choose the version of the GKE to be used for your cluster. For the timing, I will keep this as it is. Now let's look at the default pool. Under default pool options, you can configure node pool for your cluster, which is nothing but the group of node in your cluster. Here you can give the name to your node pool. You can also define version of GKE to be used for each node in the pool. By default, latest version is selected. You can change it if you want. You can also define the number of nodes in your pool over here, and you can also select the auto scaling option as well. If you select this auto scaling option, then it allows you to configure minimum and the maximum number of nodes in your node pool. You can also choose zones where you want to create nodes for your cluster, and Kubernetes tries to do the equal distribution of the nodes among all selected zones over here. Also note that these settings will override the settings that you have defined in the cluster section over here. Auto upgrade and the auto repair options is enabled by default. And you can also add the additional node pool here by clicking on the Add Node Pool button. In the same way, you can also remove the node pool from the existing cluster by clicking on the Remove Node Pool button. Here I will use all the default settings for this demo. Now let's configure nodes under this default pool. Setting under node section is very similar to what you have seen while creating Compute Engine VM instance. Here you can choose configurations like node OS image. You can also choose any of the machine family. You can select either general purpose or compute optimized or memory optimized machine family. Here you can choose the machine type. Let me choose the E2 small machine for this demo. Here you need to select the boot disk type. You can choose either standard persistent disk or SSD persistent disk. Here you need to give the boot disk size. If you want to use your own encryption keys for the boot disk, then you must enable this checkbox. If you want to use preemptible VMs for your node, then you must enable this checkbox. Here you can control maximum number of pods that can run on a node in this node pool. Here you can attach network tags with your VM instances created for the nodes. For the time being, I will not change any of these settings and will move to the security. Here under security, you can select the service account that you want to use with these worker node VM and the permission assigned to the selected service account. You can either give default permission to the service account or give the full access to the service account, or you can also do the customization for each API individually. As of now, for this demo, I will keep all the settings as default and I will create cluster by clicking on the create button. Now it will take couple of minutes to create all the required resources in GCP for your cluster, and I will pause the video till then. Now this cluster is created in GCP. Let's see what all resources have been created with this cluster. To check that, click on the cluster name. On this page, under Details tab, you can see all the details of the cluster configurations that you defined while creating cluster, like GKE version, location of the cluster, or network of the cluster used, and so on. You can also see your node pool over here. Here you can see that default node pool is created with the 3 nodes. You can also see GKE version for your node pool. Also notice that auto scaling is off for this node pool. Under Storage tab, you can see the storage information of the cluster. Under Nodes tab, you can see the worker nodes created for your cluster. You can see 3 worker nodes are created within this cluster, and each worker node is just a Compute Engine VM instance only. Now let's go back to the default node pool once again. Let's check the detail of the node pool. If you look at the node pool details here, you will notice that this node pool has created a managed instance group, and all the nodes here are part of this particular instance group. Now if you click on the instance group over here, then you can see the instance template used by this instance group. So this is how all the worker nodes inside your cluster are created using the managed instance group. Now click on the disk option over here. Here you can see that 3 boot disks are created by these worker nodes. Now let's go back to GKE once again. So this is how we can create Kubernetes cluster in GCP so easily. Now let's see what are the labels and selectors. Actually, labels are the key value pairs that you can attach to objects such as pods. And You can attach extra metadata with the objects using these labels, and these are more meaningful to users. These are very much similar to the labels that you attach with your Compute Engine VM instances during VM instance creation. You can attach labels with the object either at the time of object creation, or you can modify or add more labels with the object after the object creation as well. These labels can be used to organize and to select the subset of objects. Also notice that each object can have multiple labels associated with it, and one label can be associated with multiple objects as well. Just remember that these labels do not provide uniqueness. In general, we can say that many objects can carry the same label, and you can select the set of objects based on the selectors. Some of the commonly used examples of the labels are shown over here, like you can associate environment label with your pod to identify whether it belongs to the dev environment, or it belongs to QA environment, or it belongs to production environment. For example, here is the configuration code for a pod that has two labels, environment and tier. Environment has the value production and tier label has the value front end. Now, once you attach labels with your resources in your cluster, how can you select the resources with specific labels? This is the problem that is answered by selectors. Selectors provide a way to select the resources for the given labels. Like here, if you want to select this pod which you have defined over here, then you can use this kubectl command with the label selector like this. So this is how you can use labels and selectors. Now let's see what is a service in Kubernetes. A Kubernetes service is a REST object. A service is an abstraction that defines a logical set of pods and a policy for accessing these pods. You already know that in Kubernetes, application is run as container inside the pod, and there can be multiple containers in one pod. But if you want to reach to your application, do you know how you can do this? Do you know which IP address you should use to reach to your application? When you run your application as container inside pod, then all the containers running in a single pod use the same IP address, which is the IP address of the pod. But each pod can have the different IP address. It means if there are three instances of your application and all the instances run in different pod, then all the instances will have the different IP address as shown over here. Like here, if first instance of your application run inside this container, and second instance run inside this container, and third instance run inside this container, then each application instance will have the different IP address of the corresponding pod. So in this case, first instance will use this IP address, second instance will use this IP address, and third instance will use this IP address. So this way you do not have a single IP address to reach to your application instances. Ideally, there should be something like a load balancer, which not only gives you the single IP address for your application instances, but also do the traffic distribution among your application instances. There is one more issue with pod because of their auto-scaling nature. Because of auto-scaling nature of the pod, IP address of the container will keep on changing as the pod come and go. So what is the solution to this problem in Kubernetes? And this is where service object in Kubernetes comes into picture. This problem is solved by service object. In Kubernetes, you can create an abstract object known as service, which will provide you one single IP address on top of these pods for your application instances. And this service do the load distribution among your application containers. As you can see in this diagram, there are three pods with three different IP address, and all these pods are running your application inside the container. And all the container within each pod use the same IP address of the corresponding pod. Without service object, there is no way to reach to your application with single IP address. But once you define this service object on top of these pods, you can reach to your application by single IP, that is the IP address provided by the service object. And IP address provided by this service object will remain same even if number of pod increase or decrease because of the auto-scaling nature of pod. This way, by using this service object, you can always reach to your application instances via this single IP address. Also remember that these pods are actually associated with service through labels and selectors. And because of this, service object automatically discovers a new pod with the label that matches the specified selector. Like if you attach a label with value as web server with your pod in your pod configuration file and associate such pods with service via selector that use this label, then any pod created by this pod configuration file will be automatically discovered and added to this particular service. There are various types of service objects that you can create depending upon from where your application can be accessed. Let's consider an example of three-tier application in your cluster to understand how service works. Here you have front-end pods which are exposed by service 1, your backend pods are exposed by service 2, and your database pods are exposed by service 3. Since your front-end pods should be reachable to application users via internet, so you must define the service 1 as the load balancer service. But service 2 for your backend pods and service 3 for your database pods must be of cluster type service because both backend and the database should be accessible within cluster only. Definitely, you do not want to expose them to internet world. So, based on your use case requirement, you can create different type of service objects. You can create either load balancer service or cluster service or node port service or external name service or headless service. In case of load balancer service, clients can send requests to the IP address of a network load balancer. In case of cluster service, your application is reachable only via internal clients inside your cluster only. In case of node port service, clients can send requests to the IP address of a node on one or more node port values that are specified by the service. External name service object allows internal clients to use DNS name of a service as an alias. And you can use headless service in a situation where you want a pod grouping, but you do not need a stable IP address. So this is how service objects helps to connect different applications together or connect application to the external user. Any kind of application that you deploy in your cluster definitely needs some kind of storage to store your application data. Now we will talk about what are the options do we have to define the storage in Kubernetes cluster, how data is persisted beyond pod life, and how data is shared among the containers running inside your pod. In GKE, you can define storage in terms of volume, which is an abstraction on top of file system and block storage attached with your pod. You can create and attach volume to a pod, which can be accessed like a directory by containers inside that pod. And once you attach a volume to a pod, all the containers inside pod can access that storage. It means this volume will be shared by all the containers running inside your pod. Actually, this concept of volume was present with the Docker, but in case of Docker, volume was very much limited to a particular container, and as soon as the life of the container ends, the volume was also lost. But in case of Kubernetes cluster, the volume that you create is not limited to any container. In Kubernetes, based on the data retention, at high level, you have two options in terms of storage volume. First is the ephemeral volume, and second is the persistent volume. As the name suggests, this ephemeral volume is ephemeral in nature. It is like a local disk attached to your compute engine VM instance, and any data on this volume will be lost in case your pod is stopped or restarted. In this case, life cycle of the volume is same as life cycle of your pod. It means this volume is created when pod is created and it is deleted once your pod goes away. So now, if you want your data to be persisted and available even after your pod restart or failure happens, then you have to go with the second option, that is persistent volume. It is like a persistent disk attached to your compute engine VM instance. Data stored in persistent volume will not be lost in case of pod failure or restart happens. And life cycle of such volume is beyond the pod life. If you look at this code shown here on this page, this code creates a persistent volume. And here you can define some properties of the volume like name, label, capacity, or the path where this volume can be accessed. Traditionally, if you have to deploy your application, then you do it via script, which control what resources needs to be created, where to create those resources, and how to create those resources. The problem with this approach is that the script has probability to fail, and if it fails, it can leave the system in intermediate state, which is very difficult to fix. But in Kubernetes, you deploy your application in declarative manner using a YAML file rather than using script. It means you just tell what is desired state of the cluster that you want to have. You do not specify how to achieve it. It means you just describe the desired state in which you can specify something like how many pod replicas are needed, but you do not specify how to create those target number of pods and where to create it. Once you define the desired state in YAML file, then Kubernetes compare the current state with the desired state and allocate or remove the resources from cluster to achieve the desired state of the cluster. In such deployment, pods are supposed to be stateless, which means pods can come and go at any time. So you must design your application in a way that is not dependent on particular pod. Number of pods can change based on the autoscaling defined in your cluster. In case of GKE, deployment represents a set of multiple identical pods. A deployment runs multiple replicas of your application and automatically replace any instance that fails or become unresponsive. In this way, deployment ensures that one or more instances of your application are available to serve user requests, and deployments are managed by Kubernetes Deployment Controller. Deployment uses the pod template, which contains a specification for its pod. The pod specification determines how each pod should look like, what application should run inside its container, which volume the pod should mount, its labels, and more. When the pod template of the deployment is changed, then new pods are automatically created one at a time. If you look at the sample deployment YAML file over here, in this example, one deployment with name Nginx is created with 3 replicated pods, and all the pods are labeled with key as app and value as Nginx. This deployment opened the port 80 for use by the pods. In previous demo, we learned how to create a Kubernetes cluster in GCP, and now we have a cluster up and running from previous demo. In this demo, we will deploy WordPress application in this cluster. WordPress is simply a content management system application. This WordPress Docker image is a publicly available image, and we will use that image for our deployment. To deploy this WordPress application as Docker container in your cluster, select the cluster in which you want to deploy your application and then click on Deploy button. Here you can either choose an existing Docker image available in public Docker registry, or you can select an existing image either in container registry or in artifact registry managed by GCP. You can also select new container image from various possible sources like Cloud Source Repository or GitHub or Bitbucket as well. For this demo, I will use the publicly available WordPress Docker image. You can also add some environment variables here if you want for your deployment. For this demo, I will not use any environment variable. Now click on Continue button. Here you need to provide the name and the namespace for your deployment. You can also add one or more labels over here, and these labels will be applied to all the pods for this deployment. So let me provide the application name over here. Finally, before doing the deployment, you can see your deployment YAML file by clicking over here. And as per this YAML file, 3 replica of the pods will be created for this deployment. Also notice that horizontal pod autoscaler is configured for this deployment with minimum number of pod replica as 1 and maximum number of pod replicas as 5. This autoscaler continuously monitors the nodes and the pods running inside your cluster and do the scaling up and scaling down of these resources based on the workload on your application. And I will explain how autoscaling works in cluster in detail later on in this chapter. This deployment YAML file describes the desired state of your cluster, and this deployment defines how Kubernetes deploys your container image and manage the resources inside your cluster. and Kubernetes will ensure your system matches this configuration. Finally, click on this deployment button to trigger the deployment, and it will take some time for the deployment to happen, and I will pause this video till then. Now this deployment is completed successfully, and under this overview page you can see the aggregated CPU, memory and the disk usage for your pods running inside your cluster. Just notice that each deployment is given the unique revision name over here, and here you can see the pods running inside your cluster, and here you can see the autoscaler configuration for your cluster. If you want to see the more details about any pod, then click on the pod name, and here on this page you can see the complete detail about this pod. Now let's go back to the deployment page. If you want to see the container log or the audit log for this deployment, then click on the corresponding link. Like if you click on this link, then it will take you to cloud logging, and here you can see all the logs related to this deployment. Let's go back. Under this details tab, you can see the full details about your deployment, and in the same way, under this YAML tab, you can see the full YAML file describing this deployment. Next hurdle after this deployment is how to access the application. As of now, there is no way to interact with application container running inside pod, because pod IP address is visible inside your cluster only. To expose your pod, you need to create either node port service or load balancer service. With node port service, if your application is deployed across multiple nodes, then you can use IP address of any node to talk to your application running inside your pods. But with load balancer service, an external load balancer is configured on top of the nodes, and then single IP address is provided by the load balancer that can be used to interact with the application. This time, let's create a load balancer service for this deployment. To create a load balancer service for your deployment, click on the Expose button, then select the service type as load balancer, and after this you need to define the port mapping between the service port and the container port. And if you leave the target port as blank, then target port will be same as service port. In this case, both the port will be 80. If you want to check the YAML file for this service, then click here, and it will show you the YAML file for this service. And finally click on this expose button. So your service is created now, and you can see the details about this service on this page. And this is the IP address assigned to the load balancer created by this service. You can use this IP address to access your application. Let's try this one. So this is how you can access the WordPress application by using this IP address. And this is how you can deploy your application in Kubernetes cluster and expose it to the external world via load balancer service. If you have any queries regarding this, please post your queries. In this video, I will show you some of the important command types related to GKE managed Kubernetes cluster that you must know. So basically, we generally use two types of commands when we deal with GKE cluster. First is the gcloud container cluster command, and second is kubectl. And it is very important for you to understand the difference between these two commands. You should know very well which command should be used and when. Actually, main difference between these two commands is that gcloud container cluster command is primarily used for managing the allocation of the resources for the cluster itself. For example, you will use this command when you want to do the operations like create, modify and deletion of the cluster, or you want to change the number of nodes in the cluster and so on. kubectl on the other hand is the Kubernetes control command. It is used by all Kubernetes clusters regardless of where you have created your Kubernetes cluster. You can use kubectl command even if you have created your Kubernetes cluster either in your on-premise data center or in some other cloud like AWS. It has nothing specific to Google Cloud. You use kubectl command primarily for the manipulation of the workload on cluster after cluster creation. Like you will use kubectl command when you want to create a deployment, or you want to create or delete the pods, or you want to change the replica set count for your deployment. You will also use kubectl command when you want to manage some configurations data like configuration map or secret in your Kubernetes cluster, or you want to manage the role-based access, or you want to create the namespace in your cluster, and so on. So this is all about the difference between the gcloud container cluster and kubectl command, and you should understand this difference very well. But remember that before you can use this kubectl command with your GKE managed Kubernetes cluster in GCP, you first need to connect to the master control plane of your cluster. And for that, you need to use this command, gcloud container cluster get credentials. In this video, I will show you how to create a GKE managed Kubernetes cluster in GCP via gcloud container cluster command. And for this, I have created this project, GKE Learning. Now I will enable Kubernetes API for this project, which will allow us to build and manage the Kubernetes based application in Kubernetes cluster. Just remember that in Google Cloud, there is a different API for each service. And before using any service in your project, you will have to enable the corresponding API for your project. It will take some time to enable this API, and I will pause this video till then. So this Kubernetes API is enabled for this project. Now let's see how to create a GKE managed Kubernetes cluster via command line. In GKE, you can create two types of Kubernetes cluster. One is regional Kubernetes cluster and second is zonal Kubernetes cluster. And to create zonal Kubernetes cluster in GKE, you can use command gcloud container clusters create and then specify the name of your new cluster, then compute zone where you want to create the master control plane, and then the compute zones where you want to create your worker nodes. Here you can specify as many zones as needed for your cluster. But remember that for a zonal cluster, all the zones that you specify for both worker node and your control plane must be in the same region. If you want to create a regional cluster, then you will use the similar command. But in this case, you will specify the location of your master control plane by using the -- region in place of -- zone. In both these commands, the node location for the worker nodes is an optional parameter. And if it is not specified for the zonal cluster, then all the worker nodes will be in the cluster's primary zone. And for the regional cluster, all the worker nodes will spread across the three randomly selected zones in the same region of your cluster. Now I will use this command to create a zonal cluster. But remember that zonal clusters have a single control plane in a single zone. And depending upon your availability requirement, you can choose to distribute your worker nodes for your zonal cluster either in a single zone or in multiple zones. So let's go to Cloud Shell. Now I will create a zonal cluster by using this command. This command will create a zonal cluster with one default pool having 3 nodes by default, and both master and the worker nodes will be created in the same zone, Asia South 1A, because I did not specify the node location explicitly. There are a couple of warning messages, just ignore it for the timing. Now it will take some time to create this cluster and I will pause this video till then. So here you can see that this first Kubernetes cluster is created successfully. And this is the location of your Kubernetes cluster, Asia South 1A. This is the GKE version for your master control plane, and this is the GKE version for the worker node. Currently this cluster has 3 nodes and this cluster is in running state. You can also verify the same thing on Cloud Console as well. Like if you click on the cluster tab over here, then you can see your cluster. This cluster is created in Asia South 1A and it has 3 nodes. If you want to see the more details about this cluster, then click on the cluster name. So under this detail tab, you can see the complete information about this cluster. Like this is a zonal cluster and this is the zone for the master control plane and this is the zone for the worker nodes. If you want to see the information about nodes, then click here and then here you can see all the 3 nodes for this cluster. And all these 3 nodes are created under the default node pool. Just remember that Kubernetes cluster can have multiple node pools and each node pool can have different number and different types of nodes inside it. If you want to see the logs for this cluster, then click here and here on this page you can see the logs for this cluster. Actually, this Kubernetes cluster is very well integrated with cloud logging. So these logs are stored in cloud logging service and you can check these logs there as well. So this is how you can create a GKE managed Kubernetes cluster in GCP. And next we will learn how to deploy an application in this cluster. So in previous video, we have seen how to create a zonal cluster via command line. And our next target is to make a deployment in this cluster. But before we make some deployment in this cluster, we need to connect with this cluster. And to check the command to connect with this cluster, click over here and then click on connect. And here this is the command gcloud container clusters get credential, which you need to connect to your cluster. So just copy this command and now paste this command in Cloud Shell. This command actually fetch the endpoint and authorization information for this cluster and then generate the kubeconfig entry for this cluster. This kubeconfig entry is needed to point kubectl at a specific server to which you want to connect with. And this file is stored in .kube directory inside your home directory. Actually, there can be multiple Kubernetes clusters in one project, but we want to connect with one specific cluster at one time. So for this reason, we actually execute this command so that kubectl get the configuration to work with the required cluster. Now we will execute this command which will generate the required kubeconfig file which will be needed by kubectl command line utility to connect with our cluster. So press enter over here, click on authorize. So this is how we can generate the required kubeconfig entry which is stored in .kube directory. And you can see that directory over here. And kubectl command line utility will read this kubeconfig entry while connecting with the Kubernetes cluster. In this video, let's learn how to create a deployment in Kubernetes cluster and then how to expose that deployment via load balancer service to make that deployment accessible via internet. So first, let's create a deployment. And to create deployment via command line, you will use command kubectl create deployment and then name of the deployment and then name of the image to be deployed. So let's try this command in Cloud Shell. And here I will use this command to create the hello world app deployment. So this is the deployment name. And for this deployment, I will use this image which is stored in my container registry. And here you can see this image in my container registry. Now just press enter over here and then wait for some time for the pods to be created for this deployment. So I will pause this video for some time. Now this deployment is complete, and if you want to check the details about this deployment, then you can use command kubectl get deployment. So just execute this command. So here you can see that your first hello world app deployment is created successfully with one pod, and that one pod is also in ready state. So we have also seen how to use command kubectl get deployment, which is used to get details about your deployment in your cluster. You can also verify the same thing on Cloud Console as well. And for this, you need to go to this tab, workload. And here you can see your deployment. And here it also shows that this particular deployment is running with one pod. If you want to get the more details about your deployment, then click here on the deployment name. So on this page, you can see the CPU, memory, and the disk usage for your deployment. And from here, you can change the timeline for the data to be shown over here. Here you can see the name of your pod and the state of your pod. And from here you can see the active revision. And under this tab you can see the revision history. And under this tab you can see the events for your deployment. In case there is some issue with your deployment, then you can use these events to find the root cause. And under logs tab you can see the logs information for your deployment. And if you want to see the YAML configuration for your deployment, then click here. So this is the complete YAML file which shows the deployment configuration. And you can copy or download this configuration from these two options. Just remember that in Kubernetes cluster, you can do deployment and manage other cluster objects both via command and YAML file. But YAML based approach is definitely more preferred because it is a declarative way to make changes in your cluster. If you want to see the events for your deployment via command line, then you can use command kubectl get events. And here you can see the event for your deployment. Now coming back to Cloud Console. So here you can see that your Hello World application is deployed successfully and it is running with one pod. But still, I cannot access this application via internet. Actually, to reach to your Hello World application from internet, you need to expose this deployment via load balancer service. And to expose this deployment as service via command line, you can use this command kubectl expose deployment. Here -- type is the service type and -- port is the port on which you can access your service. So let me create a service here, and for this I will use this command. Here I have used the type of service as load balancer service because I want to expose this deployment over internet, and I will expose this deployment on port 8080. Now press enter. So here your service is created. And you can see your service on Cloud Console under this Services and Ingress tab. So here is the service that you just created, and this is the endpoint exposed by this service. So if you click over here, then you will get the Hello World response from the application which you have deployed in your Kubernetes cluster. If you want to check the details of your service via command line, then you can use command kubectl get services. Let's try this command in Cloud Shell. So I will paste this command over here and press enter. So here I can see the name of the service which I just created, and this is the load balancer type of service, and it is exposed over this particular IP and this particular port 8080, and this is the default service which always keeps running for the Kubernetes cluster. You can ignore it for the time being. We should mainly focus on the service that we just created. So this is how we can deploy an application in Kubernetes cluster and expose that application via load balancer service type to make it accessible over internet. So far we have learned how to create a Kubernetes cluster and then deploy a Hello World microservice in that cluster, and then how to make that deployment accessible over internet via load balancer service. Now let's learn some more commands to manipulate your cluster and your deployment. So first, let's check how many clusters are running in your project. And for this, you can use command gcloud container clusters list. This command will give you the list of Kubernetes clusters running in your project. Let's try this command in Cloud Shell. So I will paste this command over here and press enter. So here you can see that as of now, only one cluster, that is my first cluster, is running in my project. And this cluster has 3 nodes. Next, if you want to check the status of the pods running inside this cluster, then you can do that via command kubectl get pods. Let's try this command as well in Cloud Shell. So I will paste this command over here. So here you can see that as of now, there is only one pod running inside this cluster. And this pod is serving the traffic for your Hello World deployment. But in case there is a traffic increase for your application, then do you know how to increase the number of pods? Maybe just increase it from 1 pod to 2 pods. Actually, to increase or decrease the number of pods, you need to scale your deployment. And for this, you can use command kubectl scale deployment, then deployment name, and then the replica count. Here, value of the replica parameter determines the number of target pods. And with this command, you can both scale up or scale down the number of pods for your deployment. Let's try this command in Cloud Shell. So to increase the number of pods from one pod to two pods, here I will use this command. Just notice that here I have specified the replica count as 2. Now press enter and this command is successful. Now let's check the status of the pods. So here now you can see that there are 2 pods for your deployment. But out of these 2 pods, only one pod is in running state. The second pod is still under creation. And it will take some time to bring this pod in running state. So let's wait for some time until this new pod starts running. Now let's check the status of the pods once again. And this time you can see that both the pods are in running state. After creation of this new pod, your service will automatically load balance the traffic for your application between all the pods created for your deployment. You do not need to do anything else to load balance the traffic among the running pods for your deployment. Load balancer service that you created will take care of this for you automatically. So this way you can horizontally scale your cluster to serve more traffic. But there is a limit on maximum number of pods that you can run inside your cluster. And this limit depends upon 2 things. First is the number of nodes and second is configuration of the node itself. Actually, how many maximum number of pods a node can run depends upon the configuration of node itself. So if you want to increase the number of pods beyond the maximum limit of what current number of nodes can support, then you will have to first increase the number of nodes in your cluster. And to increase or decrease the number of nodes in your cluster, you will use command gcloud container cluster resize, where -- node pool specify the node pool which you want to resize, and -- num nodes specify the number of targeted nodes. Actually, in your Kubernetes cluster, you can create multiple node pools. So it is required to specify the name of the node pool that you want to resize in this command. Now let's try this command in Cloud Shell. So to increase the number of nodes inside my cluster, this time I will use this command. Just notice that with this command, I will resize this default node pool for this first cluster. And I will resize this first cluster to run with 4 nodes. Now press enter. Say yes over here. Now it will take some time to create new nodes and I will pause this video till then. Now cluster resizing is done. Let's check the status of the cluster. And now this cluster is running with 4 nodes. So now we have learned how to scale your cluster via manual commands. But this is not the right practice for any production environment. Ideally, in any production environment, we need a system which can auto scale itself based on the load on your application. And if you want to auto scale the number of pods for your deployment based on the CPU utilization of the pods, then you can use command kubectl auto scale deployment. When you use this command, then you specify the maximum and minimum number of the replicas for your application as well as CPU utilization target. For example, to set the maximum number of replicas to 6 and minimum to 4 with a CPU utilization target of 50%, run this command. Now press enter to configure this auto scaling. Just remember that this command does not immediately scale the deployment to 6 replicas. Number of replicas in your deployment will be increased or decreased automatically based on the CPU utilization. And after running this command, an object known as horizontal pod autoscaler is created inside your cluster. And this autoscaler increase or decrease the number of application replicas automatically based on the load. And you can check the configuration of this horizontal pod autoscaler via command kubectl get HPA. So let's check this command in Cloud Shell. I will paste this command over here and press enter. So this is the name of the horizontal pod autoscaler which is created for this deployment via this command. And these are the configuration of this horizontal pod autoscaler, like maximum number of pods, minimum number of pods, and target CPU utilization. So this is how you can configure the autoscaling for your pods. But this way autoscaling can be done up to certain limit, which depends upon the number of nodes in your cluster. If you want to autoscale beyond this limit, then you should also configure autoscaling of number of nodes for your cluster. And for this, you should use command gcloud container cluster update. With this cluster update command, you can enable the autoscaling for your cluster and you can define the minimum and the maximum number of nodes for this autoscaling. So let's try this command in Cloud Shell. So this time to configure the autoscaling of number of nodes for my cluster, I will use this command. Just notice that with this command, I will enable autoscaling for this first cluster and I will define the minimum number of nodes as 2 and maximum number of nodes as 5. Now press enter. So this autoscaling is configured properly. So this is how you can configure the scaling for both your deployment and your cluster. And also remember that whenever we have to manipulate the deployment, then we use kubectl command. But whenever we have to manipulate the cluster, then we use gcloud container clusters command. In this video, let's learn what is config map and secret in Kubernetes cluster and how to use them via command line. So basically, a config map is an API object in Kubernetes cluster that is used to store non-confidential data in key value pairs. And pods can consume this config map data either as an environment variable or command line argument or as configuration files in a volume. A config map allows you to decouple the environment specific configuration from your container images so that you can easily port your application. With config maps, you can store the different environment specific configurations in different environment specific config map. And your application does not need to have those configurations directly inside the application code. In fact, your application will read those configurations from the corresponding config map. Like if you want to deploy your application in test environment, then application will read the test environment specific configuration. And if you want to deploy the same application in production environment, then it will read the configuration from the production config map. You can use config map for the various use cases. Like if you are developing an application that needs to connect with the database, then you can store the database hostname in the config map. And if you want to create one config map in your cluster, then you can use command kubectl create config map, then the name of the configuration map, and then data source for the key value pair for this config map. Like this command here will create one config map with name test config map. And this config map will have two key value pairs with keys as key1 and key2. And corresponding values for these keys will be value 1 and value 2. So let's try this command in Cloud Shell. So I will paste this command over here and press enter and it will create my test config map. Now if you want to check the list of config maps created inside your cluster, then you can use the command kubectl get config map. Like if you run this command over here, then it will give you the list of all the config maps created inside your cluster. Here this is the config map that we just created. And this is the config map which is created by default by the cluster. And if you want to check the values stored inside a particular config map, then you will use command kubectl describe config map and then the name of the config map which you want to describe. Like if you want to describe this test config map and want to see the values inside this config map, then you need to write this command. Now press enter. And now here you can see the both keys and values that we stored inside this config map. Now, similar to config map, there is another object in Kubernetes cluster that is secret, which is used to store small amount of sensitive data, such as password, token, or a key. These secrets are very much similar to config map, but it is used to store the confidential data, whereas you use config map to store the non-secure data. Using a secret means that you do not need to include the confidential data in your application code. And like a config map, you can create the secret with the similar command kubectl create secret. Here, generic is the type of the secret that you want to create. For example, you can create a test secret with this command, which will store the value of the password. Let's try this command in Cloud Shell. Now I will paste this command over here and press enter. And this way it will create the test secret. Similar to config map, you can get the list of secrets created inside your cluster via command kubectl get secret. Let's try this command as well in Cloud Shell. I will paste this command over here and press enter. And here this is the secret that we just created. And this is the secret that is created by default by the cluster. And if you want to describe this secret, then you will use command kubectl describe secret and then the name of the secret that you want to describe. So let's try this as well in Cloud Shell. So just paste this command over here and press enter. And this time you are just able to see the keys stored inside the secret and not the values, because values are the confidential data. And this is all about how do we use config map and secret in Kubernetes cluster. In previous videos, we have learned how to manage the Kubernetes cluster and do the various operations like making a deployment or creating other cluster objects like service, config map or secret via command line. Definitely you can manage your cluster this way, but it is an imperative way to manage the things in Kubernetes cluster. In Kubernetes cluster, it is not the recommended way to manage your cluster. But in case of Kubernetes cluster, the recommended way to manage your cluster is via YAML file, because it has some advantages over using the command line. Like YAML is a structured document, and you can easily define much complex structure by using the YAML syntax as compared to command line arguments. You do not need to pass too many command line arguments to make a complex changes in your cluster. With YAML file, you can do all those configurations in a single structured YAML file. And you can add YAML file in a source control like Bitbucket or a GitHub, which makes it very easy for you to track your changes. Actually, in Kubernetes cluster always stores its current state in terms of YAML configuration in its internal database. And whenever you want to make some changes inside the cluster, then you should specify the new change in terms of YAML file, which is known as desired state. Like, just look at both these YAML files over here. In this example, these YAML files actually describe the Nginx deployment for your Kubernetes cluster. As per the current state, there are 3 replicas in this cluster. And as per the desired state, you want to increase the replica count to 4. When you apply this new desired YAML file in your cluster, then Kubernetes cluster will compare its current state with the desired state. And if these two states are not equal, then cluster will initiate the changes to achieve the desired state. So in this case, it will increase the replica count from 3 replicas to 4 replicas. And you can apply your new YAML file both via Cloud Console and via command line. Like if you click on this Hello World deployment over here, then you can see the YAML file for this deployment by clicking on this tab. And if you want to make some changes in this YAML file, then click on the edit button over here. And if you want to increase the replica count for this deployment, then go a little bit down. And now if you want to increase the replica count to 3, then make the changes directly over here. And then press the save button. Now come a little bit down. And here now you can see that now this deployment is running with 3 replicas, or you can say 3 pods. Similarly, in case you want to make changes inside your cluster via Cloud Shell, then you can apply your new YAML file via command kubectl apply -f and then name of the YAML file that you want to apply. With YAML file, you can't only make changes to your deployment, but you can manage other cluster objects as well. Like if you click on this Hello World service name, then you can see the YAML file for this service by clicking over here on this YAML tab. And you can make the changes in this YAML file in the same way by clicking on this edit button over here. So this is all about how you can manage your Kubernetes cluster via YAML file. So far we have learned how to create various resources in GKE cluster But it is also equally important for you to learn how to delete those resources as well to save the cost. There is no point in keeping a resource in cloud if it is not getting used. It might unnecessarily incur some cost for you. So to save this extra cost, you must delete those resources in cloud which are not getting used. So now let's delete the resources that we have created so far in reverse order. So first thing that we will delete is the secret. And for this you will use command kubectl delete secret and then the secret name that you want to delete. Let's go to Cloud Shell to delete the test secret that we created earlier. And to delete the test secret, I will use this command. And now press enter. And this way, this test secret will be deleted. You can verify this thing by using the kubectl get secret command. So let's press enter over here. And here you can see that in this secret list, this test secret is not there. Similar to secret, you can also delete the config map by using the command kubectl delete config map. So let's delete the test config map as well. And for this, let's go back to Cloud Shell. And to delete the test config map, I will use this command. Now press enter. And this way, test config map will be deleted. And similar to secret, you can also verify this thing by using the kubectl get config map command. So let's try this. And here you can see that test config map is not there in the result. After config map, you can delete the service via command kubectl delete service. So let's delete the hello world service as well. And to delete the hello world service, I will use this command. And now press enter. And now this hello world service is also deleted. Let's verify this thing by using the kubectl get service command. And here you can see that this hello world service is not there in the result. After deleting service, the next thing that you should delete is deployment. And for this, you can use command kubectl delete deployment. So let's delete the hello world deployment as well. And to delete the hello world deployment, I will use this command. Now press enter. And this way, hello world deployment is also deleted. Let's verify this thing by using the kubectl get deployment command. And here you can see that now there is no deployment in this cluster. After deleting the deployment, the last thing that we will delete is cluster itself. And for this, you can use command gcloud container clusters delete. And then the name of the cluster that you want to delete and the zone where this cluster is created. So let's delete the cluster as well. And to delete the first cluster, I will use this command. Now press enter. Say yes over here. And now it is deleting the cluster. So let's wait for some time. And now this cluster is also deleted. So this is how you can delete the resources that you have created inside your GKE cluster. Now in this section, we will learn about another compute offering in GCP, that is Cloud Function. Cloud Function is actually a part of function as a service offering from GCP, like Lambda function in AWS. And Google Cloud Function is a serverless execution environment for building and connecting the cloud services. In this case, no server maintenance is required from a developer. So it is very quick way to run your code inside GCP. With Cloud Function, you just write your code and rest will be handled by GCP. With this serverless approach, the whole infrastructure operations like managing the server, software update, or patching operating system, etc. are managed by Google Cloud for you. With this serverless service, just remember that the cloud function that you write should be a single purpose function. And these cloud functions are triggered in response to the events emitted from your cloud infrastructure and services, like creating an object in cloud storage bucket or receiving a message on cloud PubSub topic. And your function is triggered only when any such event actually occurs in cloud. When you deploy your cloud function in GCP, then provisioning of the resources like servers to execute your cloud function happens automatically in response to these events. This means that a function can scale from a few invocations in a day to many millions of invocations without any work from you. In case of cloud function, you will be charged only for those resources which you use for your cloud function invocation. You will be charged only as much as you use. There will be no charges if no one is using your cloud function. And you are only billed for your function's execution time, which is measured to the nearest 100 milliseconds. This way, it follows the completely pay-as-you-go model. Another interesting thing about Cloud Function is that Cloud Functions can be written using many languages like JavaScript, Python 3, Go, or Java on Google Cloud Platform. And Google always try to keep increasing the supported runtime environment for Cloud Function. So by the time you watch this video, it is quite possible that some more runtimes are also added in the supported runtime list for Cloud Function. So it is always better to refer to the Cloud Function official documentation to check the latest list of the supported runtime environment for Cloud Function. Before using Cloud Function, you should remember that since Cloud Functions are invoked in response to events, so it is good solution for event-driven computation requirement. But it is not good for use cases like hosting a web application. And each invocation of Cloud Function is independent from each other. So if you want to share some common data between the multiple parallel invocations of Cloud Function, then that shared data must be stored in some common storage like Redis distributed cache. Another important thing that you must remember before using Cloud Function is that each Cloud Function execution time is limited by timeout duration, which you can specify at function deployment time. By default, a function timeout is 1 minute, but you can extend this period up to 9 minutes. It means you cannot use Cloud Function for long-running tasks. Cloud Function cannot be used for a computation task which will take more than its maximum timeout limit, which is 9 minutes. Also remember that Cloud Function service is very much integrated with Cloud Logging and Monitoring service in Google Cloud. So you can easily monitor your Cloud Function in GCP. Now let me explain how Cloud Function works in GCP. For this, just look at this diagram. Here in this diagram, cloud services are basically the source of event. You can also call them as source event emitters or source event providers. Some of the examples of source emitters in cloud are Cloud Storage Bucket, Cloud PubSub, Stackdriver, or Cloud Data Source, and so on. Whenever an event is generated from the source emitter, then the linked cloud function is invoked for each emitted event. And different type of source emitter emit the different type of events. Like in case of Cloud Storage Bucket, new event is generated when you either create a new object in Cloud Storage Bucket or delete an object from bucket or update the metadata of an object stored in Cloud Storage Bucket. Similarly, events are triggered if either a new log entry is added to Cloud Logging or new message is published on Cloud PubSub topic. Just remember that each event generated by these event emitters has payload which represent the event data, and you can configure your cloud function to be invoked in response to such events. But keep in mind that functions are not good for the long running task. Also, these cloud functions must be stateless. In case your logic depends upon some kind of state, then that state must be stored in external data store like Redis or Memcache. Cloud function can execute in two modes. One is the foreground function and another is background function. Foreground function execution is synchronous execution, like running your function in response to HTTP event. On the other hand, background function execution are triggered asynchronously, like executing a function in response to Cloud PubSub message receive event. While using Cloud Function, just understand that Cloud Function is not a good choice for hosting the web application, and it is not a good choice for the low latency service as well. If you want to host a web application, then you should prefer to use other compute offerings like App Engine, Compute Engine VM Instance, or GKE. In this video, I will show you how to create a Cloud Function based on HTTP trigger that will allow your Cloud Function to be invoked by a HTTP endpoint. To create a Cloud Function in Google Cloud, select the Cloud Function option under the Compute Offerings. Now click on Create Function. Here, first you need to give a meaningful name to your function and then select the region where you want to create this function. So let me give a meaningful name to this function. From here, you need to select the type of trigger that you want to use for your cloud function. Cloud function supports various types of trigger like HTTP trigger, Cloud Pub Sub trigger, Cloud Storage trigger. Some trigger types are in beta state as of now, and Google is continuously increasing the trigger types that can be supported by Cloud Function. For this demo, let's select the HTTP trigger. Once you select the trigger type as HTTP trigger, then you can see one URL over here. You will use this URL to invoke your Cloud Function. Under authentication, you can control who can invoke this function. For this demo, I will allow anyone to invoke this function, but in real world, this is not an ideal choice. If you want to invoke this function via HTTPS, then you can select this checkbox as well. Now click on Save button. Under Advanced tab, here you can define the amount of memory to be allocated for this function. And here you can define the timeout for the Cloud Function invocation. If the function invocation does not get completed within this time, then function will be marked as terminated. And default timeout for this function is 60 seconds. Next, here you can define how many maximum parallel invocations can be made for this cloud function. If you leave this option as blank, then it means that there is no maximum limit and new invocation will be created for each request as per the need. Here you can select the service account that will be associated with this cloud function. Your cloud function will assume the identity of this service account. If you want to pass some environment variable for your cloud function invocation, then you can define it over here. Here you can add one or more variables, but for this demo, I will not pass any environment variable. Under Connection tab, here you can select from where this function can be invoked. You can either make this function publicly available by allowing all the traffic, or you can apply some kind of restriction for the incoming traffic for this function by selecting these two choices. For this demo, let's allow the function invocation from anywhere. From here, you can control the outgoing traffic for this cloud function. It will determine how outgoing traffic will be routed for this function. For the timing, I will leave it as default and move forward. Here on this page, you need to select the runtime for your cloud function, and you can select any runtime from this list. For this demo, I will use the Java runtime. After this, you need to select the location of the source code for your cloud function. You can either create your cloud function by using this inline editor, or you can select any other location from this list. In case of zip file, either you can upload the zip file directly from your local machine, or you can upload the zip file from cloud storage as well. In case of cloud source repository, you can select the repository, branch, and the directory which contains the source code for your cloud function. For this demo, let's use the inline editor. In this case, you can see the code directly on this page. Like this function will print the hello world message for each function invocation. Finally, once you are done with all these settings, then click on this button to deploy your function. It will take some time to deploy your function, and I will pause this video till then. Now your test function is created. Now let's see the details of this function. For this, click on the name of the function. Here on this page, you can see the metrics like how many times function is invoked in a second. Here you can check the execution time for each invocation and memory consumed per invocation and the number of active instances. These are very important metrics to notice because cloud function is priced according to how long your function runs, how many times it is invoked, and how many resources you provision for this function. Under Details tab, you can see the general information and networking setting for the cloud function. Under Source tab, you can see the source code of this cloud function. If you want to download this code as a zip file, then you can do it by clicking on this button. Under Variables tab, you can see the environment variables that you have passed to this function. Under this Trigger tab, you can see how this function can be invoked. Since this function is based on HTTP trigger, so it is showing the HTTP URL over here. Now, if you click on this URL, it will print the hello world message, and this is the expected response from this cloud function invocation. Let's go back to cloud functions once again. Here under this permission tab, you can see the roles and the members associated with this cloud function. Under this log tab, you can see the logs of this cloud function. You can also see the logs in cloud logging, or you can say Stackdriver. If you want to test your cloud function, then you can do this under this testing tab. Here you can define the payload to be passed to this cloud function and test the function by clicking on this button. So let's click on this button now. And here is the response of this cloud function invocation. So see how easy it is to create and deploy your cloud function in GCP. Now let's go back to cloud function detail page. Now if you want to delete this function, then select this function and then click on the delete button. So this is all about the cloud function that I wanted to show you in this demo. Hello friends, so far we have learned what is serverless computing and how to use cloud function as serverless compute offering. We have also covered GKE, which provides container-based runtime to run your application containers. In this video, I will talk about latest compute offering from Google Cloud, that is Cloud Run. Okay, so first let's see what is Cloud Run. Cloud Run is basically a managed compute platform that enables you to run stateless containers, which you can invoke via web request or pub/sub events. Cloud Run is a serverless offering from Google Cloud, and it abstracts away all the infrastructure management for running any container-based application. Cloud Run is built using the Knative technology, which is an open source technology. As I just said, by using Cloud Run, you can run container-based application workloads. But this you can do in GKE as well. Then question is, why do we need this Cloud Run service? If we can run containers in GKE, then what extra this Cloud Run provides? For this, just look at this pyramid. In this pyramid, GKE service sits here, and it is a container orchestration system. But Cloud Run sits at the top of this pyramid, and it is a serverless offering from Google Cloud. In case of GKE, user can select how many nodes will be there in GKE cluster and what will be the configuration of those nodes, which means user can define the number of CPU and memory allocated for each node in the cluster. So basically, as user, you have good amount of control and you will have to define some configurations while creating your GKE cluster. When you create a GKE cluster, VMs are created and you can see those VMs on the Cloud Console. And this is where Cloud Run is different from GKE. Definitely, Cloud Run also enable us to run containerized workload like GKE, but it does this job in more serverless manner. In case of Cloud Run, you just provide which container you want to run and in which region or a zone you want to run your containerized application. In case of Cloud Run, you do not provision nodes like GKE. You cannot control how many Docker containers will run for your application and what will be the configuration of the machine which will run your container. All these details are completely abstracted for user in case of Cloud Run. And that is the reason why Cloud Run sits at the top of this pyramid. Basically, Cloud Run is a serverless offering from Google Cloud that allow user to run container-based application without worrying about the provisioning of VM in cloud. Cloud Run is a super easy option to run any containerized application in Google Cloud because in case of Cloud Run, no VM provisioning is required and no YAML configuration file is needed in case of Cloud Run like GKE. To deploy your application on Cloud Run, you just need to build the Docker container image on your local machine and then upload that image to Google Cloud Container Registry and then just run your container. Cloud Run will take care of all the scaling requirement for the application. But keep in mind that to deploy application in Cloud Run, your application must be stateless so that it can be easily scaled by Cloud Run. Cloud Run allows developers just to focus on the application feature development without worrying about the hosting environment configuration. In case of GKE, you need to pay for all the VMs which are running for your GKE cluster, whether your application is serving any request or not. But in case of Cloud Run, you just pay for the resources only for the time when they are in use. If there is no traffic for your application running in Cloud Run, then you do not need to pay anything. Now let's compare Cloud Run with App Engine. App Engine flexible environment also allow us to run containerized workload. Then how it is different from Cloud Run? Though both the options looks very similar, but there is one major difference between these two options. In case of App Engine flexible environment, you can configure kind of VM that you want to use to run your application. Like you can choose how many CPU you want to use or how much memory should be allocated to VM. But on the other hand, Cloud Run is a completely serverless option where you do not have any such control in terms of defining the configuration of execution environment. You can just select the location in terms of region or a zone where you want to run your container. In case of App Engine flexible environment, at least one VM keeps running all the time, even if there is no traffic for your application. But Cloud Run shut down all the container if there is no request for your application. And because of continuously running VM, App Engine generally costs higher than Cloud Run. In case of App Engine flexible environment, you need to pay for all the running VMs, even if there is no traffic for your application. But in case of Cloud Run, you need to pay only for the duration which is required to process your request because it's a completely serverless option. Cloud Run will charge you for the used resources only for the duration when you actually use them. There is no long running compute instances in case of Cloud Run, and everything will be on demand only. So this is all about Cloud Run versus App Engine. Now let's compare Cloud Run with Cloud Function. Cloud Function and Cloud Run both provide serverless compute capability, but both have different purpose. Cloud functions are actually single purpose function, which is generally invoked either via HTTP endpoint or invoked by some event. Each execution of Cloud Function is actually a different instance of Cloud Function, and each function invocation is completely isolated from other function invocation. And keep in mind that Cloud Function invocation cannot go beyond 9 minutes. Cloud Function can be used for use cases like image processing or stream processing. Cloud Run, on the other hand, is used to run whole containerized application, which can be invoked via HTTP endpoints or PubSub events. Since Cloud Run is used to run containerized application, so you can use any language or dependency to build and run your application. And this application can handle multiple requests simultaneously. But keep in mind that your containerized application running inside Cloud Run must be stateless application. And one request can execute maximum for 15 minutes before getting timeout. And you can use Cloud Run for the applications like your backend service for web application or application that need to generate some kind of document at scheduled frequency. In this video, I will show you how to run a containerized application by using Cloud Run. And then we will access this application via HTTP endpoint. For this demo, I will be using publicly available Hello container image which is provided by Google Cloud. Now for this we need to go to Cloud Run, and for this first click over here and then select the Cloud Run option from here. In case we have to deploy a containerized application in Kubernetes, then first we have to create a cluster and then do the deployment. But in case of Cloud Run, it is much easier because in this case we do not need to create any cluster explicitly, as Cloud Run is a serverless service. In case of Cloud Run, runtime environment for the application will be automatically created and managed by the Cloud Run. To run any application in Cloud Run, we need to create a service. And if we are creating the service for the first time, then Cloud Run API will automatically be enabled for the selected project. Now click on Create Service button. Just notice that it is enabling the Cloud Run API for the project. Enabling of the Cloud Run API in a project is just one-time activity that needs to be done while creating the first Cloud Run service in that project. In Cloud Run, a service is an abstraction that provides the unique endpoint for your application, and it scales automatically to handle the incoming request. Now, to create a service, first we need to give the name to this service, and be very careful while giving this name because this name cannot be changed later on. So let me give the name to this service first. Here you need to select the location where you want to run your application. Now click on Next. In this step, we need to provide a container image from Google Container Registry that we want to run. Here you can either provide your own container image or you can select already existing public image. For this demo, I will use publicly available Hello container image which is provided by Google Cloud. And for this, first click over here and then select this Hello image. Now click on Select button. This configuration will create a revision under your service, and one service can have multiple revisions, and configuration of each revision is immutable. If you want to do some advanced settings for this configuration, then click over here. And here you can do the settings related to container, variable, connections, and security. Like under container, you can define the container port, or you can define the request timeout or maximum request per container. You can also define the memory and the CPU allocated for each container. For this demo, I will keep it as it is. Now click on Next button. In this step, we can configure how this service can be invoked. Service in Cloud Run can either be triggered via HTTP endpoint or it can be triggered in response to an event. For this demo, I will use HTTP endpoint option because I want to invoke this service via HTTP call from my local machine. So for this service, I will allow all the incoming traffic so that it is reachable from internet. You can choose other options as well in case you do not want to expose this service to the internet world. And I will not use any authentication for this demo, so I will choose this option. This option will allow anyone to invoke the HTTP endpoint exposed by this service. Now to create this service, click on the Create button. It will take few seconds to create this service, so I will pause this video till then. So this service is up and running now. So you can see that running a container is much easier by using Cloud Run as compared to using the Kubernetes cluster. Within few seconds, you can run your containerized application by using Cloud Run. Just observe that this configuration has created one revision under this service, and you can have multiple revisions in a single service in the same way. This revision concept is similar to the version concept in App Engine, and this is the URL of this service. Now let's click on this URL. So here you can see that application is running absolutely fine, and it is providing the information like name of the revision, name of the service, location where this service is running, or project in which this service is running. If you want to see more information about this service, then you can check these tabs. Like if you want to see the logs for this service, then click on this tab and it will show you the logs for this service. These logs are stored in Cloud Logging service. So this is all what I wanted to show you as part of this demo. In previous video, we learned about how to run a containerized application by creating a service in Cloud Run via Cloud Console. In this video, let's look at some of the commands as well that you should know related to Cloud Run. So in this list, first we will deploy a containerized application in Cloud Run via command line. And for this, you can use command gcloud run deploy, then the name of the service that you want to create, and then the container image that you want to use for this deployment. Just notice that syntax of this command is very much similar to the gcloud command that you use with compute engine. In case of compute engine, it was gcloud compute, and in case of cloud run, it is gcloud run. So let's try this command in Cloud Shell to deploy the same publicly available Hello World container image in Cloud Run once again. But this time we will use gcloud command. So to deploy the same Hello World container image in Cloud Run via gcloud command, I will use this command. Now press enter. Here it is asking, do you want to allow an authenticated user to make request to this service? For the timing, say yes over here to allow anyone to make request for this service. I am allowing this just for the demo purpose only, but ideally you should not allow this in real world use cases. So say yes over here and press enter. Now it will take some time to deploy this service. So let's wait until it is complete. So this deployment is complete now, and here you can see the name of the service which you deployed, and this is the URL of the service by which you can access this particular service. So let's click on this URL, and here you can see that your application is running successfully. You can also see this service in Cloud Console, like if you click over here and then go to Cloud Run option, then here also you can see the service that you just created. Now if you click on the name of this particular service, then under this revision tab, you can see all the revisions of this particular service. And currently there is only one revision which is serving the 100% traffic for this service. You can also check this revision list via command line, and for this you will use command gcloud run revisions list and then the name of the service for which you want to check the revisions. So let's try this command as well in Cloud Shell. And to check the list of revisions for the service that we just created, I will use this command. Now press enter. So this way you can see the list of revisions for a particular service. Actually, every time you deploy your service, a new revision will be created for your service. And just remember that with a new revision, you can use either the same container image or you can use the other container image as well. So let me deploy this service once again. Now this deployment is complete, and this time let's again check the list of revision. And this time you can see that now there are 2 revisions for this particular service because I have done 2 deployment for this service so far. And if you check these revisions on Cloud Console, then you will observe that this particular second revision that we just deployed is actually serving the 100% traffic. But in case you want to split your traffic between both the revision, then click on this manage traffic button. And here you can specify how much percentage of traffic will be served by each revision. So this is all about how you can check the list of revision for a particular service. But you can also create multiple services as well in Cloud Run. And if you want to see the list of Cloud Run services running inside your project, then you will use command gcloud run services list. So I will paste this command over here, and this is how you can see the list of Cloud Run services running inside your project. So currently it is showing that there is only one service as of now, and this is the name of the service which is currently running, and this is the URL of this particular service. In the same way, if you want to delete a particular service, then you will use command gcloud run services delete and then the name of the service that you want to delete. So let's try this command as well in Cloud Shell. So to delete the service that we just created in this video, I will use this command. Now press enter. Say yes over here So this way you can delete your service as well. And this is all about what I wanted to show you in this video. In this video, we will learn about some basic networking concept. Here, I will explain what is public IP address, what is private IP address, and what is CIDR range. Actually, IP addresses are classified into two types. One is private IP address and second is public IP address. Public IP address of a system is used to communicate outside the network, and public IP address uniquely identify the device in the internet world. On the other hand, private IP address is used inside one local network to communicate within same network only. We cannot communicate with any other network or internet via private IP address. This diagram here represents how do we set up the local network in general and how devices within this local network can talk to the internet. Here in this example, this dotted line actually represents the local network and all the devices in this local network are connected to this router. This router has assigned the private IP addresses to these devices, and all these devices can communicate with each other via these private IP addresses. Private IP address assigned to any device uniquely identify the device within this local network only. It does not identify your device outside this local network. Whenever any of these devices needs to talk to the internet, then request must be routed via router. It is like if you want to talk to google.com via any of these devices, then device first talks to the router and then router talks to the internet on behalf of the device. Since router talks to the internet, so unique public IP address is assigned to both the routers. Similarly, response from the google.com first comes back to the router and then router forward the same response to the corresponding device from which it received the request. Here, this router is connected to both local network via this private IP address and to internet via this public IP address. Private IP address of any device is never exposed to internet, or in fact, private IP address remains internal to its local network only. So, these private IP addresses are also known as internal IP address. In such local network, any device inside the local network can talk to the peer device via the internal IP address, but any device outside this local network cannot talk to these devices via the private IP address assigned to these devices. These private IP addresses are reusable, and most routers create a private network by starting IP address with 192.168. It means other local network can also use the same private IP address space to uniquely identify the device in their respective network. So here both network 1 and network 2 use the same private IP addresses for the devices in their respective network, but both are different private network altogether. If any device needs to make a call to outside its private network or to internet, then that device needs a public IP address. Like here, if your laptop is assigned a public IP address, then your laptop can directly make a call to Google Cloud API, which is exposed over internet. But this will make your laptop vulnerable to hacking from an unwanted attacker because now your laptop is reachable over internet via the public IP address which is assigned to this laptop. But if you use router in between to communicate over internet, then your router provides a layer of security for your devices in your local network. In this case, only device that is connected to internet is the router. All other devices in your private network are not reachable from internet, and all good router comes with the default firewall configuration to block the unwanted inbound traffic. If you are developing a three-tier web application, then only load balancer has the public IP address, and all other servers in your application are assigned private IP address just for the same security reason. If you do not use load balancer, then the web server is assigned a public IP address, and all other internal application server and database servers just have the private IP address only. IP addresses that we have most commonly used are like this, and these are IPv4 IP addresses. It is made up of 4 bytes where each byte is separated by a dot. and each byte is known as octet. Since these IP addresses are of 4 bytes only, so there can be maximum 2 raised to power 32 IP addresses only. Out of this finite IP address range, some IP ranges have been assigned to be used as private IP address only, like any IP address range which starts with 192.168 is considered as private IP address which belongs to class C IP address range. Similarly, class A and class B private IP address range is also shown over here. Here, class A private IP address range starts with 10.0.0.0 and class B private IP address range starts with 172.16.0.0. Each IP address has two components. First part of the IP address is used to identify the network to which IP address belongs to. And second part that comes after this is used to specify a specific host within that network. Here we have specified the IP address range in terms of starting IP address and the last IP address in each IP address class range. But generally we do not define the IP address range like this. In fact, we prefer to use this kind of seeder notation to define the IP address range. Here, this column represents the subnet mask for each IP address class range. Subnet mask is used to identify the network part of the IP address, and I will explain how to use this to find the network address in few minutes. In this class-based IP address range scheme, the number of bits that represent the network are fixed. Like in this class A private IP address range, first 8 bits represent the network and remaining 24 bits are used to determine the host address in the network. Similarly, in this class B private IP address range, first 12 bits represent the network and remaining 20 bits are used to determine the host address in the network. And in class C IP address range, first 16 bits represent the network and remaining 16 bits are used to determine the host address in the network. This class-based IP addressing scheme is not efficient because fixed number of bits are used to determine the network. This way, we cannot have a customized network in which we can say that network is identified by the first 20 bits of the IP address. To overcome this issue of fixed number of network bits, we prefer to use seeder notation based IP addressing scheme. Here, seeder means classless inter-domain routing. Seeder notation based IP addressing scheme allows us to specify any number of network bits. In case of seeder notation, we specify the IP address range in terms of starting IP address and the number of network bits in your IP address range as shown over here. Here, this suffix after the slash represents the subnet mask, which determines the number of bits in the network. If we use this seeder notation based addressing scheme, then we are not bound to use fixed number of bits to represent the network like in case of class-based IP addressing scheme. In such seeder convention, we can use any number of bits to represent the network. Let me explain how to represent a IP address in this seeder range with the help of an example. This is a IP address which belongs to this seeder range. If we try to represent this IP address in binary format, then it will be written like this. Here, first 20 bits which are represented in blue color actually represent your network and value of these bits will remain fixed for this network. Remaining bits in red color are actually used to determine the device address in your network. Since there are 32 bits in an IP address and out of this 20 bits are used to determine the network in this example, so it means you are left with the remaining 12 bits for the host address in your network with this IP addressing scheme. Since we can use only last 12 bits of the IP address that can be assigned to any device in this network, so you can have maximum 2 raised to power 12 equal to 4096 devices in your host network. Now let's see how to determine the network address for a given IP address based on the seeder notation. It is very simple. You can determine the network address just by doing the AND operation between the subnet mask and the IP address as shown over here in this example. In this example, as per the seeder notation, /20 means first 20 bits will determine the network address. So you can represent the subnet mask for this IP address like this. In this subnet mask, all the bits which represent the network are set to 1 and all the host bits are set to 0. In this subnet mask, first 20 bits are set to 1 and last 12 bits are set to 0. And it shows the binary representation of the IP address, and this is the result of AND operation between these two. If we do the AND operation, then we get the network address in this binary format, which result in this IP address, and this is the octet representation of the network address that determines your network. Now let's try to understand how routing works with such IP addressing scheme. Routing of any data packet is very much similar to how your physical letter is sent via postal or mailing service. If we have to send some physical letter to some recipient, then we need to specify the address of the recipient on the letter. This address is organized in hierarchical manner in terms of country, state, street, and finally the house number. And based on this addressing scheme, letter is first sent to correct country, then to correct state, then to correct street, and then finally delivered at the recipient's doorstep based on his house number. IP addresses also have the similar hierarchy, and you can find the country and the organization to which a particular IP address belongs to. And if your router has to send some data packets to google.com, then it also follows the similar routing hops before it reaches to google.com server. In this chapter, we will learn about networking in GCP, what is a virtual private cloud, and what are the various components in VPC, and how networking in Google Cloud is different from other cloud providers. So first question that comes into everyone's mind is, what is a VPC networking in cloud? Actually, you can think of a VPC network similar to the physical network in your on-premise data center, except that it is virtualized within the cloud. The way you create subnet in your on-premise data center, you can also create subnet and other resources in a cloud in a similar way. VPC in cloud provide the networking capabilities to your resources like Compute Engine VM instance, Kubernetes cluster, App Engine, and so on. You also use VPC network to connect your cloud resources with your on-premise resources. If you look at this diagram, you will observe that VPC in Google Cloud is different from other cloud providers like AWS. VPC in Google Cloud is global in nature, while VPC in AWS used to be regional in nature. It means in AWS, if two compute VM instances are in different region, then they must be in different VPC network. But in case of Google Cloud, your VPC span across all the regions, and you can create resources inside any region in your VPC because VPC in Google Cloud is global in nature. In this diagram, one VPC network is created in your project which span across all the three regions. And within these three regions, subnets are created and you can deploy the resources in any zone in any of these subnets. If you are not from networking background, then some of these terms might look strange to you. But do not worry about this. I will explain these concepts to you in this chapter. Now let's take a look at some of the important features of a VPC in Google Cloud that you must understand, like how you structure your network, which means how to define subnet and assign IP to them, and how the IP address is assigned to a resource in those subnet. How do you ensure security in VPC network? How resources in your subnet talk to other resources in the same subnet, and how resources in your subnet talk to other resources outside your VPC. And these outside resources can either be in some other VPC or it could be in your on-premise network or some other network as well. I will discuss all these things in detail in this chapter, but before this, let me give you some overview of these concepts. Each VPC that you create reside in a single project, and one project can have multiple VPC defined inside it. And you can create up to 5 VPC network per project, including the default network. Multiple network within a single project can provide multi-tenancy, IP overlap, or isolation within the project itself. Resources created in one VPC are isolated from other VPC. It means resources in one VPC cannot be shared by other VPC network. Whenever you create a new project, a default VPC is created by Google Cloud in that project. And this is the same default network where we created all the VM instances so far. We do not create resources like VM instances directly in a VPC. In fact, inside each VPC, subnets are created, and we create resources inside those subnets. A subnet or subnetwork is a smaller network inside a large network, and this subnetting makes the network routing much more efficient. Subnets in GCP are regional resources, and each subnet is assigned an unique range of IP address. Whenever you create a resource in any subnet, that resource is assigned an internal IP address from the subnet IP range, and resources inside your VPC can communicate with each other via these internal IP addresses. You can also assign an external IP address to a resource which you want to expose to internet. Just remember that in GCP, IP address range is not specified at VPC level. It is specified at subnet level. If we talk about security in VPC, then I will say that firewall rule defined in your VPC is the first level of defense. Firewall rule in VPC control both ingress and egress traffic in your VPC. Using firewall rule, you can control from where resources inside your VPC can be reachable. Similarly, you can also control traffic going out of your VPC. In VPC, you can define both allowed and denied firewall rules. As I just explained, resources in one VPC are isolated from other VPC. It means resources in one VPC cannot be shared by other VPC. But sometimes there can be a case where you need to share some resources between multiple VPC. In that case, an organization can create a shared VPC in a common host project, and resources inside this shared VPC can be shared by other VPC network. Shared VPC allow an organization to connect resources from multiple projects to a common VPC network so that they can communicate with each other securely and efficiently using the internal IP address from that network. In addition to shared VPC, there are other options as well to connect your VPC with other VPC or other network as well. Like VPC network can be connected to other VPC network in different project or organization by using the VPC network peering. Also notice that VPC network can be securely connected in a hybrid environment by using Cloud VPN or Cloud Interconnect. You can monitor your VPC network by using the flow logs, and you can view those flow logs in cloud logging. And you can export those logs to any destination that cloud logging export supports. Similarly, you can also enable logging at firewall rule level to audit, verify, and analyze the effect of your firewall rules. Now let's start learning about all the VPC networking concepts in GCP, starting with subnet. A VPC in Google Cloud is spread across all the regions, and each VPC network consists of one or more useful IP range partitions called subnet, and each subnet is associated with a single region. Like here in this diagram, we created this network which span across three regions, region 1, region 2, and region 3. But we do not create a VM or any other resource directly in this VPC. But to manage this VPC network, we prefer to create smaller networks in this big network. And these smaller networks are known as subnets. So a subnet or subnetwork is a smaller network inside a large network, and this subnetting makes the network routing much more efficient. Also notice that VPC networks do not have any IP address range, but IP address range is defined at the subnet level only. These VPC subnet work similar to the physical networking that we set up in our own data center, and subnets span across single region only. One subnet cannot go beyond a single region. Each subnet has its own route to control traffic for that subnet, and you can consider it like an isolated network in your VPC. You can create different subnet for the different environment, like subnet for the development environment and subnet for the production environment. And you can control traffic for each subnet independently. As you can see in this diagram, we have created 6 subnets in this VPC network from subnet 1 to subnet 6, and IP address range is assigned to each subnet. And whenever any resource is created inside any subnet, then that resource is assigned an internal IP address from the IP address range of the containing subnet. Also notice that more than one subnet can be created in the same region, like two subnets are created for each region in this diagram. As you can see here, these two subnets are created in region 1, these two subnets are created in region 2, and these two subnets are created in region 3. But each subnet is bound to a single region only. Since subnets are created at the regional level, so all the resources in the same subnet must reside in the same region, and the address range of the different subnets are not allowed to overlap. Each subnet must have the unique IP address range in a VPC. Notice that in this diagram, all the 6 subnets have been assigned an IP address range which is unique and does not overlap with other subnets in the same VPC. But two different subnets in the different VPC can use the same overlapping IP address range, as long as you do not want to connect those VPC with each other. It is important to know that you can create resource in any zone within a subnet, and resource can span across multiple zones in a same region. So, if you want to achieve high availability in same region, you should create resources in multiple zones in a single subnet. Like in this diagram, in first top 3 subnet from subnet 1 to subnet 3, VM instances are created in different zones in the same subnet to achieve the high availability. Just keep one thing in your mind that a VPC network must have at least one subnet before you can use it. Also remember that whenever an auto mode VPC network is created, one subnet for each region is automatically created inside that VPC network, and these automatically created subnet use a set of predefined IP address ranges. Let me show this to you on Cloud Console. So this is the default auto mode VPC which is created by GCP inside this project at the time of project creation. Here you can see that subnets are created for all the regions in your cloud, and there are 24 subnets in total as of now in this default VPC. And each subnet is allocated an IP address range from the predefined IP address range. In addition to this default auto mode VPC, you can also create a custom mode VPC network in your project. But when a custom mode VPC network is created, no subnets are automatically created for you. Custom VPC network provides you with complete control over its subnet and the IP ranges. You can decide which subnets to create in a region and which IP address range to associate with those subnets. In addition to the primary IP address ranges assigned to the subnet, you can also add secondary IP address ranges to your subnet, and each primary or the secondary IP address range for all the subnet in a VPC network must be unique and non-overlapping. And IP address ranges assigned to the subnet in your VPC need not to be contiguous. Now, before we move further in this section to learn more about VPC, let me show you the default VPC created in this project. To look at the default VPC in this project, go to networking section and click on the VPC network option over here. Here you can see the default network in this project, and in fact this is the only network created so far in this project because we have not created any custom network so far. Whenever you create a new project in GCP, a default VPC network is also created in that project for you by Google, and we call it as the default VPC because it is not created by user explicitly. This default VPC network is created by Google at the time of project creation for you. As we learn more, I will also show you how to create your own custom network in your project. For the time being, let's try to understand some of the components of this default VPC network and how does this default VPC network manages the networking for you in Google Cloud. As you can see in this default network, subnets are created for all the regions available in GCP, and each subnet is assigned an IP address range from the predefined IP address range. So there are total 24 subnets in this default network as of now, and flow log is disabled for all of them. You can check more detail of this default VPC by clicking on the name of the VPC over here. Here you can see the name and the description for this VPC, and also observe that this VPC is the auto mode VPC. Here on this page, you can remove an existing subnet by selecting it and then clicking on the delete icon over here. You can also check flow logs for the subnet by clicking on the view flow log option. If you click on this option, it will take you to the cloud logging, and here you can see the flow logs for the subnet. As of now, no flow log will appear over here because flow logs are disabled for all the subnets in the default VPC. If you want to add new subnet for your VPC, you can do that by clicking on the add new subnet button over here. I will not add any subnet as of now. Under Firewall tab, you can check the firewall rules created for this VPC. In current firewall rules, we are allowing HTTP, ICMP, RDP, and SSH ingress traffic from all the IP address. So if some VM instance is created in this VPC, you can reach to that VM instance by any of these protocols. Open port for all these protocols is also shown over here. There is one default allow internal rule which allows the communication between VMs inside this VPC using private IP addresses. All IP address in this VPC lies in this range. Under Routes tab, you can see the routes defined for each subnet created in this VPC. There is one special route that is the default route to the internet. This route allows all VMs inside this network to access internet. I will explain all these terms in detail as we move further in this section. Now let's talk about different types of VPC networks in GCP. First type is the default network, which you have already seen in previous demo. Default VPC is the first network created by Google in your project at the time of project creation. Let's do a quick recap of the features of default network. In case of default network, one subnet per region is created by Google so that you can create resource in any zone in any region in your subnet, and each subnet is assigned a primary IP address range from the predefined network IP range. Default VPC is a auto mode VPC network. In default VPC, default subnet routes are created to allow traffic to flow from one subnet to other subnet. Default firewall rules are created for the default VPC to allow all ingress traffic. So all resources inside this VPC can communicate with each other using the internal IP addresses. Default firewall rules are also created to allow HTTP, ICMP, RDP, and SSH ingress traffic from any source IP. Default VPC also comes with an internet gateway which allows resources like VM created in this default VPC to access internet via default route. We have already seen that flow logs are disabled for all the subnets in the default VPC. Since GCP had created default network for our project along with the default firewall rules and routes in it, so we did not face any issue in connecting to our VM, or you can say Kubernetes cluster node, while doing any previous demo so far. This default network comes with very sensible defaults which makes things easy for us, especially if you are learning GCP for the first time. But in production environment, using default network is not the right choice. You must create your own additional VPC for production environment with your own defined firewall rules and routes in it to allow restricted access within your network. Next type of VPC is custom VPC. Custom VPC gives you complete flexibility in terms of creating your own subnet, firewall rules, routes, etc. To create your custom VPC, click over here. While creating your custom VPC, you can select the subnet creation mode. You can select either custom creation mode or automatic creation mode. Auto mode network is similar to the default VPC. You can think of auto mode as a template of subnets, firewall rules, and subnet routes, etc. that needs to be created inside your VPC. Default VPC is also a auto mode VPC. If you create your custom VPC using auto mode, then default subnets will be created in all the regions similar to default VPC. Here you can also select the firewall rules that needs to be created for this VPC. Now let me show you how to create a auto mode custom VPC in Google Cloud. Creating a custom VPC with auto mode is very simple. You just define the name and description of your VPC over here. Then select the creation mode as automatic. If you select the auto mode over here, then you can see the details of regions and IP address that will be allocated to each subnet in that region. Here you can select firewall rules that needs to be created for this VPC. These firewall rules are same as what you have seen in the default VPC. I will select all the firewall rules for this VPC. Just notice one special rule over here that allows all ingress traffic from any internal IP address range 10.128.0.0/9. All IP ranges assigned to any subnet created by auto mode will be from this predefined IP address range. If you want to add new subnet to your VPC, then IP range for that subnet must be outside this particular predefined IP address range. Finally, click on the Create button to create your VPC, and it will take some time to create subnets in your VPC. I will pause video till then. Your VPC is created now. Subnet creation is still taking some time. Now subnets are also created in each region, and you can also see the IP address range assigned to each subnet. Here you can see the firewall rules created for your VPC. You can also see the routes for your VPC over here. So this is how you can create custom VPC using auto mode in Google Cloud. Now let's talk about another option to create custom VPC using custom mode. Custom mode is quite different from auto mode, and custom mode gives you complete flexibility in terms of adding subnets to your VPC. You choose your own region and IP address range while creating subnet with the custom mode VPC. In fact, in production environment, we prefer to use custom mode for creating custom VPC. You can convert auto mode VPC to custom mode VPC, but reverse is not possible. This is just a one-way conversion. Custom mode VPC network cannot be changed to auto mode VPC network. If you look at your auto mode VPC, then here you will have an option to convert this VPC into custom mode VPC. If you click on this option, then you will get a warning message. This warning message actually reminds you that this is just a one-way path to convert your auto mode VPC to custom VPC. I will not convert this into custom mode as of now. Now let's try to add a custom mode VPC. To create custom mode VPC, click on Create VPC Network button. Here you need to give a name and description for your custom VPC, and this time select the custom mode to create your custom VPC. Just see that there are no subnets defined by the custom mode. So this time we will add our own subnet over here. To add subnet, click on Add Subnet button. Now give a name to your subnet over here. Then from here you need to choose the region for your subnet. Then here you need to give a IP address range for your subnet. While adding a subnet in your custom VPC, you can define region and the IP address range for your subnet, but make sure that this IP range does not conflict with the predefined IP address range used by auto mode. This IP range is the primary IP range for your subnet, and if you create some resource in this subnet like VM or internal load balancer, then they will get the IP address from this primary IP address range. You can optionally add secondary IP address ranges to your subnet, which are used by the alias IP ranges. These alias IP ranges is used by GKE while using container load balancing in your GKE cluster. In case of container load balancer, you need to create your cluster in VPC native mode, and in this case, nodes of your cluster get the IP address from the alias IP range of the subnet. When alias IP ranges are configured, Google Cloud automatically installs VPC network routes for both primary and alias IP ranges for the subnet of the primary network interface. Your container orchestrator does not need to specify VPC network connectivity for these routes. I will not add any alias IP address range as of now. Here, you can also enable private Google access for your subnet. This option is used when a compute engine VM instance does not have an external IP address. When a compute engine VM does not have an external IP address assigned to its network interface, it can only send packets to other internal IP address destinations only. But you can allow these VMs to connect to set of external address used by the Google API and services by enabling option of private Google access on the subnet used by the VM. So this way, if you enable this private Google access option for your subnet, VM inside this subnet can access Google API and services without external IP address assigned to them. I will not enable private Google access for this demo. Here, you can choose to enable or disable flow logs for your subnet inside your VPC. Flow log helps you in monitoring traffic inside your VPC, and flow logs are stored in cloud logging services, and these are charged as well as per the storage occupied in cloud logging service. I will not add flow logs for this demo, and click on Done to add subnet to your VPC. Now click on Create button to create your VPC with this subnet. It will take some time to create this VPC. I will pause this video till then. Now this custom mode VPC is created, and you can see your subnet over here, and you can also see the IP address range assigned to your custom subnet. Now let's check the details of this custom mode VPC. You can see your subnet over here. Now let's check the firewall rules. See, there is no firewall rule in this custom mode VPC. If you want to add some firewall rule for your custom VPC, then you have to add it by clicking on this button. Now let's check the route. So some default routes are created for this VPC. This default route allows internet access for the VM inside your VPC, and this route allows the internal communication between VM inside your VPC using private IP address. So this is how you can create a custom mode VPC in Google Cloud. In this video, let's try to understand how IP addresses are assigned to the VMs inside your VPC, and how do these VMs communicate with each other in same VPC, and how do they communicate with the other VMs in the outside world. Whenever subnet is created in your VPC, then an unique and non-overlapping primary IP address range is assigned to that subnet. It is very important to understand that IP address range assigned to each subnet is unique and non-overlapping. It means if an IP address range is assigned to one subnet in one VPC, then the same IP address range cannot be assigned to other subnet in same VPC. But keep in mind that same IP address range can be reused in other VPC. If this VPC is an auto mode VPC network, then this IP address range is assigned to this subnet by GCP. Else, you have to assign this IP address range to subnet at the time of subnet creation. When you create a resource like Compute Engine VM instance in this subnet, then that VM instance is allocated an IP address from the primary IP address range of the subnet. Like this IP address range is assigned to this subnet 1. So any VM created inside this subnet 1 will have the IP address from this IP range only. So both these VMs will have IP address from this IP range only. Similarly, IP address will be assigned to other VMs as well inside all the subnet in this VPC. IP address assigned to your VM like this is the internal IP address of the VM. In addition to internal IP address, you can also assign external IP address to your VM, and assigning external IP address is optional. Also remember that Compute Engine VM instance in a VPC can have multiple network interfaces associated with them, and these interfaces can be assigned different IP addresses. You can also assign one or more secondary IP address to a VM from the secondary IP address range of the subnet. The internal IP address is used to communicate between the instances in the same network. These VM instances can be either in the same region or they can be in different region as well, but they must be in same VPC. On the other hand, external IP address is used to communicate with the instances in other network or with the internet. Like if you host a web application inside a VM but do not assign an external IP address to your VM, then you will not be able to reach to your application. To make your application accessible via internet, you need to assign an external IP address to your VM. If you look at this diagram, then any communication between the VM in the same VPC network, be it in the same region or be it in the different region, is shown in black color line. And all this communication happens via internal IP address. On the other hand, communication between the VM inside your VPC and the internet is shown in red color line. And all this communication happens using the external IP address via internet gateway. Also notice that any communication that happens across two different networks, or you can say two different VPC, also happens via external IP address. And any communication that happens via external IP address gets routed via internet even if both networks are available in GCP. Like here, communication between the same network is happening via internal IP address, but the communication between two different VPC is happening via external IP address because internal IP address of any VM is not visible outside its VPC network. Another important point that you must remember is that external IP address assigned to your VM can be both ephemeral or static. An ephemeral IP address remains attached to a VM instance only until the VM is stopped or restarted or instance is terminated. If an instance is stopped, then any ephemeral IP address assigned to the instance is released and it can be reused by other projects. When a stopped instance is started again, a new ephemeral IP address is assigned to that instance. Also notice that VM is not aware of any external IP address attached to that VM instance. It is part of metadata and it is stored in metadata server. You can get this information by querying the metadata server. We have already seen that each VPC has its own set of firewall rules defined inside it. But what are these firewall rules? Actually, these firewall rules are the first line of defense against the attacks, viruses, and malware, and it helps in creating a secure network. It controls both traffic coming into your VPC and traffic going out of your VPC. Like if any VM outside your VPC network want to make some request to VM inside your VPC network, then this firewall layer can allow or deny this request based on the firewall rules configuration. In the same way, it also controls the traffic which is originated from the VM inside your network. By using these firewall rules, you not only control the traffic between other network and your VPC, but you can also control the traffic between the individual VM instances inside your VPC as well. Just keep in mind that firewall rules are defined at the VPC level and not at the subnet level. And each VPC has its own distributed firewall. You can define both allowed and the deny rule in your VPC, which allows or denies the traffic into and out of the network and between the VM instances. While creating a firewall rule, you not only define what traffic is allowed or denied, but you can also select the VMs inside your VPC to which this firewall rule can be applied. And there are three ways by which you can select the target VMs. You can either apply your firewall rule to all the VMs inside your VPC, or you can apply the same rule on the few selected VMs. In this diagram, there are four VMs, and out of this, two represent the web server which are running with service account 1. In the same way, this represents the app server which is running with service account 2. And this is the database server which is running with service account 3. Here it is shown in red color, which represent that firewall rule is created for all the VMs. If you do not want to apply your firewall rule for all the VMs inside your VPC, then you can also select your target VMs based on the network tag as well. In this case, your firewall rule will be applied to all the VMs which are associated with a particular network tag. Network tags are user-defined string tags that you can attach to resources like VM inside your VPC. And these network tags helps in organizing the firewall policies. For example, you can use a tag called as web, and you can attach this tag with all the web server VMs running inside your VPC. Once you attach this tag with your VM, you can use this tag to define the firewall policy for all those web servers associated with this tag. This way, you can open HTTP or HTTPS traffic for all such web servers using single firewall rule. Like here, this time firewall rule is applied to the first two VMs having the network tag value as web, which represent your web server. It is considered to be a good practice to select the firewall rule target based on the tags. Another way to select the target VMs for a firewall rule is by service account. In this case, your firewall rule will be applied to all the VMs which are running with a particular service account. Like here, this time firewall rule is applied to the third VM which is running with service account SA2. Also remember that by using the firewall rules, you can just control the IPv4 traffic. And these firewall rules are not shareable among multiple VPC networks. Rules created for one VPC are not applicable to other VPC. Also keep in mind that these firewall rules are stateful in nature. It means if you allow some incoming request traffic from one source IP, then its corresponding response traffic is also allowed. Response traffic cannot be denied. Like if this laptop is allowed to make a request to this VM inside your VPC, then the corresponding response traffic for the request will always be allowed, even though outgoing traffic originated from this VM is not allowed by another firewall rule. Whenever any firewall rule is created, then a priority is also defined for that firewall rule, and firewall rules are evaluated in terms of priority, where 0 is the highest priority and 65535 is the lowest possible priority. And for any new rule, 1000 is the default priority order. Every VPC network has two implied firewall rules. One implied rule allows all the egress traffic and other denies all ingress traffic. And both these implied rules have the lowest priority. These implied rules are not visible on Cloud Console and you cannot delete the implied rules. But you can override them by creating your own custom firewall rules with higher priority. So if you create a new VM inside your new custom VPC, then you cannot reach to that VM until you explicitly define the firewall rule to allow incoming traffic for that VM. In addition to implied rules, default VPC also comes with these predefined rules as well. Here, this default allow internal rule allows all kind of traffic on all the ports between the VMs inside your VPC. Default allow SSH rule allows SSH traffic on port 22 from any source. And it is this firewall rule because of which we were able to access any VM in the default network via SSH so far. Default allow RDP rule allows to establish Microsoft remote desktop connection from any source on port 3389. And last, default allow ICMP rule allow to use tools like ping utility from any source. Now let's see what all things you need to provide to create a firewall rule. Whenever you need to define a firewall rule in GCP, then you need to define these things. First, you must define what traffic you want to control. Like, do you want to create a firewall rule for the ingress traffic, or you want to create a firewall rule for the egress traffic? Here, ingress traffic means any traffic coming inside your VPC, and egress traffic means traffic leaving your VPC. After this, you need to decide whether you want to allow the traffic or you want to deny the traffic. Then you need to select the target for your firewall rule. Here, the target specifies to which VMs inside your VPC this rule is applicable to. Here, you can either apply the firewall rule to all the VMs inside your VPC, or you can choose the target VM based on the network tags associated with your VMs, or you can select the VMs based on the service account. When you select the service account option, then you need to provide a service account for your firewall rule. And in this case, this rule will be applicable to all the VMs associated with the selected service account. In the same way, if you select the tag option to define the target, then the firewall rule will be applicable to all the VMs associated with the specified network tag. After selecting the target, you need to choose either the source or the destination for your firewall rule, which depends upon the direction of the traffic for the firewall rule. Like, if you want to create a firewall rule for the ingress traffic, then you need to define the source of the incoming traffic. And you can choose the source based on either the IP address range by using the CEDAR notation, or you can use the network tags, or you can use the service account in the same way as you selected the target for your firewall rule. If you want to create a firewall rule for the egress traffic, then you need to define the destination of the outgoing traffic. And you can define your destination based on the IP address range by using the CEDAR notation. After defining all these things, you need to select the protocol and the port for which rule is applicable. And last but very important thing that you must define is the priority order of the firewall rule, which will determine in which order your rule will be evaluated. And first matching rule will be used to decide if the traffic is allowed or denied. Keep in mind that this priority order range from 0 to 65535, and lower priority number means higher priority. It means rule with 100 priority is evaluated before the rule with 200 priority order. And default priority order for any new rule is 1000. Here, enforcement means do you want to enable your rule or you want to disable your rule. In addition to all these settings, you can also enable flow logs for your firewall rule, which will help you in debugging and monitoring of your firewall rules. In this demo, I will create a VM instance that will run Apache web server inside it, and I will create a firewall rule in custom mode VPC, which we created in our last demo. And I will show you how you can control access to your web application running inside this VPC using firewall rule. Before I create any VM, please observe that there is no firewall rule defined in this VPC for the time being. Only two default implied rules are applicable for this VPC as of now. Now first, let's create a VM instance very quickly. I will use most of the default settings to create this instance. I will just use the startup script to create a web server inside this VM. I will copy paste the startup script over here. Now select the networking tab. Here attach the network tag as web server with this VM. Then change your default VPC to custom mode VPC. Now finally click on create button to create your VM. It will take some time and I will pause this video till then. Now this VM is created and an external IP is assigned to this VM. Now let's try to use this IP to access your web application inside your VM. So you can see that we are not able to reach this IP. It is because of the default implied firewall rule created inside your VPC, which denies all the incoming traffic by default. Now let's go back and create a firewall rule which will allow HTTP traffic for this particular VM. Here I will create a firewall rule to allow HTTP traffic in this VPC. I will select the direction of traffic as ingress and action as allow. I will apply this firewall rule for all the instances in this network. Then I will select the source using IP address ranges and I will allow traffic from all IP addresses. I will allow TCP traffic on port 80. Finally, click on create button. It will take some time for your firewall rule creation. I will pause the video till then. Now your firewall rule is created successfully. Now let's try to access the application once again. So here you can see that you are able to access your web application now. Now let me disable the firewall rule and see what happens if firewall rule is disabled. To disable the firewall rule, click on edit button and disable the firewall rule using this option and then click on save. Now your firewall rule is disabled. Now let's try to access the application once again. So now your application has become unreachable once again. Now let's enable the firewall rule once again. To enable the firewall rule again, click on edit button and enable the firewall rule using this option and click on save. Now your firewall rule is enabled once again. Now let's try to access application again. Now you can access your application successfully. Now I will create a higher priority firewall rule which will deny the all incoming traffic and I will show you how it affects the accessibility of your application. So let's go back to firewall rule once again. This time I will add a deny rule. Let me increase the priority for this rule. This time I will select action as a deny because I want to create the deny rule. I will again choose the target as all instances in the network. Now I will block incoming traffic from all IP addresses. Here select the protocol as TCP and port as 80 once again and then click on create button. Now your deny rule is created with the higher priority. Now let's again try to access your web application. So this application has become unreachable again because of the higher priority denial firewall rule. Now I will create another higher priority allow rule based on the network tag and will show you how it affects the accessibility of your web application. So let's go back to firewall page once again and add a new firewall rule. This time let me increase the priority of this rule further. This time I will select the action as allow and I will select my target based on the network tags. This is the same tag that I attached to my VM at the time of VM creation. Now I will allow all incoming traffic from all the IP addresses. Again select the protocol as TCP and port as 80 and click on create button to create this rule. Now your second allow rule is created with the highest priority. So now let's try to access the application once again. So we are able to access the application once again because we created a highest priority allow rule based on the network tag. You must have also noticed that we just created the allow rules for the incoming traffic. We did not create any rule for the response traffic. Response traffic is always allowed for the given request traffic, and this shows the stateful nature of the firewall rule. This is how you can use firewall rules to control traffic that is coming in and going out of your VPC. Now let's discuss about how routing works in Google Cloud VPC. In Google Cloud VPC, routes define the path that network traffic takes from one VM instance to other destination. And these destinations can be inside your VPC network or it can be outside it as well. Let's say if you want to send some request from VM A to another VM, then path taken by your request will be determined by the routes created in your VPC. And that another VM can be either in the same VPC A or it can be in a different VPC as well. Now let's take a look at the routes defined inside your default VPC. So these are the routes defined inside your default VPC. In a VPC network, route is usually defined by the single destination and the single next hop. And destination is usually defined by the IP range. If you want to send traffic to some destination whose IP is in the destination IP range of the route, then that traffic is routed to the next hop defined in that route. In Google Cloud, routing table is defined at the VPC network level and each VPC has its own routing table. Each VM instance inside your VPC has a controller that is kept informed of all the applicable routes from the network's routing table by using eventual consistency. Like route table of VPC A has two routes defined in it. Similarly, route table of VPC B has three routes defined inside it. Both controller in VMs keep copy of the route tables from the corresponding VPC in which that particular VM resides. Whenever a data packet leaves a VM, its destination is matched against the subnet routes defined in your VPC, and if matching route is found, then the packet is delivered to the next hop defined in the matched route. Each route also has the priority order defined for that route, and if multiple routes are matched against the destination of the data packet, then the route with the lowest priority wins. When you add or delete a route in your routing table, then the set of changes is propagated to the VM controller by using the eventual consistency. When you create a VPC, GCP creates two kinds of system generated routes inside your VPC. First is the default route, which allows all the VMs inside your VPC to access internet. And this is the default route for your default VPC. which allows all the VMs inside your default VPC to access internet. Other type of system generated routes are the subnet routes that define paths to each subnet inside your VPC network. And these all are the subnet routes defined inside your default VPC. Whenever a subnet is created, a corresponding subnet route for the subnet's primary IP address and the secondary IP address range is also created. Just notice that you cannot delete these system generated routes. And if these system generated routes are not sufficient for you, then you can also define your own custom routes, but make sure that the destination of the custom route cannot be more specific than any of the subnet routes. In addition to these static routes, dynamic routes can also be created and managed by the cloud router in your VPC. And in case of dynamic routes, destination always represent the IP ranges outside your VPC network. Now let's see how you can add a new custom route in your VPC. To add a custom route in your VPC, click on the Add Route button. Adding a new route in your VPC is very simple. You just need to give a name and description for your route and then define the destination IP range for your route. You can also change the priority associated with your route. And finally, you just define the next hop for your route. You can select any of these options to define the next hop for your route. It can be either internet gateway or it can be a individual instance. You can also specify the IP address. It can also be a VPN tunnel or it can be the load balancer forwarding rule as well. Finally, just click on the create button and your custom route will be created. This is all about routes in GCP. If you have any queries regarding this, please post your queries. So far, we have understood that each VPC in Google Cloud is bound to a project. And in large organizations, you may need to put different departments or different applications into different projects to achieve separate budgeting and access control. By creating resources in different projects, you can achieve complete isolation, but it is not always required to strictly isolate these departments. It is only to control access and manage the resources. In fact, sometimes you need to share some information or services with other departments. And this sharing of the resources can be beneficial to the organization as well, as it will avoid duplication of resources across multiple projects and ultimately can save the cost for the organization. For such kind of use cases in GCP, you can create a shared VPC network which allows an organization to connect resources from multiple projects to a common VPC network so that they can communicate with each other securely and efficiently using the internal IPs from that network. Shared VPC approach allows you to create a shared VPC inside a host project which can share its network of private IP subnets and their attached resources with all the associated projects called service projects. A host project can contain one or more shared VPC network. To create a shared VPC, admin of the shared VPC must first enable a project as a host project. After that, a shared VPC admin can attach one or more service projects to the host project. A service project is any project that has been attached to the host project by the shared VPC admin. Just keep in mind that a project cannot be both host project and the service project simultaneously. You can create and use multiple host projects. However, each service project can only be attached to a single host project. With shared VPC, cloud organization administrators can give multiple projects permission to use a single shared VPC network and corresponding networking resources. Also notice that the shared VPC connects projects within the same organizations only. Both participating host and the service project cannot belong to the different organizations. As shown in this diagram, multiple service projects are connected to the same shared VPC network and all the projects resides in the same organization. Let us try to understand how shared VPC works via an example. Consider a case where you are developing an e-commerce application and your web interface displays various kinds of information on its dashboard, like personalization information, recommendation information, and analytics information. But all these three information comes from different teams which manages their application in their respective projects. So in this case, question comes, how can you build common UI on top of these services which are hosted in different projects? You can solve this challenge by hosting your shareable common web UI in the shared VPC, which will connect all the three service projects and retrieve information from those projects. Resources between host projects and the service project can talk to each other via internal IP addresses. This is how shared VPC can help you. During external IP address discussion, we have already seen that whenever two VMs in different VPC need to talk to each other, then that communication happens via external IP address. In addition to this, there is one another way which allows VMs in two different networks to communicate with each other, and that is the VPC peering. In Google Cloud, VPC peering allows connectivity between two different VPCs via internal IP address. It is not like VPC sharing. VPC sharing can happen between two different projects within the same organizations, but there is no such condition in case of VPC peering. In case of VPC peering, two different VPCs can be either in the same organization or it can be in the different organizations as well. In fact, two VPC networks can be in the same projects as well. To establish VPC peering between two networks, both networks must establish VPC peering from their side individually. Like here, we need to establish VPC peering between two VPC networks, network 1 and network 2. So, network 1 does the VPC peering with network 2 via peer 1 2. Similarly, network 2 also need to establish separate VPC peering with network 1 via peer 2 1. Once both side of peering is configured, then VPC peering is set to be complete between two networks. Once two VPCs are connected via VPC peering, the two networks always exchange the subnet routes of each other. Let's take a look at another example to understand how VPC peering works in case of multiple networks. In this example, network A needs to access service from two different networks, which are the network B and network C. To achieve this, separate VPC peering is established. First peering is established between network A and network B using the peering configurations peer AB and peer BA. Similarly, VPC peering is established between network A and network C using peering configuration peer AC and peer CA. This is how you can achieve VPC peering between multiple networks. But in such cases, keep one thing in your mind, that VPC peering is not transitive in nature. It means though both network B and network C are paired with the network A, but it does not mean that there is a VPC peering between the network B and network C. Network B and network C cannot communicate with each other via internal IP address like paired network. While doing VPC peering between two networks, there is one restriction, that there should be no overlapping between subnet IP ranges between two networks. At the time of peering, Google Cloud checks to see if there are any subnet IP ranges in one network that overlaps with the subnet IP ranges in the other network. If there is any overlap, peering is not established. Like here, VPC peering cannot be established between network 1 and network 2 because of the overlapping subnet IP ranges between the subnet 1 and subnet 3. Same way, in this example, you can establish VPC peering between network N1 and network N2. And once this peering is established, both network exchanges subnet routes with each other to support full mesh connectivity between both the networks. Now, if you want to establish VPC peering between network N2 and network N3, then it fails because IP ranges of the subnet 1 and subnet 5 overlaps with each other. Because in case of VPC peering, communication happens via internal IP addresses. It leads to cost saving on the egress traffic, and it also reduces the network latency. In addition to this, by using VPC peering, service owners do not need to have their services exposed to public internet and deal with its associated risk. Now let's discuss what is a bastion host and when to use it. Whenever you deploy an application in production environment, your application consists of various VMs. Like in a typical three-tier application, these VMs can represent your web server, application server, or it could be a database server as well. For the security reason, you never want to expose these VMs to the public domain in the internet world. So you normally remove external IP address from all these VMs to avoid any public access via internet. But if you do this, then how will you apply any kind of a software update or new application version on these VMs without making a connection with these VMs? This is where Bastion host can help you. In such situation, you create a VM with external IP address and SSH traffic allowed in your VPC that act as an entry point in your VPC. And we call this entry point machine as the Bastion host. Since this Bastion host has an external IP address and SSH is also allowed for this, you can connect to this machine via the internet using the SSH protocol. Once you are connected to this, you can further use this VM to access the other VMs in your VPC via internal IP address. You can make the connection between the Bastion host and the internal VM via internal IP because they both are in the same VPC. As shown in this figure, there are three internal VMs which can run either database or the application services for your application. All your isolated internal VMs only have the internal IP addresses inside your VPC. However, the Bastion host instance has the external IP address and it also has the internal IP address of your VPC. If you need to access instances on the internal network that do not have the external IP addresses, then you can connect to your Bastion host first and then you can connect to the internal VM via the Bastion host. This method uses a two-step SSH connection. First connection is from the internet to the Bastion host via SSH and second connection is from the Bastion host to the internal target VM. First connection uses the external IP address of the Bastion host while second connection uses the internal IP of the target VM. Because of this two-step login, this Bastion hosts are sometimes called as the jump servers. During discussion about the Bastion host, we learned how to use Bastion host to connect to your internal VM for doing any kind of maintenance activity on these internal VMs. But challenges are not over yet. Next challenge is that if you want to do some software update on these internal VMs that need internet access, how can you do this without the external IP for the internal VMs? We know that VM cannot access internet without the external IP address, and since internal VMs in our case do not have external IP address, so we cannot download any software on these internal VMs from internet. Is there any solution to this problem? How can you allow these internal VMs to access internet without exposing them to the public internet? Answer to this question is given by the NAT gateway. NAT gateway routes traffic and allow multiple VMs in a subnet to reach to internet using a single public IP address without exposing internal VMs to public internet. Here, in this case, all your VM talk to NAT gateway and NAT gateway in turn access the internet. But it does not allow internet traffic to reach your internal VMs directly, and hence your internal VMs are still secure in this case. With traditional NATs, you typically have NAT proxy instances between your cloud instances and their destination. And this creates the choke point in the path to access the internet. Hence, it affects the performance, throughput, and availability of your NAT solution. But in case of Google Cloud, NAT is provided as a software-defined managed NAT service, and this service is known as CloudNet. In case of CloudNet, there is no choke point and it provides high scalability and availability with higher performance. In this section, we will talk about hybrid networking options available in GCP. But before we discuss these options, let's first understand what is hybrid networking. Hybrid networking simply means deploying your application resources in a way that some resources are available in cloud and some resources are in non-cloud environment, or you can say in your on-premise network. And in fact, in real world, hybrid networking is the more common approach of deploying applications because it is not feasible for most of the organizations to migrate its entire infrastructure in cloud in one go. Organizations do this cloud migration activity in a phased manner. So in this situation, support for the reliable and highly available hybrid networking becomes very important to keep your application running. So far, you have seen how to create your own VPC in Google Cloud and configure firewall rules and routes inside it. But in addition to this, Google Cloud also provides various options to support hybrid networking like direct peering, cloud interconnect, and cloud VPN. And each option has its own pros and cons. Since each organization has its own specific workload and budget, so GCP has created all these options to fit as per the different use case and the budget. Like for high performance, you can go with either dedicated interconnect or partner interconnect. But in case you have less traffic volume and you want to save cost as well, then you should go with Cloud VPN. Whenever you connect your on-premise network with Google Cloud VPC, you can face some challenges. Like if you're connecting your on-premise resource with Google Cloud, then data security will be the foremost concern for you. You would not like your data to travel via public internet to ensure data security. You can use VPN for such connections to encrypt your information, but it can put additional performance overhead for your data transfer. Second concern for you is the latency. You always want to use high speed network to meet your application and business SLA in case of hybrid networking. In addition to these, you also prefer to use highly available and reliable networking for smooth functionality of your application. You cannot rely on the public internet because of all these challenges. To cater to these needs, Google Cloud provides various tools to meet your hybrid networking requirements. Next, we will discuss about these options in GCP to support your hybrid networking. First option to support hybrid networking in Google Cloud is Cloud Interconnect. Cloud Interconnect provides low latency, high available direct connections between your on-premise and Google Cloud VPC. It basically provides extension of your private data center to GCP via dedicated connection between them. It provides internal IP address communication, which means internal IP addresses are directly accessible from both networks. In this case, traffic between your on-premise network and your VPC network does not travel via public internet. Traffic travels either through the dedicated connection or through a service provider with a dedicated connection. Because you are able to avoid public internet in case of cloud interconnect, so your traffic takes fewer hops. So there are fewer point of failure as well, where your traffic might get dropped or disrupted. In addition to speed, it also ensures data security by avoiding public internet. In case of cloud interconnect, internal IP addresses of your VPC are directly accessible from your on-premise network. You don't need to use a net device or VPN tunnel to reach internal IP addresses, and you can scale your connection capacity to meet your requirements. By using interconnect option, you can also access some of the Google API and services via private Google access that allows you to access these API via internal IP address. And this provides security, speed, and high availability for your data transfer with business SLA defined. You prefer to use interconnect option where security and high speed is very critical requirement like data transfer, data replication, or disaster recovery, etc. You can use this cloud interconnect option in two ways, either dedicated interconnect or partner interconnect. Dedicated interconnect provides direct physical connection between your on-premise network and Google network. Just look at this diagram. Here, a direct physical connection is established between Google Cloud VPC and your on-premise network at a common co-location facility. Here, you have created Cloud Router to support dynamic routing between the Google Cloud and your on-premise network. It enables exchange, addition or deletion of any route between the two networks. Like if some route is added in your on-premise network, this information is passed to Cloud VPC, and Cloud VPC will store this route information locally. In the same way, it also exchanges the route information of Cloud VPC with the on-premise network. Once this connection is established, both networks can talk to each other via internal IP addresses. Since traffic is not routed via internet, this dedicated interconnect allows you to transfer large amount of data between networks, and it is a cost-effective way to transfer data between Google Cloud VPC and your on-premise network. By using dedicated interconnect, you can use either 10 Gbps or 100 Gbps connection to connect your on-premise data center with Google Cloud VPC, and this dedicated interconnect option is preferred to use for very low latency application. If you want to achieve high availability, you can establish multiple direct connection between your on-premise and Google Cloud network, so that if one connection is down for some reason, traffic can be routed via other path. You can see here in this diagram that multiple direct connections are established between both regions to achieve high availability. There are multiple interconnection locations available in Google Cloud, and you can establish direct interconnection by using any of these locations. Ideally, you prefer a location which is nearest to your data center. In case of cloud interconnect, Google will charge you based on your interconnect attachments capacity and the egress traffic from your cloud VPC. If your network does not meet the requirement of direct interconnect, then there is another option of interconnect, that is partner interconnect. In case of partner interconnect also, connection is established between cloud VPC and your on-premise data center, but it is slightly different from the dedicated interconnect. In case of dedicated interconnect, it was direct physical connection between two networks. But here, in case of partner interconnect, this connection is established through a service provider, as you can see on this diagram. You choose this interconnect option if your network is not co-located with any of the direct interconnect location. As you can see over here, you make a connection with service provider peering edge location from your on-premise network, and then Google Cloud is connected via service provider. Once both these connections are established, you can use this connection for high-speed data transfer in a cost-effective way, and your traffic use the service provider's network to reach to Cloud VPC, but it does not use public internet. Here also, to achieve higher availability, you should establish multiple partner interconnect to create redundancy in your network. If your traffic does not require a 10 Gbps or 100 Gbps circuit, you should consider Cloud VPN or partner interconnect rather than the direct connect option. In case of partner interconnect, Google will charge you based on your interconnect attachments capacity and any egress traffic from your cloud VPC. In addition to this, you might also need to pay for the service provider's fee. Egress traffic charge rate is discounted as compared to normal egress traffic charge for both dedicated and partner interconnect. This is all about cloud interconnect. Another option for connecting with Google Cloud is direct peering. In case of direct peering, direct connection is established between your own premise data center and one of the edge location in Google Cloud. And you can use this peering connection for fast data exchange between your on-premise network and cloud VPC. Peering is layer 3 option to connect with GCP, and it gives you access to Google Cloud Service and products like G Suite as well, which are exposed by the public IP addresses. There is no cost to set up direct peering, and you can establish direct peering at any of the 100 peering locations present today. Here you can see the egress traffic rate for direct peering for different locations. Once peering is established between your on-premise network and Google Cloud Edge point, it gives you direct access to G Suite and Google services, including the full suite of Google Cloud products from your on-premise network. In this case, you are charged at the discounted rate for the egress traffic targeted for your on-premise network, and there is no upfront cost in setting up of peering connection. But keep in mind that you need to contact Google to enable the discount pricing for the egress traffic in case of direct peering. You also have to talk to Google if you want to change IP address range of your destination of your on-premise network. Next option to establish peering connection is carrier peering. Carrier peering enables you to access Google applications such as Google Workspace by using a service provider. This option provides connection to Google through a service provider. You can get connections with higher availability and lower latency using one or more links to obtain enterprise-grade network service that connect your infrastructure to Google. In case of peering, you need to pay for both egress traffic and service provider fee. Here you can see the egress traffic rate in case of carrier peering for the different locations. In case of both direct peering and carrier peering connection, egress traffic travels either through the internet gateway or configured VPN tunnel. Carrier peering exits outside of Google Cloud, and Cloud Interconnect is more recommended approach unless you need to access Google applications. Here you can see list of service providers that supports the carrier peering connection as of now. This is all about peering options available in GCP. Next option to extend your on-premise network in GCP is Cloud VPN. Cloud VPN securely connects your on-premise network with VPC in Google Cloud through IPsec VPN connection. In case of Cloud VPN, traffic between two networks travel via internet, and traffic traveling between these two networks is encrypted by one VPN gateway and then decrypted by the other VPN gateway, and this encryption protects your data as it travels over internet. When you extend your on-premise network to GCP, you normally create a Cloud VPN in GCP which connects with the corresponding peer gateway in your on-premise network. You also need to establish two VPN tunnels, one from GCP to your on-premise network and second tunnel from your on-premise peering gateway to Cloud VPN in GCP. In Google Cloud, you can create VPN in two ways. You can create either classic VPN or you can create high availability HA VPN. HA VPN is a highly available cloud VPN solution in a single region. HA VPN provides an SLA of 99.99% service availability. It has two network interfaces with different external IP addresses. HA VPN is more recommended approach in production environment because it provides higher availability of 99.99% as compared to classic VPN, which provides 99.9% availability. On the other hand, classic VPN provides 99.9% availability and it has only one network interface. If you use classic VPN, then to achieve high availability, multiple cloud VPN must be created in a region. As you can see over here in this diagram, your on-premise network is connected with VPC in Google Cloud via Cloud VPN. Here in this case, HA Cloud VPN is created in your Google Cloud VPC, which connects with the peering gateway in your on-premise network. And two pairs of tunnels are connected between your on-premise peer gateway and GCP. Here, two pairs of tunnels are created to achieve high availability, so that if there is any failure in one tunnel, then traffic will shift to another tunnel. You can also use Cloud Router with Cloud VPN to support dynamic routing by creating a BGP session between Cloud VPN and peering gateway. I will explain about Cloud Router in detail in another video. For the time being, this is all about Cloud VPN. You have already seen default routes and subnet routes during discussion about VPC. These are the static routes. In case of Auto VPC, these routes are automatically created by GCP for you, but you can also add your own routes in your VPC. These routes determine how data packet will travel from one source to destination. Kind of routes that we have seen so far are the static routes. With static routes, you must create or maintain a routing table. In case of static routes, if there is any change in the topology on either network, then it requires you to manually update the static routes. Though managing routes like this gives you granular control, but you can manage static routes this way for small network only. This kind of static routing is suitable for small network with stable topologies. In case of large network, managing routes becomes tedious. Biggest problem with the static route is that these are not fault tolerant. If some link becomes unavailable, then it cannot be fixed without manual intervention. As shown in this diagram, here you are connecting your on-premise network with Google Cloud via VPN gateway. Here in this case, both networks have only fixed number of subnets. In such case of small network, static routing works fine. Now consider a case where you want to add a new subnet in your on-premise network. Now question is, how will routing take place for VM in such new subnet in this case? One way is to add route information manually in both on-premise network and Google Cloud network, which requires reconfiguration of VPN at both ends. Another option is to use the Cloud Router. With Cloud Router, you can use BGP session to exchange routing information between both networks. Instead of manually configuring static routes, network's topology is automatically discovered and advertised through BGP session. This way, network changes are seamlessly implemented without disrupting traffic. This method of exchanging route through BGP is dynamic routing. Dynamic routing is suitable for any size of network. It frees you from maintaining static routes. Also, if one link fails, dynamic routing can automatically reroute traffic if possible. Here, in this case, Cloud Router in your Google Cloud VPC is connected to both Google Cloud VPN gateway and peering gateway in your on-premise network, and it established the BGP session between both the gateways. Cloud Router is a fully distributed and managed Google Cloud service that manages the dynamic routes, and it scales with your network traffic. Cloud Router works with both legacy network and VPC networks. Cloud Router is not a connectivity option, but a service that works over Cloud VPN or Cloud Interconnect connections to provide dynamic routing by using BGP for your VPC network. Cloud Router is not supported for direct peering or carrier peering connections. Cloud Router is not a physical device that might cause a bottleneck. When you extend your on-premise network to Google Cloud, you should use Cloud Router to dynamically exchange routes between your Google Cloud network and your on-premise network. Cloud Router peers with your on-premise VPN gateway and Cloud VPN in GCP. The Cloud Router exchanges topology information through BGP session. If there is any change in the network topology in such connected networks, those topology changes will automatically propagate between your VPC network and your on-premise network. When you use Cloud Router, you don't need to configure static routes. This is how Cloud Router can enable dynamic routing in the connected networks. Next service in networking that we must understand from this exam perspective is Cloud DNS. Like any other DNS service, Cloud DNS here also just resolve your domain name to IP address. For example, when you type this URL in your browser, DNS converts the URL into the IP address of a web server associated with this name. DNS makes your application easily available to users without requiring them to remember the string of numbers which represent the IP address. In case of Google Cloud, DNS is the only Google service that offers a 100% uptime guarantee. It is because nothing can run unless DNS resolve your URL into IP address. There can be small application issue or there can be some availability issue. But if you cannot look up a domain name, then it means you cannot access your application at all. So that is why you have never seen a situation where you hit google.com in your browser and it says, sorry, I cannot find this IP address. This is because of the Cloud DNS service only. Cloud DNS is a high-performance, resilient global domain name system service that publish your domain names to global DNS in a cost-effective way. And this makes easier to manage your application while giving users easy access to these applications. Cloud DNS runs on Google Cloud's trusted infrastructure rather than your own premise data center, and it provides you with easy lookup of your authoritative name servers. Cloud DNS resolve your DNS name to IP address with the help of any cast name servers. Any cast name servers are the ones that can respond to DNS queries. Google offers a global network of these to provide users with a quick result to a query. Ideally, the name server that is geographically closest to you should handle the query, but any location around the world provides redundancy for high availability and low latency for your request. Now, let's try to understand some of the important concepts to learn how DNS resolution works. DNS is a hierarchical distributed database that stores IP addresses and other data and allows you to query this information by name. You can actually host all of your authoritative DNS records directly through Cloud DNS. You can call those through either an API or through the web console. An authoritative server is a server that holds the DNS name records like a record or 88AA record or the canonical name record, etc. A non-authoritative server constructs a cache file based on the previous queries for the domains. It does not hold original name records. Cloud DNS managed zones are an abstraction that manages all DNS records for a single domain name. One project may have multiple managed zones. Managed zones provide permission control at project level and allows you to monitor propagation of the changes to DNS name servers. You can create both public and private zones in Cloud DNS. A public zone is visible to Internet. You can create DNS records in a public zone to publish your service on the Internet. For example, you might create an A record in a public zone called example.com for your public website www.example.com. A private zone is any zone that cannot be queried over the public internet. These zones gives you an easy to manage internal DNS solution that focus on your virtual machine, load balancers, and other GCP resources. Private zones can only be queried by your organization's authorized VPC network and are assigned to specific projects only. You can create various types of records in Cloud DNS. A record is a mapping between a DNS resource and a domain name. Each individual DNS record has a type, an expiration time, and type-specific data. Some of the commonly used record types are A record, CNAME record, or you can say canonical name record, etc. And each record has a specific purpose. You can please go through some of these important record types in Cloud DNS. This is all about the Cloud DNS for the time being. If you have any queries regarding this, please post your queries. Another important service that you should understand in networking section is Cloud CDN. But before we talk about Cloud CDN, we will discuss what is CDN and why should we use Cloud CDN. Whenever you have very popular website like Netflix, you normally have your customers across the globe for your application, and your application should be able to serve user requests with low latency. But since your customers are present in different regions, some of these customers might be present near to application server, but other customers might be living in some remote location as well. So for the remotely located customers, both request and response has to travel a long distance, which causes latency for these customers. As you can see in this diagram, some happy customers are staying near to application origin server while other customers are remotely located. And response time for such customers is higher as compared to the customer who are staying near to the place where your application servers are hosted. This is where Cloud CDN can help you. What it does is it basically copies the data from the origin server to the Google Edge locations. And these Google Edge locations are globally distributed. Once this data is copied to the edge location, then requests are served from the edge location rather than the origin server. Since in this case, customers' requests are served by the nearest CDN edge location, so customer experience the low latency in this case. At a high level, this is how Cloud CDN provides fast, reliable web and video content delivery with global scale and reach to its customers. Now let's look at some of the features of Cloud CDN. Google's Cloud CDN has edge locations distributed across the globe at various locations, and it provides a single Anycast IP address for its customers. Google's Cloud CDN is highly optimized and it supports modern protocols which are originally developed at Google itself. Cloud CDN is tightly integrated with cloud monitoring and cloud logging service, which helps you in providing detailed latency metrics out of the box. And you can get request log for the deeper visibility. You can use Cloud CDN with both HTTP and HTTPS load balancer. SSL support is very much integrated with Cloud CDN. Cloud CDN can serve responses from globally distributed caches, even when you need requests to be authorized on a per user basis. One of the very common use case of Cloud CDN is to use it with the HTTP load balancer to deliver content to your users. The HTTP load balancer provides the frontend and the backend for your application, where frontend defines the IP address and port that receive the request from user, and backend actually respond to the request. You can configure Cloud CDN with such load balancer. As per this diagram, your web servers are running inside Compute Engine VM instances and traffic is load balanced by a HTTP load balancer. Static content is cached at the Cloud CDN and any request for static content is served from nearest cached edge location without going back to the backend origin server. If requested content is not available at the edge location, then content is fetched from other nearest cache edge location where content has already been cached. If content is not available at other cache locations as well, then it is read from the origin server. This content is cached at the edge location for next subsequent request, and current request is also served by this cached content. Now let's do a quick recap of what we have learned in this section. In this section, we have learned about what is Cloud VPC and how can you create your own VPC in Google Cloud. Every project comes with a default VPC, but you can also create your own custom VPC with custom subnets, firewall rules, and subnet routes inside your VPC. Default VPC comes with subnets defined in all the regions, and default VPC also has default firewall rules that denies all ingress traffic and allows all egress traffic for your VPC. Default VPC also comes with subnet routes that allows all VMs inside your VPC to communicate with each other. Default VPC also has a route that allows VM inside your VPC to access internet via internet gateway. Firewall rules in your VPC is the first line of defense in your network. By configuring firewall, you can control traffic coming in and going out of your VPC. We also discussed how to create shared VPC, which allows VPCs in the same organization to connect with each other. You can create some shared resources in host shared VPC, and this shared resource can be accessed by VM inside the guest VPC connected with this shared VPC. You can also use VPC peering to connect any two VPC in Google Cloud. We also learned how to do software maintenance on your VM inside VPC using Bastion host and NAT gateway. In addition to this, we also looked at the hybrid networking options like interconnect, peering connection, and cloud VPN, which allows you to extend your own data center to Google Cloud and you can use any of these options based on your requirement and budget. In the end, we also discussed some other important networking service like Cloud DNS and Cloud CDN at high level to understand what are these services and when to use them. Cloud DNS gives 100% uptime guarantee in Google Cloud, and Cloud CDN is the content delivery network to cache static content at Google's edge location. You use Cloud CDN to provide low latency experience to your customers. This is all about networking in Google Cloud. If you have any queries related to this, please post your queries. From this chapter, we will start our learning journey about storage options available in Google Cloud. We have already seen some of the storage solutions provided in GCP, like persistent disk, while learning about Compute Engine. We can use them as a bootable disk. You can access storage of these persistent disks in terms of blocks. It means whenever any file is saved to the persistent disk, this file is allocated storage in fixed size chunks called as blocks. Each persistent disk is associated with a unique address space. Persistent block storage device provides fixed-sized raw storage capacity. Each storage volume can be treated as an independent disk drive and controlled by an external server operating system. This block device can be mounted by the guest operating system as if it were a physical disk. In addition to block storage solution, Google Cloud also provides various other type of storage options for you to meet your requirement for the different kind of workloads. GCP provides cloud storage as Object Store in Google Cloud. Object Store is quite different as compared to block storage. You cannot use it as a file system based storage and you cannot install your OS on this. You cannot use it as a bootable disk as well. Block storage volumes can only be accessed when they are attached to an operating system. But data kept on object storage devices, which consist of object data and metadata, can be accessed directly through APIs. Cloud storage is normally used to store unstructured data like video files, images, log files, etc. Cloud Object Store guarantees that data will not be lost. Object storage data will be replicated across different data centers. GCS stores data in the form of object on an underlying distributed file system called Colossus. Colossus is Google proprietary and a very high performing file system. You can transfer data in or out of GCS using a command line tool called gsutil. You can also use REST API or Cloud Console to interact with GCS, and in this chapter we will primarily focus on GCS. In next chapters, we will learn about other storage options available in Google Cloud like Cloud SQL, Cloud Spanner, Datastore, Bigtable, and BigQuery. Cloud SQL and Cloud Spanner are used to store relational data in cloud, while Cloud Datastore is a NoSQL document database like MongoDB or like DynamoDB in AWS. Bigtable is another NoSQL database to store columnar data. It is like H-based database. And BigQuery is used for data warehousing solutions in Google Cloud. It provides SQL-like interface to run your analytics queries. You have already seen how to host web application in Compute Engine VM instance by using persistent disk storage. Persistent disk work fine for this use case because you need to store some limited number of files like HTML, CSS or JS to host your website. But if you want to run some video library like Netflix, then you need to store large amount of unstructured data like images and video files. In this case, persistent disk will not solve your purpose because these are unstructured data and large in sizes. It can even exceed storage limit provided by the persistent disk. For such use cases, you prefer to use cloud storage to store your unstructured data. Cloud storage is a persistent object storage system which provides you limitless storage in cloud, and you need to pay for only storage space that you occupy in cloud storage. You can interact with cloud storage using a gsutil command line tool or REST API or via Cloud Console or programming language specific client library. You don't need to allocate capacity or create a storage server of any type, and it scales automatically as per your needs. Whenever you store some object in cloud storage, data is replicated across multiple geographies to provide high availability, and it provides 99.9 times durability, or you can say 11.9 durability. There is no minimum size for the object that you want to store in GCS, but there is a maximum size limit of 5 terabyte for the individual object stored in cloud storage. Cloud storage is a low latency solution to store and retrieve data in Google Cloud, and an object's data is completely opaque to cloud storage. It is just a chunk of data to cloud storage. Now, before I show you how to store some data in cloud storage, you should understand two important keywords related to cloud storage. These keywords are bucket and object. Buckets are the basic container that hold your data. Everything that you store in cloud storage must be contained in a bucket. You can use buckets to organize your data and control access to your data stored in bucket. But unlike directories and folders, you cannot nest your buckets. Each bucket that you create should have a global unique name as the name of the bucket stored in a single cloud storage namespace. You can also attach multiple labels with your bucket. These bucket labels are the key value metadata pairs that allow you to group your bucket along with the other Google Cloud resources like Compute Engine VM instances. You have already seen labels with the VM instances, and these bucket labels are also similar to those only. You can also define lifecycle management rules for your bucket, which enables you to manage lifecycle of all the objects inside that bucket. Object is the actual data that you want to store in Google Cloud. There is no minimum size for the object that you want to store in cloud storage, but object size in cloud storage cannot exceed 5 terabytes. Each object that you store in GCS has two components. One is the actual data and other is the metadata associated with the object data. This metadata is specified in terms of key and value pairs for the object. For some metadata, key is fixed. You can just give the value for this metadata like cache control, content description, etc. You can also add metadata for your object by defining both key and value as well. Object that you store in cloud storage is usually like a file, like a video file or a image file. You can create any number of objects in your bucket. There is no limit on the number of objects that you can store in a bucket. Also remember that objects stored in GCS are immutable. It means you cannot change the object once it is stored in GCS throughout its entire life. You can just replace the whole object with the other object, or you can delete the entire object from GCS. Also notice that all these objects are completely opaque to GCS. For GCS, any stored object is just a binary data. There is no limit on how frequently you can create or update different objects in a bucket. However, you can update or replace a single object only once per second in one bucket. For example, if you have one object bar in bucket foo, then you should only upload a new copy of this bar object about once per second. If you try to update this object more frequently, then you will get HTTP error 503, which means too many request errors. You can also save multiple versions of one object inside your bucket. Now, before we move further in this section to learn more about Google Cloud Storage, let me show you how to create bucket and store objects in GCS. In GCP, there are multiple ways to interact with cloud storage. You can use Cloud Console, gsutil command line, or REST API. Here, let's try to store objects via Cloud Console UI. So to open the cloud storage, click over here and select the storage option. Here you can see list of my existing buckets. To create a new bucket, click on Create Bucket button. To create a bucket in GCS, you need to provide primarily three things. First is the name of your bucket, then the location where you want to create your bucket, and third is the storage class for your bucket. So let me give a name to my bucket. Bucket name that you give over here must be globally unique. Uniqueness in your project is not sufficient. You can also use domain name as the bucket name. If you want to check the complete naming guidelines, then you can click over here and can see the complete naming guideline for your bucket. After specifying name, next you need to choose the location for your bucket. Objects stored in this bucket will be stored in the selected location, and it will affect the cost and performance for the data storage and data retrieval. Here you need to choose whether you want to store your objects in the single region or you want to store your objects in the dual region or multi-region. Both dual region and multi-region are the geo-redundant locations. If you select the regional option, then you will get the lowest latency. If you select the region option, then you can select the any region from this list. But if you select the dual region option, you get the high availability as well along with the low latency. In this case, data is replicated across two regions. As of now, these are the only three locations available for the dual region option. If you choose the multi-region, then you get the highest availability. You should use multi-region when you want to serve content to consumers that are outside of the Google network and distributed across large geographic area. Here you can see the option in case of multi-region. Generally, you should store your data in a location that is closest to your customer. Here I will select the region option and I will use US Central 1 as the region for my bucket. Now click on continue. After location, you need to decide the storage class for this bucket. Storage class that you will select here will become the default storage class for the objects inside this bucket. While storing objects inside bucket, either you can use the storage class of your bucket if you do not specify the storage class for your object, or you can specify the storage class at the object level as well. Storage class of an object affects its availability and cost for saving and retrieving the object. Currently, there are 4 storage classes in GCS, and these are the standard, nearline, coldline, and archive storage classes. Here, this time, let's go ahead with the standard storage class. I will explain storage classes later in more detail. Now click on continue. Here you need to choose how you want to control access for the objects stored in this bucket. Either you can use fine-grained access by using object level permission in addition to bucket level access permission, or you can apply the same access permission uniformly by specifying the access permission at the bucket level. For the time being, let's go ahead with the default selected option here, that is fine-grained control. This also I will explain in more detail later on. Now click on continue button. Here you can control encryption for your objects data stored in GCS. Here you can use either Google managed keys or you can use the customer managed keys. Let's go with the Google managed keys for this demo. Next, you can specify the retention period for the objects in this bucket. Retention policies specify the minimum duration that this bucket's object must be protected from deletion or modification after they are uploaded in bucket. Here you can specify the retention period for the objects inside this bucket in terms of seconds, days, months, and years. For this bucket, I will not set the retention period. Here you can attach key value labels to your bucket. You can group multiple buckets by attaching the same labels to your bucket. For the time being, I will not attach any label to this bucket. On the right hand side of this page, you can see the cost estimate for the object storage and retrieval inside your bucket. This cost will vary depending upon the location and storage class that you choose for your bucket. Currently, I am using regional bucket, so my storage cost is $0.02 per GB per month. But if I select the multi-region bucket, then my storage cost goes up to $0.026 per GB per month. Data retrieval is free for both multiple region and single region. Similarly, cost for the standard storage class is different from the cost for the nearline storage class. In case of nearline, cold line, and archive, you also need to pay for the data retrieval. Next, you can see the cost of operations that you can perform on buckets or objects inside this bucket. Operations are broadly categorized in two categories: Class A operations and Class B operations. Class A operation means operations like create bucket, upload objects, set bucket permissions, delete object permissions, etc. On the other hand, Class B operations are like download objects, view metadata, retrieve bucket and object permissions, etc. Here you can see cost for both kind of operations. Next, it will show availability of your bucket and your monthly estimate cost based on whatever information you have provided over here. Since I am using free tier as of now, so my monthly cost for the timing is $0 per month. Now click on create button to create your bucket. So here is the bucket that I just created. Here under object tab, you can see the list of objects in this bucket. You can also upload any new object on this page by clicking on upload file button. Let me add an object in this bucket. So here your first object is created inside this bucket. Here you can also see the properties for this object like size, type, creation time, storage class, last modification time, public access, encryption key, etc. You can also see the retention period for this object. If you want to download this object, you can click on this arrow button, and here you can see the object. Here you can perform other operations related to your object like edit metadata, edit object permissions, copy, move, rename, etc. If you want to delete an existing object, then select the object which you want to delete and click on the delete button. Under configuration tab, you can see configurations for your bucket that you specify at the time of bucket creation. Here you can change some of the configuration for your bucket, like if you want to change the storage class for your bucket, then click over here and select the next desired storage class for the bucket. You can also add or remove the labels for your bucket by clicking over here. Similarly, you can also change the encryption keys and the access control for your bucket. Here, requester pay flag determines who will pay for the bucket data for this bucket. By default, project owner is supposed to pay for the bucket created inside the project owned by the project owner. If you do not want to pay for this bucket and instead of this, requester of the bucket data to pay for it, then you can toggle this flag by clicking over here. If you turn on this flag, then the request for the bucket's data will be billed to the requester's project instead of the bucket owner, and requester will be asked to select their own billing account at the time of data retrieval. Here under permission tab, you can define the access control for this bucket. Here you can see the list of members and the roles defined in this project. If you want to change access control from fine grained to uniform, then you can do it from here. Here you can change it to uniform if you want. Under this retention tab, you can set the retention policy at the bucket level for the objects inside this bucket. Here you can specify the lifecycle rules for your bucket. I will explain all this later. So this is how you can create and manage your bucket in GCS at high level. Now let's see what do you mean by the storage class and how to select the right storage class for the bucket. You have already seen that while creating a bucket, you need to define the storage class for your bucket. These storage class determines the availability and cost for data storage and other operations. Buckets in GCS are mainly divided into four classes based on their availability, demographic relevance, and frequency of access. These storage classes are standard storage class, nearline storage class, coldline storage class, and archive storage class. Whatever storage class that you specify at the time of bucket creation is the default storage class for the objects stored inside this bucket. If you do not specify a default storage class when you create a bucket, that bucket's default storage class is set to standard storage class in that case. When you add an object to the bucket, they will inherit this storage class unless storage class is explicitly specified at object level. There are some common aspects which are applicable to all storage classes. Like there is a single API for all storage classes and all of them provides unlimited storage with no minimum object size. Objects stored in all storage classes are accessible from anywhere across the world and provides low latency and high availability. In addition to this, all the storage classes provides the 11.9 durability. Standard storage class is generally used for frequently used data. Earlier, GCP used to have standard multi-regional and standard single-region storage classes. Now, in place of these two standard storage classes, we have option of using single standard storage class. Location you can specify separately for your bucket. If you choose to use single region standard storage class, then it provides 99.9% availability. On the other hand, if you choose multi-region standard storage class, then it provides 99.95% availability. Multi-region standard storage class is more suitable for use case like serving web content, serving videos, or any other use case where you have customers across the globe and you want your data to be present near to your customer. It also provides high availability to your data because your data is replicated in multiple regions. Multi-region standard storage class is the most expensive class of buckets and should only be used when you are certain that your traffic is global. You use single region standard storage class where your data is consumed by compute resources like compute engine instances or GKE cluster or data proc cluster in the same region which needs data with low latency. In such case, you should create your bucket in the same region where your compute resources are present to optimize the performance. This option of storage class provides data with lower latency and cheaper rate than the multi-region standard storage class. There is no minimum storage period applicable in case of standard storage class. It means you will just pay for the duration for which you store your data in cloud storage. Next storage class available in GCS is nearline storage class. Nearline storage class is a low cost and highly durable storage service for storing infrequently accessed data, or you can say cool data. This storage class is ideal for data that you plan to read or modify on an average of once per month. For example, if you want to continuously add files to cloud storage and plan to access those files once a month for analysis, then nearline storage class is a great choice in such case. You can use nearline in use cases like data backup, data archival, etc. It offers less availability as compared to standard storage class. In single region, it provides 99% availability, and in case of dual region or multi-region, it provides 99.9% availability. So here you are compromising availability as compared to standard storage class, but you are charged at the lower cost for this. There is a minimum 30 days of storage period in case of nearline storage class. So even if you delete your data in less than 30 days from nearline storage class bucket, then you will have to pay for minimum 30 days. Nearline storage class also incurs data access charges in addition to data storage charges. Cold line storage class is more ideal choice for storing data in bucket where you plan to read or modify data at most once a quarter. This storage class is even more cheaper than the nearline storage class, and there is a minimum 90 days storage period in case of cold line. So even if you delete your data in less than 90 days from cold line storage class bucket, then you will have to pay for minimum 90 days. It also offers less availability as compared to standard storage class. In single region, it provides 99% availability, and in case of dual region or multi-region, it provides 99.9% availability. Last storage class available in GCS is Archive Storage Class. Archive Storage Class is the lowest cost, highly durable storage service for data archiving or disaster recovery. Unlike other cloud storage classes, Archive Storage Class has no availability SLA, though the typical availability is compared to nearline storage class or cold line storage class. Archive Storage Class also has the highest cost for data access operations, and it has 365 days of minimum storage duration, but storage cost is lowest among all the storage class. Some of the use cases where you should use archive storage class is storing the data for the legal or regulatory compliance reasons, where you need to store data for longer duration, but you rarely use such data. You also prefer to use archive data storage for the disaster recovery option. You should always keep one thing in your mind, that you can change the storage class of your bucket after bucket creation, but changing the default storage class of a bucket does not affect any of the objects that already exist in that bucket. New storage class will be applicable for new objects only. If you want to change the storage class for your bucket, then you should go to the configuration tab of your bucket and then click on this edit icon over here. Here you can select any storage class for your bucket, but keep in mind that this change will be applicable for new objects only. Older objects will remain in the previous storage class. Also note that choosing the storage class affects the data availability in your bucket, but all the storage classes provide the 11.9 durability. Whenever you need to choose the storage class for your use case, you should do some math by considering both storage cost and data access charges. The standard bucket type do not charge at all for the individual object access, but its storage cost is quite high. Like if you consider the data storage cost and the data access cost as shown over here, storing the 10 terabytes of data for a year would cost around $24 in a multi-regional storage class bucket. But in case of cold line, this cost is only $1.44. And accessing the same 10 terabytes of data once each day of the year would cost nothing in case of multi-regional bucket, but you need to pay $730 as the data access charges in case of cold line. If you sum up both the data storage cost and the data access cost, then it is very clear that it is not a good choice to use the cold line storage class for the hot data. In addition to this, there will be egress network traffic charges as well in case you want to read the data from GCS. You can create lifecycle rules for the objects inside your bucket. These lifecycle rules help in supporting very common use case where you want to save your storage cost for your data by downgrading its storage class to lower storage class. It also helps in setting the time to live for the objects stored in a bucket. Like whenever you create a new report in your application, you will save that report in standard storage class on day 0 because most likely it will be accessed very frequently by your business team for few days to analyze that report. So it will be hot data for some time, but after some time it will be rarely accessed. So you do not like to pay higher charges for this report by storing it in standard storage. It would be better to downgrade its storage class to nearline storage class or cold line storage class to save the cost. Similarly, after 1 year, you can move this report to archive storage and keep it there for the 7 years for the regulatory purpose. After 7 years, you no longer need this report. So after that, you can remove it from GCS. You can manage such kind of life cycle either manually or via some scripts, but it is tedious to manage life cycle of objects this way. GCS provides a very easy way to create lifecycle rules in your bucket that will manage the lifecycle of the objects automatically for you. To add lifecycle rules for your bucket, you need to go to your bucket and then select the lifecycle tab over here. After that, you need to click on Add a Rule button. Each rule that you create has an action and it can have multiple conditions. If you specify multiple conditions in a rule, then an object has to match all of the conditions for the action to be taken. In action, you can either change the storage class for your object or you can delete the object. Conditions specify when to apply the rule that you define. Like here, you can see list of possible conditions. It can be based on the age of the object. Here, you can define the age in number of days. If you apply rule that is based on the date of creation of the object, then you can use this particular condition. Similarly, there are other conditions as well, and rule is applied only if object matches with all the conditions defined in the rule. Now let me add a rule that will move the object from standard class to nearline class after 30 days. For this rule, select this particular action and I will define the condition based on the age of the object. Here I will specify the age in number of days as 30 days. Now I will click on create. So here my rule is created that will move the objects inside this bucket from standard class to nearline storage class after 30 days. Similarly, you can add other rules as well in this particular bucket. Data is very critical asset for any organization, so its security is also paramount concern for them. So whenever you store an object in your bucket, it is private by default so that it is not accessible to any outsider. When you create a bucket in GCS, you need to choose how you want to manage the access control. You can either select the fine-grained access control or you can select the uniform access control. If you select uniform access control, then you can define access control at bucket level only using IAM, and whatever permission you define at bucket level, it will be applicable for all the objects inside your bucket. On the other hand, if you select the fine-grained access control, then in addition to the bucket level access control, you can also define access control list at the object level. You can define members and assign roles to them at the organization or project or bucket level, or you can define access control list at object level. If you have objects that contain sensitive data such as personally identifiable information, then it is recommended to store such data in bucket with uniform access control. Because if you use object level permission control in such cases, then there is a high chances of setting up permission incorrectly and someone can access the data which should not be accessible to that person. Like here, two users Max and Bella have read access on their respective buckets only, and access control is defined at the bucket level. This way, security is enforced uniformly for all the objects inside their bucket. This way, both Max and Bella cannot see each other's data. If we try to use the object level permissions to mimic this behavior as shown over here, and these permissions are not defined correctly for all the objects individually, then it can lead to the data security issue. If you look at your bucket that you created previously, then you will observe that by default access is controlled by fine-grained access control, and you can enable uniform access if you want to do this. To enable uniform access for your bucket, click over here and then you can select the uniform access. But notice one thing, that once you make this switch, then it will become permanent after 90 days and you will not be able to switch back to the fine-grained access after this. To define bucket level access control, here you can add members by clicking on the add button. Here you need to give the email ID of the member. This member can be individual user or a group. Next, you need to select the role for the user. Like if you select the object viewer role over here, then this user will be able to see all the objects in your bucket. You can also assign multiple roles to the same member by clicking over here and adding the another role for the member. If you click on this checkbox, then this member will receive notification for the role assignment. Once you define all the roles for the member that you have added over here, you can click on the save button, and this way you can assign the roles to the members over here. Now let's go to the objects list of this bucket and see how we can change the permission at the object level. To change the permission at the object level, click over here and then select the edit permissions option. Here you can define your object level access permission. If you want to add more entries into this list, then click on add entry button, and then you can define the entries for the another user over here. Whenever you create a new object in cloud storage, by default this object is private. It means there is no way for the other user to view this object. Like if you see the detail page of this object, here you can see the URL of this particular object. Now copy this URL. Now try to access this object using this particular URL. Here you are able to view this object because you are already logged into the Cloud Console. Now let's try to access the object in some other browser using the URL. This time you are not able to access this object using the same URL because this object is private and it is not allowed to access this object by anyone else. Now question is, how can you make this object public so that it can be accessed by anyone? To make an object public, you need to change the object permission. Here you can make this object public by giving the read permission to the all users or the all authenticated users. This time I'll give the read permission to the all users. Now click on save button over here. Now I got one more URL for this object. Using this URL, anyone can access this object. Let me copy this URL. Now I will try to access this object using this URL. So this time you are able to access this object using the public URL. Also notice the difference between both the URLs. This URL starts with storage.cloud.google.com, then followed by the bucket name and then object name. On the other hand, this public URL is storage.googleapi.com followed by bucket name and then the object name. Sometimes you may get question in exam which is just based on the URL pattern. Now I will revoke the public access permission from this object. To revoke this permission, click over here and then click on save button. Now you can see that I do not have the public URL once again. So I cannot access this object using any public URL. This is how we can make one individual object publicly accessible. But what we should do to make all the objects publicly accessible in a bucket? You can make all the objects in bucket public by changing the bucket level permission. Now I will give the object read permission to all users for this bucket. This time I will select the object viewer role and now I will click on save button. Now click on allow public access. This way you can make all the objects public in this bucket. Let's check the detail of this object. Now once again I have the public URL for this object and anyone can access this object using this URL. There is one more way to make all the objects in a bucket publicly accessible for the internet user. You can use this feature to host website with static web content via cloud storage. What you can do is you can put all your static web content in your cloud storage bucket and then put the load balancer in front of it. Here your bucket will act as a backend service for your load balancer. You can also register domain name and use DNS to access your website using registered domain. This way, you don't need to give direct public access permission at bucket or object level, but still all the objects in your bucket will be publicly accessible for all internet users. You can control access to your objects inside your bucket via controlling permission either at the bucket level or object level. But in many applications, your organization users are not the only one who need access to these objects. Sometimes third-party applications or the end users themselves may need to access these objects. If you give them object viewer role, then it will be very difficult to keep track of all of them and it can lead to errors. A simple solution to this problem is to give them the public URLs, but that would only give them read-only access to these objects. If you want to provide read, write, and even delete access for a certain length of time, then the solution is to use the signed URL. These signed URLs are time limited and you have to specify a period of validity while creating these signed URL. For example, if you want to allow anonymous user to download a video file for a predefined time, then it will be easier and more efficient to give such access via signed URL. These signed URLs are used to give time-limited resource access to anyone, regardless of whether they have a Google account or not. These signed URLs enables you to allow visitors to download a file from your bucket when you do not require users to have a registered account. You can see one such signed URL as an example over here. Signed URLs contains authentication information in their query string, which allow users without credential to perform specific action on a resource. When you generate a signed URL, you specify a user or a service account which must have the sufficient permission to make the request that the signed URL will make. Once this signed URL is generated, then anyone who has this URL can perform specified actions such as reading an object within a specified period of time. When the request to access an object is received, cloud storage will verify that the signed URL was issued by a trusted service account, as it will delegate its trust of that account to the holder of the URL. There are some security concerns as well, and you should be aware of these security concerns. Once you give out the signed URL to anyone, then it is out of your control. So you want the signed URL to expire after some reasonable amount of time. You can create signed URL for any object by using the gsutil signed URL command. Here, this private key belongs to any member who has access to this bucket, and this member could be a user or a group or a service account. Here, this 10M represents the time of validity for this URL. You can specify this duration in either seconds, minutes, hours, or days. This is all about the signed URL in cloud storage. You have already seen how to create, update, or delete objects in cloud storage. In addition to this, you can enable object versioning to protect your cloud storage data from being overwritten or accidentally deleted. You can also enable versioning at bucket level for all the objects in your bucket. Once you enable versioning for the objects, cloud storage will automatically archive current live version of the object each time you replace or delete a live object, and current version object becomes the live object. Each of this version has the same name but uniquely identified by their generation number. While enabling versioning for the object, just remember one thing, that object versioning will increase the storage cost because multiple copies of the same object will be stored in cloud storage once versioning is enabled. Cloud storage uses two properties that together identify the version of an object. First is the generation that identifies the version of the object's data, and the other property is the meta generation that identifies the version of the object's metadata, and it is incremented each time metadata of the object is updated. Currently, versioning cannot be enabled from Cloud Console. It can be enabled from command line only. Here, I have shown some of the most commonly used commands. Like if you want to enable versioning for your bucket, then you can use gsutil versioning set command to enable the versioning for your bucket. Now let's try these commands in Cloud Shell. First, let me enable versioning for my bucket. So this is how I can enable versioning for my bucket. Now to check the versioning status of your bucket, use the gs versioning get command. So here you can see that the versioning is enabled for my bucket. Now let's get the list of all version object inside this bucket. So it gives me the list of version object inside this bucket. Here this highlighted number represents the generation of this object inside your bucket. It uniquely identifies the version object in your bucket. You can also copy a particular version of an object to another bucket using gsutil copy command. This is how this version object is copied to second bucket. Now I will add another version of the same object in this bucket. Now again get the list of all version object in same bucket. So here this time you can see two version object in the same bucket, and each version object is uniquely identified by their generation number. If you want to see just the live object, or you can say the latest version object in your bucket, then use the same gsutil ls command but without -a. Here it will show you the list of currently live object in your bucket. This is how you can use versioning using Cloud Shell. While using versioning, just remember one thing, that you can turn versioning on or off for a bucket at any point in time. If you turn off the versioning, existing object version in your bucket will remain same as it is. However, it will stop accumulating any new version for the objects. Data in GCS bucket is always encrypted both in flight and at rest. And whenever you create a bucket in GCS, you can specify how to encrypt this data. There are two ways to manage the encryption of your data in GCS. First is the Google Managed Key, and second option is Customer Managed Keys. Google Managed Key is the default option which works right out of the box for you. In this case, encryption occurs using Google supplied keys, and these keys are created, managed and rotated by Google, and you need not bother with the data encryption at all. Second option of managing the key is the customer managed keys. And in case of customer managed keys, customer uses a specific GCP service called the Google Key Management Service to store the keys on the cloud. So in this case, keys are persisted on the cloud and the key protection is performed by Key Management Service. Whenever any organization plans to migrate its application from on-premise or other cloud to Google Cloud, then one of the major challenges is how to transfer existing data residing outside to Google Cloud storage. To solve this concern, Google Cloud provides various options to transfer data to Google Cloud. Whether you want to transfer 1 GB of data or 1 petabyte of data, Google provides tools to transfer your data into Google Cloud. You can transfer your data from both on-premise or other cloud provider like AWS. Google provides data transfer tools like gsutil, Data Transfer Service, Transfer Appliance, and BigQuery Transfer Service. Whenever you need to plan for your data transfer to cloud, you must evaluate some factors like cost of data transfer. It can include network cost, cloud storage cost after data transfer, cost of tool used, admin cost of data transfer. Next factor that you must think about is the time that it will take to transfer your data from source to destination. Like if you use 1 Gbps network and you want to transfer 1 gigabyte of data, then it will take around 8 seconds. But if you plan to transfer 100 terabytes of data on the same network, then it can take up to 12 days. And transferring such huge data set can really test the limits of your infrastructure and potentially cause problems for your business. Next critical decision is whether you should use the offline mode or the online mode to transfer your data. You must choose between transferring over a network, whether it's a dedicated interconnect or public internet, or transferring by using the storage hardware like storage appliance. In addition to this, you must always ensure data security and data integrity as well while doing your data transfer. For this, you should do pre and post validation of your data transfer. You should also plan for the regular backup of your data. All these are the difficult questions to answer, and you can always use this transfer calculator in making such decisions. You can play around with this calculator, and based on your inputs like size of data, network bandwidth, it will give you some idea about the time and the cost involved in the data transfer. I have given link for this calculator in the resource section. These are the Google's recommendations which you can use in deciding the right data transfer tool for yourself. Like if you want to transfer few terabytes of data from your own premise data center to Google Cloud and you have enough network bandwidth, then you should use the gsutil command line utility to transfer your data. But if data in your own premise data center is more than few terabytes of data, or you want to transfer data from other cloud provider to Google Cloud or between two buckets in the Google Cloud itself, then you should use the storage transfer service. Storage transfer service allows you to quickly import online data into cloud storage, and using this you can also set up repeating schedule for transferring your data. In case of storage transfer service, data source can be another cloud storage bucket, or it could be another cloud provider like AWS, or it can be HTTP or HTTPS location as well. To use data transfer service, you need to go to data transfer option from here. You can use data transfer service to do the data transfer from cloud or from the on-premise data center. So let's use the cloud option this time and click on create transfer. Here you need to create a transfer job, and to create transfer job you need to provide primarily three information. First is the source, second is the destination, and third is the time when you want to initiate the data transfer. In case of source, these are the options for you. You can use the Google Cloud Storage bucket or AWS S3 bucket or Microsoft Azure storage container, or you can also provide the list of object URLs. So let me select one source bucket over here. Now click on continue. Here you need to give the destination bucket. So let me select this as the destination bucket. Now click on continue. Here you can define the time when you want to run this transfer job. You can either run this data transfer immediately or you can schedule it for the later time as well. Once you provide this whole information, just click on create and it will create a transfer job for you. In case you do not have enough bandwidth to meet your project deadline or you want to transfer very large amount of data, then you should order transfer appliance from Google. Transfer appliance is a hardware device that allows you to quickly and securely transfer large amount of data to Google Cloud Platform via high capacity storage server that you lease from Google and ship to your data center. To order transfer appliance from Google, you need to fill up this form and submit your request to Google. Another data transfer service provided by Google to transfer your data from cloud storage to BigQuery is the BigQuery Data Transfer Service. BigQuery Data Transfer Service supports various formats like CSV, JSON, Avro, Parquet, and ORC. In addition to these data transfer services, there is one more way to do the data transfer, and that is via offline media import. Offline media import is a third-party service where physical media such as storage arrays, hard disk drive, tape, and USB flash drives is sent to a provider who uploads the data.